Hello all, my name is Shivam and I'm going to deliver you this course which we have created for the beginners, a machine learning course for the beginners. And this course is very beautifully designed and structured for the beginners, even for those who wants to get into this field, who wants to get into the field of data science, machine learning and AI. Because we have developed the this course, and this course consists of the mathematical aspect, the theoretical part, and as well as we also include the real time projects which with on the real world data set. Okay, so this actually helps you to get the theoretical knowledge, to get the mathematical aspect of the machine learning along with the real time data, along with the real time projects. Now I am having 7 years of experience in teaching. Along with, I am working on the same domain. I am working as a machine learning researcher from last 7 years. So from my experience, I have created this bundle for you. This course is definitely going to help people who wants to develop their career, who wants to build their career in field of machine learning and artificial intelligence. Now, what we are going to cover in this 6 hours or 6.5 hours of session, we are going to first I am going to talk about the introduction. Okay, then I'm going to cover the Python in 2 chapters. Okay, so I'm going to cover maybe data types and all the basic steps of Python, along with loop making control statements and functions. Then another 3 chapters is all about the Python modules, which is used for data science. Okay, so that is Numpy, Pandas, and data visualization part. After this, we jump into the machine learning section. So I give you the introduction, I give you the workflow, that how machine learning model build, because the workflow or the stages of a machine learning model is always same. Then I'm going to talk about the regression. I'm going to talk about the classification. So there are different algorithms. It means like the regression or classification, which I have mentioned, it consists of different algorithms. And with that algorithm, we can try to build a model. We can try to solve real world problems. At last, I will give you the end-to-end machine learning model deployment. Okay, so we are going to discuss about end-to-end machine learning model. End-to-end means we are going to deploy our model by using a web API. So you are able to push your input and you are able to see the output at a real time. Okay, so this is what we are going to implement at the last. Fine. Now, if I talk about the artificial intelligence, so artificial intelligence is a broad capability of machines to perform the activities using human intelligence. Okay, so it means that whatever the things, whatever the like idea, or whatever the you can say whatever the whatever the things which human can perform, we are trying to teach a machine to perform the same thing, but with a high accuracy, with a better ease. Okay, so like if we take an idea of self-driving car, so definitely human have a capability to drive a car, but we are trying to automate the system. We are trying to make our life easier. So and that is why we are trying to teach machine. We are trying to teach a car that how it can drive the car by their own without having a human intervention. Okay, so this is all we know. This is all we can call it as a artificial intelligence. Now, machine learning is a subset of an artificial intelligence which allow computers to automatically learn and improves from the experience without being explicitly programmed. Okay, so what does I mean by without being explicitly programmed? So we are trying to teach computers the pattern. Okay, so every data consists of some patterns. Okay, so we are trying to generalize that pattern. We are trying to learn those patterns only, and based on that patterns, we are trying to make decisions, and we are trying to make predictions for the future data. Okay, so it the main idea, the main concept of a machine learning is all about pattern recognition. Okay, so we are trying to discover the pattern, we are trying to get the pattern, and based on that pattern we are trying to decide that what may be the possible output, what may be the possible thing which can be which can be happen in a future, which can like we are trying to make our prediction. Now for making any machine learning model, for any data science model, we always need a data. Okay, so data is a more important thing. As I told you that every data consists of a pattern, and this is the main idea behind machine learning, which is called a pattern recognition. Okay, so pattern recognition is only possible when we have a data. Okay, without data we can't do anything. Okay, so whatever the problem statement we are having, so suppose someone gives you the problem statement that try to build a model which is called spam classification or spam filtering, so that and that model can classify in between spam and non-spam mails. Okay, so definitely you guys are also receiving a spam mails a lot of time, and you guys are having and definitely we are having a true mails also. So we don't want to waste our time to classify this thing manually. We want to build some kind of a system, we want to build some kind of a model which automate this thing, which can do this thing for us, which can automatically classify. So as soon as it receives the mail, it can automatically classify whether our mail is spam or not. Okay, so for that, for that particular model, for the to solve that particular problem, we need a data, we need a historical data, we need a model needs a experience. Okay, and experience comes from a data itself. So we need a past data where we have a lot of meals in our, so data consists of meals, historical meals, past meals, and that meals consist of a true meals also, along with the spam meals also. And now our job is to feed all those meals to our machine learning model. And the job of our machine learning model uh, is to decide, okay, so now if there any new mails comes into the existence, so we have an ability to decide whether this new mail is spam or not. Okay, and so the most important thing is a data. We always need a data, we always need an experience to build our model, to continue our task. Now, to build a machine learning model, to build a machine learning model, we need like a library, we need a language. Okay, so there are a lot of language around us. We have a C++, Java, then we have a JavaScript, then we have a R language. So there are a lot of languages, there are so many languages around us. But you can see that Python getting a popularity after 2016 or 17, when this machine learning or when you have this deep learning model, when you heard about this kind of a thing is becomes a buzzwords. Okay, so maybe after 2016 or after 2015, this machine learning becomes a buzzword. And people are like a lot of people are trying to get their trying to get the job in field of machine learning. Like a lot of problems people are trying to solve are able to solve with the help of machine learning, with the help of deep learning concepts. And I think nowadays in a today's scenario, there is no field which is left. Like maybe it is a field of market, stock market. So whether it is a field of stock market, whether it is a field of you can say a medical analysis, healthcare system, or maybe a climate, or maybe your daily to daily life use case. So each and every place, I think we are surrounded by like a machine learning and artificial intelligence techniques, or maybe applications. So we need a language, so that we can solve this problem. We can like create our machine learning model efficiently. Okay, we don't want to waste our time, we don't want to waste lot of time in terms of coding itself. Okay, so we want some kind of a language which can make our life easier, which can solve that mathematical stuff for us in just with just few lines of a code. So Python is having that ability. Python is having that ability because it is having a huge amount of libraries. So you can see that it is having a easy data extraction and effective data management. So we can extract the data. Definitely we need information from the data itself. We need to explore the data, we need to extract the data, we need to discover the pattern in data. So we always need to explore our data, and we need to explore so for that we need a kind of a library which can help us in the data exploration job. So Python is having those library which will help which help us in case of data exploration. Second, we need to do a lot of mathematical calculation, we need to do a lot of numerical calculations. There also Python help us. So Python helps us to do like a very, you can say, a very heavy mathematical calculation, a very like complex mathematical calculation in just a single line of a code, or maybe few lines of a code. Python is having a very huge machine learning and deep learning libraries. And along with all these applications, along with all these libraries, Python also helps us. Python also have a library to deploy our model, to make an web API. So these are all the things which can be solved with just a single language, which is called Python. Okay, so this is one stop solution for all your problems, for all your machine learning stuffs. So that is why we are going to use Python. So now we are going to start our journey. We are going to so I think we are good to start our journey. So first we are going to install the Python. We are going to install the required things. So we need to install the Anaconda, we need to install Python from the python.org. And definitely I'm going to code in a Jupyter notebook. So I will explain you one by one that what is the Jupyter notebook and all after installation. And so let's start. I think we are good to go. So I think I need to switch my screen, and I will show you that how you can install the Anaconda, how you can install the Python, and then how we can code these things on a Jupyter notebook. Install the Python. Okay, so you can install Python from just by going python.org, and you need to type python.org/download. Okay, so from here you can download the Python, or you can download the latest version, or but my suggestion is you need to download the the 3.8 version. Okay, so because the new version may be having some kind of stuff, so which is not maybe inside Anaconda, which we are going to use. So we need to use version 3.8. Okay, so I suggest you to download this 3.8 version of like a Python. So you can install any version of 3.8, 3.8.12, 3.8.11, 3.8 point any version. Okay, and based on your configuration. So if your configuration, okay, so if you're having a Windows, so you can download it for Windows. If you are having a Mac OS, so you can download it for Mac OS. So and based on your configuration, or whether is you are having a 64-bit or 32-bit. Okay, so you can install Python from here. And then for an editor, so there is a like a different kind of editor available on an internet, on which we can build the like Python modules or Python thing. But the best editor where for the beginners, okay, so for the beginner or as a beginner, where from where you can learn, so that is Anaconda. Okay, so Anaconda, and inside Anaconda there is one thing called a Jupyter notebook. Okay, so you need to go this Anaconda download, and then you need to install Anaconda from here. Okay, so if you click on this,
So this is available for all three versions, like for Mac OS, and then for Apple users, and then Windows and Linux. Okay, so you can install the Anaconda from here. And after installing the Anaconda, after installing the Anaconda, you are able to see this kind of a page. Okay, so I think, yeah. So after installing the Anaconda, you need to write on the search bar, you need to write Anaconda Navigator, and you are able to see this kind of like page. Okay, so what you can do, so you can stop the video, and you can install like Python and then Anaconda, and that is not a like very big thing. If your internet speed is fast, so you can download it in like maybe in 5 to 10 minutes. Okay, so after installing, you need to launch this Jupyter notebook, and you can read the documentation of Jupyter notebook. So it is a web-based interactive computing notebook. So here you can build your model. Here you can write your code, and along with the code you can write a markdown. So like each and every functionality is available over here. So this is a like best thing. The notebook is much better in comparison to any other like editor. So you can launch this notebook from here itself. And after launching this notebook, so it will push you onto the home directory. Okay, so if you launch this notebook, so you are able to see your home directory. So this is the home directory. And now inside your home directory, you are having different directories like desktop, then documents, then downloads. So these are the like different directories available. And now what you need to do, you need to click on the this download directory. Okay, so not in a download directory, you can create a kind of a folder anywhere. Okay, so I just create a like a folder AI session in this download directory. You can create your AI session if you want to create with this name, or you want to create with any other name. So you can create a folder over there. Okay, so you can create a folder in a document or desktop, wherever you want. Okay, so I just create over here, and then inside this I create one more folder, Python recap. So I want to I want everything at one place. So that's why I create a folder with AI session. And then inside AI session, I want to have a different like folders Python recap, then maybe linear regression. So according to the chapters. Okay, so according to chapters, I am going to arrange it. Now inside a Python recap, so you are able to see that there is no notebook. The notebook list is empty because we didn't create any notebook till now. So you can create your own new notebook. Okay, so you need to click on the Python 3, and you are able to see this kind of a notebook. Okay, so this is what we call a Jupyter notebook. And now you can change the name of your notebook. So you can mention it like Python recap, okay, or whatever you want. Python recap maybe 1, and now you can code whatever you want over here. Okay, so inside a Python, you can write your code in like any format. Okay, so Python supports all the three kinds of programming. Okay, so it supports a like a scripting way, it supports a functional way, and it supports a object oriented way. Okay, so so whatever the way you want to code, you can code. Okay, so now the very first thing inside a Python is and which is and a kind of a basic thing which you need to learn for like a machine learning, or to like for a future stage, is your data types. Okay, so Python is having 6 different kinds of a data type. Okay, so and the very first thing, you want to check whether your notebook is running well or not. So you can perform any kind of arithmetic operation, and you can check those things. So 1 plus 1 is equals to 2, and here you are able to see that 2 is written. So means my notebook is is good. Now the 6 different data types are strings, tuple, then numbers, list, dictionary, and sets. Okay, so these are the 6 different data types which are available inside a Python. So one by one, I am going to discuss those with some basic concepts of programming. So maybe okay. So if I start with a string, so and Python is able to recognize, okay, what kind of a data type is this. Okay, so we need not to mention that str, or we need not to mention int. Along with that, Python is able to recognize by itself. Okay, so suppose if I write something, and then the like the thing where we store this string or any other data type, so that is called a variable. Okay, so this a is a variable, and inside this variable I'm going to store something. Okay, so I'm going to store like maybe a string, so maybe hello Python. So this is a kind of a string. So anything inside like a single inverted comma or a double inverted comma is considered as a string. Now if I run this and if I try to check the type of this a, so this is nothing but a str. Str means string. Okay, so this is a simple concept, and Python is able to recognize, Python is able to identify with the signature whether the the like things, whether the data is in the form of a string or list or tuple or dictionary, anything. Okay, now suppose if you want to check, okay, so suppose if you want to like perform some kind of a stuff with this string, so yes, you can easily perform. Like if you want to check the length of this string, so yes, it's pretty simple. The length of this string is nothing but 12. Okay, now if you want to check if you want to access any value, any particular value from this whole string, so maybe if you want to access this p, so you can access this p by its index value. Okay, so what is the index value? So index value is start from 0, and then you are able to count those index values, so 0 1 2 3 4 5 and this way. Okay, so now if you are and this space in this space is also countable. Okay, so the index value of p is nothing but 0 1 2 3 4 5 and 6. Okay, so now if you want to access this p, so you need to write a of 6. Okay, so in this way you are able to access any single value from a complete string. Okay, now if you want to slice like a number of characters, okay, so suppose if you want to if you want to access pyt all together, okay, so or maybe pyth all together. Okay, so if you want to access these 4 characters together, so what you can do is, so you can write the first index value. So the first index value is nothing but 6, and then you can write okay, so the last index value. Okay, so the last index value is what? 6 7 8 9. Okay, but so this is a lower bound and this is the upper bound. So upper bound is excluded. So if so the upper bound is excluded, so that's why you need to use n plus 1. Okay, so if the last value is 9, so you need to use 10. Okay, so pyth. So this is what we call as slicing. So in this way you can access a single character, or you can access a multiple character by using this by using this square bracket. Okay, now there are like some built-in functions inside this Python. Okay, so suppose if you want to like lower each character. Okay, so if you want to convert into the lowercase character, all as you can see that h and p is in the uppercase. So what you can do, you can simply use a dot lower. So all the characters are converted into the lowercase, and if you want to convert all the character into the uppercase, so you can use a dot upper. Okay, so these are like simple operations or simple functions inside a string. Now if you want to perform okay, so these are like some simple functions inside string, and there are like some functions which you can see from its signature. Okay, so if you press a dot and then if you press tab, so you are able to see like these are all the functions available inside a string. So like if I take maybe one more function, so if I want to take if I want to check the index value of any particular character, so maybe if I want to check the index value of y, so I can write y over here, and the index value of y is nothing but 7. Okay, so and one important character of string is so string is always a immutable. So immutable means if you want to like change any character. Okay, so if you want to change any character by with the help of that index value, so you're not able to do that. So suppose in place of p, okay, so because p is available on the sixth index value, so in place of p, suppose if you want to enter s, so it gives you an error. Okay, so it gives you an error that str object does not support item assignment. Okay, so this happens because string is immutable. String is not a mutable thing. Fine. Now if I take another example, okay, so now if I talk about another kind of a data type, so another kind of a data type is nothing but a numbers. Okay, now if I talk about the numbers, so yes, you can perform any kind of arithmetic operation with the numbers. So as we saw earlier, so suppose if I want to um, like if you want to add two numbers, so yes, you can add. If you want to like subtract two numbers, so you can subtract. And similarly, Python can recognize that this is nothing but a integer. So if you try to check type of d, so type of d is nothing but an integer. Okay, in a similar way, in a number you have different kind of a number. So maybe you are having a floating point integer, so 0.9 is a kind of is a floating point number. So if you try to check the type of this 0.9, so this is float. And in similar way, you can also have a complex number. So suppose if you write something 8 plus 9j, so this is nothing but a complex number. So suppose if you try to check the type of c, so this is a complex number. Okay, now if you have anything in the form of true or false, so that is what we call the boolean. Okay, so suppose if I try to write true, so this is a boolean. Okay, so suppose if I store it somewhere, I is equals to true, and if I try to check the type of I, so the type of I is nothing but a bool. Okay. So yeah, Python supports all these kind of a thing, and everything or every what you can say, every kind of a data Python is able to recognize by with the help of a function which is called type. Okay, so fine. I think these are the like some basic stuffs in Python. Now the next kind of a data type is nothing but a tuple. Okay, so how you are able to recognize a tuple? So suppose if you are having any kind of a data type. Okay, so if you are having any kind of a data, okay, maybe a string or okay, so this tuple, list, and dictionary is also considered as a data structures. Okay, so why they are considered as a data structure also along with the data types? Because they are having a capability to store a different kind of a data. Okay, so like inside a tuple, you can store a string, you can store integers, and then you can store a floating point numbers. Then you can also store any string. Okay, so maybe Shivam. So yes, you can store all these things together inside a tuple, and this is a signature of tuple. So if you write these things inside a parenthesis, so that it becomes a tuple. Now if I try to check the type of T. So the type of T is nothing but a tuple. Okay, so it's very easy to understand with the help of a signature. So if any like a value is inside a parenthesis, so it becomes a tuple. Now in a similar way, as you are doing in a like slicing, so in a slicing you are trying to or sorry, in a string you are trying to access any element with their index value. So in a similar way, suppose if you want to access any value, maybe 2.8, so you can access 2.8 with the help of this index value. So index value of 2.8 is nothing but 3. Fine. In a similar way, you can slice maybe couple of values with the help of by putting the index value inside a square bracket. So suppose you can slice some numbers in this way. Okay, so we are able to slice 9, 2.8, 9.6 by using this slicing operation. And just like string, tuple also having some built-in function like len and then max, mean. So max is used for finding the maximum number, mean is used for finding the minimum number. And similarly, like a string, it is also having same kind of a property that tuple is also what you can say immutable data type. Okay, so it is also a like immutable data type, so you can't change anything in between. Okay, so suppose if I want to like in place of 9, so in place of second index value, so in place of 9, and if I want to put any other integer, so maybe 92. Okay, so if I want to put this 92 over here, so it gives me an error. Okay, so it is also having a same property that it is a immutable data type. Okay, now if I talk about the list, so how we are able to recognize, how Python is able to recognize a list. So list can be recognized with the help of its signature. So if I anything which is inside a square bracket. Okay, so just like a tuple, so tuple is inside a parenthesis. Now list is inside a square bracket. So if I make a square bracket with the and put some numbers, so 3, 5, 6, 8, and then 9.3, and then maybe a string. So this is a list. Now if I check the type of this L, so this is nothing but a list. And similarly, if I want to access or if I want to slice, so yes, I can do by using the index number. And but list is also having some extra what you can say some uh, extra functions. Okay, so in comparison of tuple, list is having a more number of functions. Okay, so yes, we can like discuss those functions. So and those functions are like really important. Like one function is like called append. Okay, so append is what append is denoting to the add. Okay, so if you want to add anything in this list, so you can use a append. Okay, so suppose if I want to add any number. Okay, so if I want to add 87 at last, so we can use append, right? And suppose you have a to list and you want to if you have like maybe a to list and list 1, and then you have a list 2. Okay, so suppose you have two lists and uh, you want to extend the first list with the value of the second list. Okay, so means extend means it is extend the first list with the value of second list. So 5, 6, 7, 8, and then inside a list 1 itself you are having 4 more values, 6, 7, 8, and 1. Okay, so this is what happened inside a extend operation. Then there are different kind of operation, like if you want to drop any suppose if you want to like reverse this list, so you are having a reverse operation. If you want to drop any value, so you have a pop operation. Okay, or if you want to remove any value, so you can have a remove operation. So these are all operations available inside a list. And then one very important property of a list is what? So lists are mutable. Okay, so tuple and strings are immutable, but lists are mutable. So mutable means what? So suppose in place of like sing, if you want to put Python. Okay, so this index value of sing is what? So 0, 1, 2, 3, 4, and 5. So suppose in place of sing I want to put Python. So yes, I can put. Now if you run this list, so it will become Python. So in place of sing, it replaces the sing with Python. So this is what happened inside a list. Now if I talk about another data type, so another data type is nothing but a dictionary. So inside a dictionary, so dictionary is like represented or identified with the help of a key value pair. So if I try to write a dictionary, so dictionary can be identified with a like a curly braces. So anything inside a curly braces is considered as a dictionary, but it should be in a form of a key value pair. Okay, so key value means so suppose you have a name of any person and then the name, then maybe a registration number. Okay, and then the registration number, you should have a registration number, and then maybe a designation. So yeah, and then you have a designation. So this is what we call the dictionary. And now if I try to check the type of D, so this is a dictionary. Okay, So dictionary is also a mutable data type. So if you want to change any value at any particular time, so yes, you can change. So and for accessing dictionaries, so you can't use a index number. So for accessing any dictionary, you need to access with the help of key. So these are the keys: name, registration, and designation is a key, and Shivam 449 and trainer is a your value. Okay, so suppose if I want to access this, so this is a 449, and if I want to make any change, so suppose in place of 449, if I want to make it 450, so yes, I can make it. Now if you see the dictionary, so here in place of 449 I got 450. Okay, so this is what happened inside a dictionary. Now there are again inside a dictionary also we have different operations. So suppose if I want to access only keys, so yes, we can access the keys, and if you want to access only values, so you can access only values. So this is what happened inside a inside a dictionary. Okay, then there is the last data type is nothing but a sets. So sets are also is also in a curly braces, but again just like a list and tuple, it is having like a continuous values. Okay, so it should have some numbers, or maybe some floating point numbers and all. And one more important concept of sets is, so all the numbers are going to arrange in ascending order, and no number is going to repeat. Okay, so suppose if you run this, and if you try to check the type of s, so this is set, and now if you run s again, if you want to see the set, so yes, you are able to see that your 4 is repeating 3 times in our original set, but here it is not repeating, and your 2 is repeating 2 or 3 times, but here it is not repeated. Okay, so and all the values are arranged in ascending order. So this is a definition of a set. So the values are arranged in ascending order without any repetition. Okay, so these are all the different kind of a data type available inside of Python. And yes, you can explore it more. You can try with some more functions, and you can see that what happened with that function. Okay, but fine. This is all about data types. And yes, you can perform a different kind of a function. Okay, so then it's a basic programming concept that you have some kind of a loop, and then you have some kind of a conditions to run. Okay, so if I talk about the conditions, so those conditions are nothing but those are the conditions are represented in a form of if, elif, and else. Okay, so here the conditions are represented in 3 ways. Okay, so if, elif, and else. Okay, so maybe we have suppose we have any number uh, like suppose we have a number assigned with n. Now if I write if n is equals to suppose 25 or 35. Okay, so yes, this statement is wrong. So you are able to see the number is lesser than 25. Okay. So if you run this, so you're not getting anything, because your statement is wrong. Okay, and if you put like this way, so yes, oh, sorry. So number is actually greater than yeah, this n 45 is yeah, this number is lesser than okay, so this number, this yeah, this number means you're greater than 35. Okay, in a similar way, suppose if this condition is not correct, so you can put one more condition where you can write n is maybe lesser than 35, okay, or lesser than 50, I can say. Okay, and here you can change the signature so that this value becomes false. Now you can print a statement that the number is like lesser than 50. So yes, you are able to see that the condition is wrong. So we come on to this condition, and now this condition is true. So this condition is printed. Now the last condition, if both the condition is wrong, so we can use like the else statement. So we can write over here the both the condition is wrong. Okay. So now I can put 40 over here, and you can see, so 45. Okay, fine. So 45 is lesser than, and is what 45. So, oh, sorry. Yeah. So I need to, so the both the conditions are wrong, then the else statement is printed. Okay, so this is a simple the conditional statement inside a Python. And in a similar way, for a looping, you have a very good function inside, so that you can provide any kind of a loop. So that function is nothing but a range function. Okay, so the range is a kind of a function which where you need to tell that what may be the range of your like what may be the range of your loop. Okay, so suppose you want to run a kind of a loop over anything. So maybe that if you want to if you want to have a range of in between 12 to 13. Okay, so 12 to 13, 2 to 13 means what? It is going to give you a number in between 12 to 13. Okay, so 13 is excluded, and you are able to get 2, 2, 3, 4, 5, 6 till 12. Okay, so suppose if I put this thing inside a list, so you are able to see the output. Okay, so 2, 3, 4, 5, 6 till 12. Okay, so in a similar way, you can try to you can use a different kind of loops. So there is one thing which is called a for loop. So you can apply a for loop. So for I in maybe some range, and here you can give your range. So maybe you can directly provide a range till which point you want to go. So suppose I want to go till 7. So yes, I can write print I in a simple way, and you can see the output. Okay, so 0, 1, 2, 3, 4, 5, and 6. So you can like run this kind of a loop anywhere. So you can run this kind of a loop over a list. You can run this kind of a loop over a tuple. Okay, so anywhere, and then inside this you can perform some kind of operation. So suppose I have a list. So for I in maybe some list. Okay, so 8, 4, say 7, 1, 6, 91, 19, and then maybe 23 and 4. Okay, so suppose I have this list, and I want to extract only even numbers from this list. Okay, so yes, I can give a condition. So if I modulus 2 is equals to 0, then only I want to extract it. So I want to print only those i's where it is able to where it is a even numbers. Okay, so I want to print that. So 8, 4, 6, and 42. So these are the numbers which is like a even numbers. So in a similar way, we have like this kind of like conditional statements, or we have this kind of looping statement through which we can perform this kind of operations. Okay. So like we also have a break statement. So suppose we don't want to run the complete program, we want to break it at some point. So we can use a break statement. So suppose I am having I'm using some kind of a loop. So for I in maybe over any string. Okay, so I can run a loop over a string also. So for I in Shivam, and then I want to maybe break it. Okay, so I want to break it somewhere. So for I in Shivam, so if I is equals to V, then I want to break it. Okay, so break, and then after breaking, I want to print the rest of the things. Okay, so maybe print I. So you are able to see SHI is there, and when I become v, so so at the very first time, at a very first iteration I should be s, then the second iteration I should be h, then on the third iteration I should be I, then on the fourth iteration I becomes v. So as soon as it becomes v, so we want to break the loop and we want to come out of the loop, and now, and this is the like our this is our output shi. Okay, so fine, and these are all the like basic steps which we are able to perform in inside a like a Python. So along with like a break statement, you can see one more statement like in place of a break, if we use so there is one more statement in a Python which is called continue. So if you use a continue, so it only leaves that character and then it continues till the end. Okay, and it is going to print each and everything till the end, just leaving that character apart. Okay, so it just leave like v apart and it prints all other characters. Okay, so this is what happened with the continue statement, right? Okay, now okay, so the next thing which we can check. So these are till now what I discussed with you. So these are doing so here I'm doing just like a programming in a scripting way. Okay, but yes, in a Python you can program your thing in a functional way also. Okay, so that is why that is what we call the functional programming. Okay, no, so now how we can create a kind of a function and how we can uh, put our thing inside a function. So yes, we can observe those things by giving like a functional like a creating a function, and then by calling a function, and then by defining some things inside a function, we can do those things. Okay, so
Hello all. So my name is Shivam, and now I am going to talk about functions. Functions in Python. Still now, whatever the code we have done is in is in the scripting format. Okay, so you just so like you are writing a story. So in a similar way, we are trying to write our code. But okay, so suppose if I want to add two numbers, so what do we need to do? So every time I need to like take two variables, or maybe if I can like add two numbers directly. Otherwise, maybe I need to take two variables and then I just assign a numbers to those variables and then add a put a plus symbol in between, and then I'm able to add two numbers. But now if I try to build the program, if I try to build a program in a functional way, so my code can become my code will become a modular. Okay, so modular means I create a simple function for the summation of two numbers, and after that in future anytime I want to add two numbers, so what I need to do is I just need to call that function, and after calling that function I'm able to add and I need to pass my variables and I'm able to add those two numbers. Okay, so this is what happened if I try to write a code in a modular way, if I try to write a code in a functional way. Okay, so let's start now. In case of a Python, creating a function is a like very easy thing. Okay, so creating a function is very simple to is very simple. So you only need to use like a def keyword. So def is a kind of a keyword to define a function. So now inside this you need to define a function. So suppose the function name is info, and after this or sorry so I just directly create a program of adding two numbers. Okay, so this is my function sum, and then maybe I just pass two numbers. Okay, so a and b. Now these are two variables which I want to add. Now I create one more variable where I just try to add these two numbers, uh, and then I just print like result. Okay, so print result means print c. Fine. Now I need to, okay, so I need to call this function. So for calling a function I can use simple sum again, and then I need to pass a value. Okay, so now here you need to pass a value which you want to add. Okay, so which two values you want to add, you can pass over here. So okay, so now my program is complete, my function is created. So anytime in a future, if you want to add two numbers, so what you need to do is you only need to call the like function with the name of a function itself, and then you need to pass those two numbers. Okay, so this number can be anything, and then I'm able to add my numbers. Now a very important thing which you need to notice is okay, so now these two numbers, so if you add any two numbers, so because my first number is an integer and my second number is also an integer, so if I try to add these two numbers, so this should be the output which I get, that should be always that should also be an integer. And if it is really an integer, so if I try to add maybe anything, okay, so maybe if I try to add like, so 8 plus 6 is 14, and now if I want to add 6 more, okay, so suppose if I want to make it 20, so it will give you an error. Okay, so it will generate an error, and the error is unsupported operand type for a plus operator, none type and int. Okay, so it gives you an error that okay, that you're trying to add two different two different data types. Okay, so whenever you are trying to add two different data types, it will give you an error. Okay, so suppose if I try to add maybe a list and a tuple, so it will give you an error. Okay, so these are the sure things. So and this is what happened over here. Okay, so now if I want to if I really want to make it so what happened actually, the print. Okay, so if I told you that what may be the mistake, so suppose if you try to check this print statement, so and the type of this print statement, so the type of this print statement is none type, and this is what it is trying to say. Okay, so 18 plus 6 means the output 14 is a none type character, okay, or a none type value. Okay, this is not an integer value, and this is an integer value. So the operation, this operation is not possible between two different data type. Now to make this thing possible, what you need to do is you need to like copy this thing. Okay, so suppose if I want to make it possible, so what you need to do is you just, in place of print, you just need to write return and a return C. Now if you are trying to perform the same thing which you tried to perform earlier, so 5 plus 7 is 12, and now if I add maybe 8, so it will give you 20. Okay, so return actually returns your output in a similar data type. Okay, but print tries to return an output in a none type. Okay, so if you try to add any two different data types, it will always give you an error. Okay, so always try to okay, so whenever you are trying to add, maybe whenever you are trying to use an operand, whenever you are trying to use like maybe a plus operator, or maybe a subtract operator, or maybe a multiplication or deletion operator, so whenever you are you are trying to do this, always try always take a two same data type. Okay, so always go with a similar data type, don't go with a like different data type. Okay, now fine. Okay, so now these are like so people are, or people also call it as like a positional argument. And then suppose if I try to give it a, okay, so give some value. Okay, so maybe in place of just b, if I assign a value, so it becomes a position keyword argument. Okay, so position means it tries to take a value according to the position. Okay, so the value of 5 becomes the value of a becomes 5, and the value of b becomes 7. Okay, so this is what happened with the positional argument. Okay, now fine. Now if so this is a simple function. Okay, so this is a plain function or a simple function available inside a Python. Now if I talk about an anonymous function, okay, so anonymous function means what? Anonymous function means a kind of a function, okay, so you are trying to create a function where you actually try to you actually try to complete a complete concept. Okay, so you are trying to complete you are trying to write down the complete concept in a single line. Okay, so whenever you are trying to write down a complete concept in a single line, so that is what we call a inline function, or maybe a lambda function, or maybe anonymous function. Okay, so suppose if I ask you to make a function which through which I am able to I'm able to find the square of a number. Okay, so for that, what you can do is, so you can define a function with a name square, and then here so this is my number n. Okay, so n may be any number which the of which so okay, so n may be any number on which I'm going to square. Okay, and then I can return, because it is a number, so it should be an integer. So n cross 2. Okay, so this is a symbol for doing any kind of a square. Okay, now if I take maybe, okay, so I need to pass that number. Okay, so I need to pass n over here. So the square of 5 is 25. Fine. Now if I want to make this whole function, okay, although this function is also very like easy to understand, because this is just a 3 line of a code, but then also if I want to make this thing in a single line, okay, so if I want to make this same code in a single line, so for that you need to use some kind of a keyword, and that keyword is called a lambda. Okay, so now what you can do, so you can use a variable, maybe like you can assign the whole thing inside a variable. So maybe I can take s denote a square, and then lambda. Okay, so lambda is a keyword, and then so x is a value on which you want to do the squaring, and then just put a colon, and after colon just give the formula for the square. Okay, so for squaring any number, what you need to do is you need to follow this formula. Fine. Now if I try to run s, and inside this s, if I pass any number, so suppose 5, so I get 25. Okay, so oh sorry, this should be passed in a bracket parenthesis, sorry. Okay, so 25. Fine. So this is this is what we call a lambda function. Okay, so this is a lambda function. This is what we call an anonymous function, or maybe a inline function. Okay, now there are like a different anonymous functions which are present. Okay, so okay, so this is like a plain lambda function. Then there is another function which is called a map function. Then there is another function which is called a filter function. So map and filter means what? So map means suppose you have one iterables, like maybe a list or tuple or maybe anything. So what you want to do is in a list you actually want to so suppose in a list you have maybe 4 or 5 elements. Okay, so there are maybe 4 or 5 elements inside a list, and you want to do square of each element. Okay, so you want to do square of each number, or maybe a square of each element. Okay, so so maybe there are numbers maybe 2, 5, 7, 8, and 1. So square of 2 is 4, then square of 5 is 25, square of 7 is 49. So you create a new list, and inside a new list, so you generate a new list from the existing list, and now inside this new list you have a square of each number. Okay, square of each element which is present in the original list. Okay, so that is what you can do. Yeah, if, you can create like a function, and then there may be multiple lines of code. But if you want to create this kind this kind of a thing in a single line, so for that you can use a simple map function. Okay, so yeah, just go for it. I think it's pretty easy to make this kind of a scenario. Okay, with the map function. So suppose I can create a list inside a function, even I can create a list outside a function. Okay, so just for your understanding, I am trying to create a list outside a function. Even it is very simple to create a list inside a function. Okay, now I want to return a list, and this list should be a new list, and in this new list I want to map one function. Okay, so lambda. So I need to use lambda, and I want to multiply each number. I want a square of each number, and where I want to do this thing, where I want to perform this task, I want to perform this task over this list, this L. Okay, so so this is how you are able, you can do this. Okay, so what you can do, you can copy this list, you can use this list here itself. You don't need to you don't need to have an extra line of code, or else you just need to assign L. Okay, so I think you are able to understand. So this is your new list, and so the square of 2 becomes 4, square of 3 becomes 9, square of 5 becomes 25, 6 36, 7 49, 1 1. Okay, so this is what we call a like a map function. Okay, now if I try to try to show you the filter function. So as the name suggests, the concept of filter function is pretty easy to understand. So suppose from this similar list, okay, so from the same list which I have right over here, so I want to filter only the even numbers, or maybe I want to filters only odd numbers. Okay, so yeah, you can do that. Okay, so again you need to do the same thing. Just instead of a map function, you need to apply a filter function, and then you need to change the condition, because here you are doing some kind of an operation, and in case of filter you need to do some kind of a you need to add some kind of a condition. Okay, so yeah, it's easy to write. So what you need to do is, so you need to write a filter, and then again lambda, and then you need to write, okay, so you want only those number which are odd. Okay, because here odd numbers are more in comparison to less, so just you can change the condition. Okay, you can make even also. Okay, so x modulus 2 is not equals to 0. Okay, so this is what I need. And then, so yeah, I think there is some mistake. Oh yeah, fine. So oh, I do so 3571. Okay, so these are my odd numbers from this list. Simple. So this is what we call a filter function. Okay, and all these category come into the anonymous function. Now if I talk about a last kind of a function, so that is called a reduce function. So the reduce function is again like inside a reduce function, we are again doing the same thing. So reduce function is trying to, okay, so now all these function like a map function and a filter function, it gives you a kind of a iterable. Okay, iterable means a list or tuple. Okay, so it may be a tuple also, it may be a string also. Okay, so there is a, so it's completely fine if if it is a list, or if it is a string, or maybe a tuple or anything, it is completely fine. But in case of a reduce, what you need to do is you need okay, so what happened in case of a reduce, you from this list, or maybe from a tuple, or from many iterable, you just your output will be a single integer, or your output will be a single number. Okay, so great. What you can do is you can use a reduce function, but for using a reduce function you need to use a tool. So from func tools, you can import a reduce. Okay, and then what you need to do is you so this is like total number, and then like a reduce, and then what you can do is you can apply a lambda function again, and then suppose I want to add each and every number in this list. Okay, so what exactly I want to do, I want to print 2 plus 3 is 5, 5 plus 5 is 10, 10 plus 6 16, 16 plus 7 is 23, and 23 plus 1 is 24. Okay, so this is this is what going to be my output. Now a and then plus x, so this is what I want to do. And then maybe okay, and I want to perform this thing on my over my list L. Okay, so fine. Now the total is going to be 24. Okay, so yeah, every function has their own has their own value and has their own property. But yeah, this is what we are able to get by applying maybe a map function, lambda function, reduce function, and then a filter function. Okay, fine. I think these are the like simple thing which you are able to understand. Now, the next thing, or maybe you can say a next like a complex thing, like not a complex, but it is a kind of like very a kind of a thing which is which was mostly asked in an interview also. Okay, so maybe in coding interview, because so these are the thing which these are the like code which you can simply can give in a single line, and people can understand. Okay, so you have a very good command in a Python. Okay, so now if I talk about like list comprehension. Okay, so a list comprehension is again a different thing. Okay, so you are trying to maybe do some kind of a stuff in a single line again, but that single line should always be in a list. Okay, so maybe so now the advantage of list comprehension is what? So you are using maybe a map function or maybe a filter function or a reduce function, and all these function having a different like a criteria or maybe a different importance. But a list comprehension is just a combination of all. Okay, so suppose if you want to perform some kind of operation, or maybe if you want to apply some kind of a condition, so in each and every scenario, list comprehension is applicable. Okay, so okay, so list comprehension is applicable. So what I want to do, what I want to say is, so suppose there is one string, maybe my name Shivam Singh, and I want to make each character of my name into, I want to convert each character of my name into the uppercase character. Okay, so suppose I write my name in a lowercase character, and then I want to convert each character of my name into a uppercase character with a list comprehension. Okay, so fine, yes, I can do this. So what you can do is, so for converting any string into a uppercase character, you need to use this function upper. So s dot upper for s in Shivam. Okay, so Shivam and then Singh. Okay, so now you are able to convert each and every character of my name into the uppercase. Now suppose along with this, if I want to add any like condition, then yes, I can add. Okay, so suppose with this for loop, okay, so I'm able to run a for loop even inside a list comprehension. So but and along with the for loop, suppose if I want to add one condition, so yes, I can do that. Okay, so along a for loop, so suppose I have like I want to run a loop in a number between 1 to 10, and then I want to add a condition that from this from the number 1 to 10, I just want to print, I only want to print even numbers. Okay, so what you can do is, so yeah, you again can use a list comprehension. So x for x in a range, so you need to give a range, and then if x modulus 2 is equals to 0. Okay, so yeah, I'm able to I'm along with the for loop, I'm able to use the condition also. Okay, so I'm able to use the condition. So yeah, these things are easily possible in with the help of list comprehension. Even you can perform a dictionary comprehension. Okay, so like if I ask you to like use a list, or maybe use a tuple, or maybe by using any technique, just try to give me a table of number between 2 to 10. Okay, so just like print the table of each number 2 to 10. So yeah, you can print, but suppose I want like I want in this way. Okay, so in corresponding to 1, you have 1, then is corresponding to like, okay, so I want a like square of maybe or not a table, I want a maybe square of each number, and I want a square of like each number in a range of 0 to 10. Okay, so suppose if I want in that way, and I want to show that number, okay, so and I want to show the actual number also. So yes, by the help with the help of list comprehension, you can do that. Even if you want to, like suppose you have a list of strings, and I want to print the like corresponding to that string. If I want to print like their like how many characters are there in that string. Okay, so in a form of a dictionary. Okay, so dictionary is in form of the key value pair. So suppose I want to print that thing in a form of a key value pair. So yes, we can do that by using a list comprehension method. Okay, so let me show you a simple example. So dictionary comprehension. Okay, now so in this way I can do this what I'm trying to tell you. So I and then like I cross 2. Okay, so this is like a square, and then for I in range, okay, 11. Now if I print D, so this is my dictionary. Okay, so it comes in the form of a dictionary. So the square of 0 is 0, square of 1 is 1, square of 2 is 4, square of 3 is 9, square of 4 is 16, the square of 5 is 25. So in this way we are able to like print. Okay, fine. So these are all the things, like these things are pretty easy to understand. Even these things are like pretty easy to follow. Fine. Okay, and like these things are is enough to start with a machine learning, but there is like one more simple concept inside a Python which we need to understand. Okay, so maybe that concept is maybe might be might be a different one, but yeah, that concept is okay, so maybe that concept you're not you may not use that concept rigorously in maybe a machine learning, but yeah, that concept is also a kind of an important part of your like a Python. Okay, so that is, and for each and every programming language. Okay, so that is what we call the OOPS concept. Okay, so object oriented programming. So I think till now we talk about a programming in a scripting way, then we talk about a programming in a functional way. Now the last kind of a programming is what we call like object oriented way. Okay, so yes, okay, so just we are just trying to get the definition of like object oriented programming, that how we can create a class, and inside a class how we can create our own function, and even how we can create our like inbuilt functions. Okay, okay, so fine. For creating a class, okay, so what we need to do is, so like with the help of there is something which is called an init method. So if I talk about a oops method, so how you can create a like a class with the help of this method. So class, maybe a name of a class is person. So you for creating a class you only need to use a keyword that is called a that is what like we have. So our keyword is a class. Okay, then a very first function. So this is what we call the init function. So init function is kind of, okay, so if you guys are aware about like a C++ or C programming, so there is something which is called what we call like construction. Okay, so init function is playing the same kind of role in a Python. So you are just you try to initialize one simple function. Okay, so def init, and then what you need to do is you have maybe one key. So self is not a keyword, so self is a kind of a pointer. Okay, so it tries to point your variable, and it tries to tell like your class. Okay, so these are all my like variables. Okay, so now you have a f name, then you have l name, and then you have an age. Fine. Then if I want to initialize my variable, so how I can initialize? So self dot f name is equals to f name, then a self dot l name is equals to l name, and self dot age is equals to age. Okay, and so this is the way of initializing a variable in case of a class. Fine. Now suppose if I create one more function, one function which is not an initial function, I just create a different function. So suppose a test function. Fine. Now inside a test function, what I am trying to do, I again use a self, and then maybe I want to have two variables or maybe two numbers inside this, and with this function I want to return maybe a summation. Okay, so n plus m and then plus age. Okay, so this is so maybe this is what I want to print. Fine. Okay, so this is it. In this, so you can create a multiple function if you want. Okay, so based on the requirement, that is completely fine. Okay, now the very first thing which you need to create object. Okay, so object you need to create. So for calling a function or to call anything which is inside a function, you need a object. Now if you run a object in this way, so you get an error because it is having three required positional argument. Okay, so which is f name, l name, and age. Okay, so you need to define your f name, your l name, and your age. Okay, so means you need to define your first name, your last name, and then age. Okay, so my first name is Shivam. Fine. Then my last name is Singh. Okay, and then my age is 25. Great. Now if I try to if I want to access anything, so suppose if I want to access maybe like f name. Yes, so Shivam. Now if you want to understand the concept of self and how why I'm calling it it as a pointer, so suppose if I make a name over here only. Okay, so in place of f name, if I write name over here only. Okay, and now if I run this program, so it will give an error, and the error is person object has no attribute f name. Okay, so now this is what I'm trying to tell you, that self is a pointer. Okay, so it is only self, and it can be only anything. Okay, although so so it is an alias name, so it could be a my name, it could be your name, so it is possible that it could be any name, but so but this name is like acquired by what you call a community of a Python maybe. So and most of the now so people are using this name. Otherwise it could be any name because it is just a pointer, it is not any kind of a keyword. Okay, and what it trying to point. Okay, so when you assign Shivam, so Shivam is going to assign this f name. Okay, Shivam is put on this place, then it tries to reach here, and then it tries to reach here, and then self is going to tell this class. Okay, so self is going to tell this person, okay, this is what the name of so this name is what the name of this person. Okay, now if you have a name over here, so you need to write so it does not have anything with the name. Okay, it is having a like f name. Oh, sorry, it does not have anything with f name, it is having just name. Okay, so that is why you are getting an error. Okay, so self is a pointer. Self is only, so self is a pointer which actually tells your like a class that these are the name of your variable. Okay, so you need to write f name over here, and then only you are able to perform, and you are able to check the same thing with the test. Okay, so suppose if you try to maybe so suppose if you try to uh, return like a number. Okay, so return maybe summation. So suppose the first number is 32, second number is 38, and the third number is 25. It will give you an error. So it is not able to add 25 in this place because age is a variable in a main class. Okay, so anytime if you want to call a variable from the main class, you always need to use self. Okay, so now it is able to print. So 32 plus 38 plus 25 is equal to 95. Okay, you can add. So 38 plus 32 is become 70, and 70 plus 25 is 95. So this is how you are able to create a class. Okay, and this is how you are able to make your program. You are able to program in a object oriented way. Okay, so fine guys, this is all about from like a Python section from the recap of Python. Now so in next day we are going to talk about the libraries which we use to in a machine learning. Okay, so like NumPy, pandas, and then matplotlib and seaborn. Okay, so thank you so much. Have a nice day. Okay, hello all. So now I'm going to discuss about NumPy. Okay, so NumPy stands for a numerical Python, and it is actually used for a scientific computation. Okay, so we use NumPy to perform a scientific computation. So scientific computation means any type of like a matrix computation or maybe any kind of a mathematical operation which we can perform on what you call matrices. Okay, so in a core Python, you can do maybe a kind of a mathematical operation in between two numbers or maybe in between two lists or maybe a tuple or something. But if it is okay, so if your data if your data is present in a form of a matrices or maybe or 3D or 3D 4D 5D array, so in that scenario, in that case, you need to use like NumPy. Okay, so NumPy helps you to make this kind of a computation, and not only like a basic arithmetic calculation, you can perform a typical mathematical computation as well. If you want to find out log and exponential, anything, so any kind of a typical mathematical operation is possible with the help of NumPy. Now if I talk about maybe and then there are different functions. Okay, so there are different functions and like a lot of ways to create maybe a random numbers, to generate a random numbers, to generate identical matrix, or maybe to generate a diagonal matrix. So any kind of a matrices or any kind of array can also be generated by using this library which is called NumPy. So the very first thing which you need to do is you need to import this library. So import NumPy as NP. So NP is an alias name. So NP is always termed as an alias name. Okay, so you can use any name in place of NP, but it is a mostly used name and a popular name, and we don't want to use NumPy everywhere. Maybe anywhere if you want to call any function. So what we can do, we can use like NumPy dot then dot this, then NumPy dot that. So to avoid that thing, we try to use like a alias name. Now if I want to create a simple array, so how I can create a simple array? So I can create a simple array with the help of np dot array, and then I can pass my array. Okay, so I can pass the element which I want to create inside an array. Now if I see an array, so this is my array A, and if you try to check the type of this A, so this is nothing but numpy dot nd array. So nd means n dimensional array. So it tells you that yes, you can create any dimensional array, although it is a single dimension. Okay, so it's just a single dimension array, but based on our choice and based on our requirement, we can create any any dimension of an array. And then we have like function shape. So with the help of shape, we can check the shape of an array. So because we just have 5 element and we only have a row, so it is 5 cross dash. Now if I try to create or maybe 2D or 3D array, so how I can initialize a 2D or 3D array? So yes, we can do that also. So what you need to do is you just need to write np dot array, and then you need to use two bases. Okay, so 2 5 7 8 sorry 3 5 7 8, and then maybe you want to have 2 4 8 and 9. Now this is your 2-dimensional array. Okay, so if this time if you try to check the shape of an array, so it is 2 cross 4 because you have 2 rows and 4 columns. And along with this, if I try to check my dimension, so n dim, so it is 2. Okay, because we have 2-dimensional array this time. In a similar way, if you want, you can create a 3-dimensional array. So I think you are able to understand that in order to increase the dimension, what we need to do is you only need to increase these braces. Okay, so so number of dimension depends upon this number of braces. So how many number of braces you have, that so that is the number of dimension. Now if I check some of the properties of numpy array or numpy. So there is one property, there is one a kind of a very important concept, you can say. So that is called a shallow copy and deep copy concept. Okay, so shallow copy and deep copy. Now I have np dot array, and inside this, suppose I have this element, so 3 4 5 6 7 and 8. And then so now if I try to make a variable b, and I want to have same element inside a b, the element which I'm having in a. Now this is what we call a shallow copy. Okay, shallow copy. So this is what we call a shallow copy. Now if you check b, so b is also having the same element which is inside an a. And now if you try to change, maybe if you try to modify this b, okay, so if you try to modify this b, maybe in place of okay, so in place of 4, okay, so 4 is in on the first index value, index location. So if I want to okay, so if I want to change this 4 and I want to make it 9, okay, so yes, it is possible. Yeah, and you are able to see one more interesting thing, that the same change is going to reflect in a also. Okay, so whatever the change you make in you made in b, the same change will reflecting in a also. Okay, so this is what we call the shallow copy. Now if I talk about another method of like copying an element. So now I have a c. Now inside a c, what I can do is, so I can try to make a copy again. So np dot copy, and then we have an a. Okay, so c equals to np dot copy, and then we have an a. Now if we try to check this, okay, so np dot copy, and now if I try to run this c, so we have the same element in c, which is in a. And this method of copying an element, or this method of copying an array, is called a deep copy. Okay, so this is what we call a deep copy. Fine. Now okay, so now just try to do one thing. Try to do the same thing with c, what we have done in a. So in place of maybe 5, okay, so in place of 5 I want a 10 over here. Okay, so in place of 5 I want a 10. So 5 is on the second index value, so I just try to change that value with 10. Okay, now if I run c, so yes, the c changes, and now on the second index value we have a 10 in place of 5. And now if you run a, so the same change is not going to reflect in a. Okay, so this is what a difference between a shallow copy and a deep copy. Okay, so in case of a shallow copy, whatever the changes you try to make in like a second array, or maybe the array which is derived from your original array, the same change will going to is reflect in like a main array, or maybe what you call existing array. But in case of a deep copy, whatever the change you make in a secondary array, that the same change will not going to reflect in a primary array. Okay, so this is the main difference between a shallow copy and a deep copy, and this is the way of like copying an element. Okay, so one is np dot copy, and another is just a kind of an initialization. Now if I talk about another important function inside an numpy, so that function is called a range function. Okay, so range function. Now what happened inside a range function? So suppose if I want to we already have a range function. We already learn about a range function in a core Python. So suppose if I take maybe a range of like a values. Okay, so suppose if I want to start from 2, and then I want to go till maybe 11. So and then I want to take like a step of 2. Okay, so I think you all are aware about this fact that inside a range, this is my first value, then this is the last value, and this is the step size. Okay, and the upper bound is always excluded, so this 11 is not going to include, this 11 is going to exclude at all. Okay, now if I run this, so we have 2, 4, 6, 8, and 10. Okay, so in gap of 2, in step size of 2, we are having this elements. Now okay, so now if I try to make np dot a range. Okay, so now if I try to if I try with np dot a range, so inside np dot a range, what I'm having is, so I'm having maybe again I'm having a 2, and then again I'm having 11, and again I'm having 2. Okay, so yes, I'm getting the same thing. Okay, so I'm not getting any like a new thing over here. But okay, so let's try to find out the difference. Okay, so what may be the possible difference between a range and a range function? Although yes, in case of a numpy, because we are using a numpy, so it so in place of a list, we are able to create an array. Okay, so but that is not a kind of a difference. Okay, so because we are creating an array, so that is why we are getting an array. If in our case we are creating a list, so that is why we are getting a list. Okay, so that is not like a kind of a difference. What else, what other difference we can find out? Okay, so what you can do is you can try to okay, so suppose in place of a 2, if I want to make a step size as 2.2. Okay, if I want to take a step size as 2.2, so now this is this will give you an error. Okay, so the error is float object cannot be interpreted as an integer. It means what? That inside a range function you can't take a float value. Okay, so you can't take any floating point number. But in case of a range function, I think you can take this. Okay, so if you take a step size as 2.2, so you are getting an element you are getting an element after 2.2th step. Okay, so this is what we call a so this is what happened inside a range function. So, and this is the difference between a range and a range function. Now if I talk about maybe like a linear space. Okay, so suppose if I talk about a linear space. Okay, so linear space. Now inside a linear space, what you can do is, so there is one more function, linear space. Now there is like just a thick difference between a range and a linear space. So what happened in a linear space? So np dot, if I try to write np dot linear space, so again here I need to give like starting value from where I want to start. Then I want to give like maybe an end value, so till where I want to go. And then like the last value is not going to be a step size or nothing. It is going to be like how many numbers you want to put in between 1 to 20. Okay, so this is what you are going to give over here. And suppose if you didn't give like any number for like a reference, so it will take 50 by default. Okay, so what it can do is, so if I suppose if I didn't give any number, so it will going to give you a 50 numbers in between 1 to 20 with a equal size. Okay, with the equal step size. Okay, and now suppose if I make 10 over here, so yeah, you are getting then 10 numbers in between. And suppose if you want to find out that what may be the step size, so there is a function called a ret step. Okay, so I think yeah, ret step is there. So if you make ret step as true, so you are able to see that what is the step size. Okay, so this is your step size 2.11. Okay, and this is what we call a linear space. Fine. Now the next thing, if I talk about maybe some common arrays. Okay, so some common numpy arrays which you can build like just like a bread and butter. So that is like a zeros. Okay, so you can create a numpy array. You can create an array where every element will be a 0. Okay, so you can create a kind of an array where every element is going to be a 0. Okay, and like each and every element is 0, and that can be of any shape. Okay, so it depends upon you that how what what is the shape of an array. It depends upon you. So z is equals to np dot zeros. You can you can write in this way. So np dot zeros, and then you can write you need to give a shape. Okay, so suppose 4 cross 4, and then if I run z, so yes, I'm able to get a array where all the elements are 0. In a similar way, if you want to create like an array where each element is like 1, so you need to write np dot ones, and then you need to give size. Okay, so this is np dot ones. Okay, so again you can try in this way. Okay, it should be double braces because it's a matrix. Okay, fine. And in a similar way, you can create a diagonal matrix. Okay, so only at a diagonal you have 1 and rest of, so you can create an identity matrix. Okay, so that is called an identity matrix. Okay, so identity matrix can be created by a np dot I. Okay, so this is an identity matrix. Okay, so yeah, this kind of array or this kind of matrices can be created by using a numpy. Now if you want to generate a random numbers, okay, so if you want to create a array and as suppose if so this is a very like a kind of a basic questions which can be asked anywhere, that try to generate an array of maybe 4 cross 5, or just try to create a matrix of maybe shape 4 cross 5, and the numbers are the number should be a random numbers. Okay, so yeah, you can generate this kind of an array. Okay, so you can generate this like random number array. Okay, so how you can generate that kind of an array? So for that you have like three functions. Okay, so 3 different functions are there. So I can write over here that a random function generation. Okay, so random number generation. Okay, and then you must have ru is equals to np dot random dot and rand. Okay, so np dot random dot rand, and then suppose you give a a shape. Okay, now if you try to, okay, I just want to print over here itself. So this is my random numbers. Okay, so np dot random dot rand, and then you give a shape. Okay, so shape is 4 cross 3. So I want to generate an array of or matrix of size 4 cross 3. Now in a similar way, if you want to, okay, now another way of like generating a random number. Okay, so that is called np dot random dot rand n. Okay, so np dot random dot rand n, and then size is again maybe 4 cross 3, and then suppose if I run rs, so I'm getting this number. Okay, now I think you might thinking, okay, so in both way we are creating we are generating a random numbers, then what is the difference? Okay, although you are able to find like a difference, definitely you are able to find a kind of a difference by yourself, just by seeing the like kind of a matrix. But you must be you must be like thinking, you must be curious about okay, so what kind of a what is the exact difference? Okay, so what may be the exact difference? So now if I try to find out the exact difference, so what you need to do is you just go on to this braces and just press just try to press shift and tab. Okay, and then you are able to find out that the number which I am generating in case of np dot random dot rand, so the number, so these random numbers are come out from from a range of 0 to 1. So the numbers are between the range of 0 to 1, and these numbers are come out from a uniform distribution. Okay, so I think if you are aware about maybe a probability distribution, or maybe if you're aware about a probability, so there are like different kind of probabilities distributions. Okay, so that are like a Bernoulli distribution, and then a Poisson distribution, then uniform distribution. Okay, and then like a normal distribution. Okay, so these numbers, these random numbers are come out from a uniform distribution. Now if you try to check in a similar way, if you try to check over in case of random dot rand n, So these values are come out from a standard normal distribution. Okay, so I think in this case the value is in between the range of 0 to 1, and in this case if you try to find out the mean of this array, so the mean of this array is going to be 0 or maybe very close to 0, and the standard deviation of this array is going to be 1. Okay, so this is what a difference between like a rand and a randan. Now the third way of creating generating the random numbers, so that is called a np dot random dot rand int. Okay, so now in above function you the range is already predefined. Okay, so range is predefined, so you do not to refine the range. But in case of rand int, the range is not defined, so you need to define a range. Okay, so suppose I want to take a element in between 1 to 20, and then you need to give a shape. Okay, so suppose the shape is same. Okay, so 4 cross 3. Now if you run this ri, so this is what we are getting. Okay, so I think you are able to understand that in above two cases the numbers are in a decimal values, but in case of rand int you are able to generate a random numbers, but like integers. Okay, so if someone asks you to generate our integer random numbers, so in that case you need to use rand int. In place of rand and in place of rand you need to use rand int. Okay, fine. So these are all functions which you can use in case of numpy, and you can generate a random numbers, and even if you want to perform any kind of thing though, so yes, you are able to perform that. Now if I talk about there is a concept which is called a reshaping. Okay, so you can reshape your array, so that is also possible that you can reshape your array. So suppose the same array, if you want to reshape the same array, so ri dot shape, if you try to check, so the shape of this array is nothing but 4 cross 3. Now if I want to reshape it, so yes, you can reshape it, but the size is so the size should not change. Okay, so you can reshape it. So suppose you can reshape in this way 3 cross 4, so that is possible, it is completely possible. But and even you can reshape in this way. So I think if I try with the maybe a 6 cross 2, so it is all this is also fine. 6 cross 2 is also fine, even 2 cross 6 is also fine. But if you try to make okay, so suppose if you try to make if you try to reshape in this way, so maybe a 4 cross 5, so it will give you an error, because the size of the array is 12, because you just have 12 elements inside this array. So you can't reshape it in a 4 cross 5, because 4 cross 5 needs a 20 elements. Okay, so the size should be a 20 if you want to reshape it in 4 cross 5. Okay, so I think this up to this point everything is clear to you. Now one last thing which we need to understand in case of a numpy is what kind of a mathematics, or what kind of a mathematics we can apply, or what all kind of a mathematical operation we can do with this array, or with this matrices. Okay, so suppose if I try to create an array np dot array, and then suppose I have a 2-dimensional array, maybe a 1 cross 2. Okay, so I'm just taking a small number so that the computation will be easy, and we are able to cross check whether we are doing correct or not. And then suppose np dot array, and again we are having maybe 4 cross 5, and then in a second we are having maybe a 7 cross 6, 7,6. Okay, so we have an x and we have an y. Okay, so we have an x, we have an y, and now if I try to perform x plus y, so yes, I'm getting x plus y. So 4 plus 1 is 5, 2 plus 5 is 7, 3 plus 7 is 10, and 4 plus 6 is 10. Okay, so this is like x plus y, and the same thing you can achieve with np dot add. So the same thing you can achieve with np dot add. Okay, even this function, or this kind of a mathematics is very much applicable for np dot subtract, and then np dot multiply, and even np dot divide. But now the interesting case is a case of a multiplication. Okay, so suppose if I try to multiply this two array, okay, x comma y, and even if I try with like np dot multiply, okay, so I'm getting 4, 10, 21, 24. But if you're trying to check, okay, so this is what, so this is just an element wise multiplication. So 1 cross 4 is 4, 2 cross 5 is 10, 3 cross 7 is 21, and 4 cross 6 is 24. And this is what the output we are getting. Okay, so this is what we call the element wise multiplication. This is not a proper matrix multiplication. I think you guys are aware about like what is matrix multiplication. So in case of matrix multiplication, the multiplication going in this way. Okay, so 1 2, and then you need to like multiply this value with this 4 7, and then the same thing you need to do is 5 6. Then the same thing we need to do is with 3 4 and 4 7, then 3 4 and 5 6. Okay, so that is what we call the matrix multiplication. And this is what we actually want to achieve. Okay, so in a real case, or whenever someone give you a kind of a task, so they definitely want you to do a matrix multiplication, not a like element wise multiplication. So now in so suppose if you want to do a matrix multiplication, so again there are two methods. You can use np dot dot, a dot function. So you can find out a matrix. So yeah, you are able to see the values are changes, and this is a real value which come out from a matrix multiplication. Even you can do one more thing. So you can apply at the rate. Okay, so x at the rate y, and yes, you are getting the same value. Okay, so this is what we call a matrix multiplication. Fine. And then like last function is called a broadcasting. Okay, so a broadcasting kind of an operation. So what we can do in a broadcasting, so suppose there is an array, and broadcasting means you just try to broadcast a value over the complete array. Okay, so maybe there is one maybe any value or element, and you want to broadcast that particular value over the complete array. Okay, so s is equals to np dot like maybe a zeros, and the shape of this is 4 cross 4. Okay, and then this is okay, so fine, I need to write in this way maybe. So this is my like array s. Now if I try to write s plus 100, so this is what I'm getting. Okay, so this is what we call a broadcasting. Okay, so this thing is called a broadcasting. Okay, so it becomes 100, so every value becomes 100. Okay, so this is what we call a broadcasting. Okay, so you try to broadcast like this single value, this and you try to broadcast with this plus operator over the complete array. Okay, so this is like a kind of a good thing, and a very beautiful function in a Numpy, which is called a broadcasting. Okay, so I think guys, this is it from this Numpy section. And then okay, so now we are ready to move forward, and we can now learn about pandas. Okay. Hello all. So now I'm going to talk about pandas. So for pandas, so if I give you a kind of introduction about pandas, so pandas is like a data manipulation and data analysis. Like it is used for data manipulation and data analysis. Okay, because so like a kind of data which we are receiving from maybe from client end, or maybe from any like open source repository. Okay, maybe from anywhere. So the kind of data which we are receiving is like that data can be in a form of a CSV, or maybe it can be in form of Excel. So the data is like in a different format, and it may be in any format, like in maybe a tabular form, or maybe in a like in maybe a HTML format. So it can be in any format, and we need to like manipulate the data. We may need to like what you call, okay, so we need to make a data in arrange the data in a proper format, so that we can process it, we can then we can analyze it, we can try to get some insights from it. Okay, so it is like so these things are possible, like getting an insights and then making an analysis. So these things are possible only when we are able to arrange our data set in a proper manner. Okay, so and there we use this concept pandas. Okay, so so again for pandas also we need to import a library, because this is not inside a core Python. So we need to import pandas, and again just we are doing in a Numpy. So we are going to take a kind of alias name. Alias name, well, a popular alias name for a pandas is nothing but a PD. And now maybe I want to create some kind of an array or something. So for that I am going to import Numpy as well. Okay, so let's start that what are the like kind of a functions, and what are the kind of a manipulation or analysis we can do with the pandas. Okay, so fine. Now if I okay, so I'm going to start with an example. So suppose I can, okay, so like in a pandas, the data are arranged in two form. Okay, so it can be arranged in like in a series, or maybe it can arrange in like a data frame. Okay, so now so x is a kind of an variable. So suppose we are going to take maybe like I'm going to store some data inside it. So a, and then b, and then c, and then d, and then e. Okay, and then inside a y we are having maybe some numbers. So 1, then a 2, then 3, then 4, and then 5. Okay, so we have two array, or like two list. Okay, so one is x, another one is y. Yeah, we need to make like a series. Okay, so to make a series, what we can do is we can write pd dot series. Okay, so pd dot series, and pd dot series, and then we need to pass our data. Okay, so x and y. Now if I run x, so if I run a, so I'm getting this kind of a data. Okay, so and if I try to check the type of a, so the type of a is nothing but a series. Okay, so there is a like difference between series and a list. So in case of a list, you're not getting a you are not okay, so suppose, okay, so I you can say, okay, so here I'm I just like give a index value. But suppose if you didn't give an index value also. Okay, so suppose if I just pass a x from here, then also I'm getting an index value. Okay, so this is the difference between series and a list. Okay, so in a list you don't have any like an index value, means you don't have anything of as such called an index value or something. But in case of a series, you have you always have an index value. Okay, so this is kind of a difference between series and list. Now and so this is like a one way. Okay, so this is the one a kind of a data which we are able to create by using pandas. Now the another kind of a like a data which we can create by using a pandas is like data frame. Okay, so now if I try to make a data frame, so I can again store inside a variable. So np dot random dot randint. Okay, so np dot random dot randint, and then I can pass maybe like values. So I can start from 1, I can go till 28. Okay, and then I can give like a range. Okay, so maybe sorry, I can give a shape. So shape maybe 4 cross 5. Now if I run this, so this is my array. Okay, so 4 cross 5. So 4 cross 5 is shape of my matrix, and I'm getting a value in between 1 to 28. Okay, so I'm able to generate a random numbers in between 1 to 28. Now if I want to make a data frame of this array, so it's pretty easy to make a data frame. What I need to do is I just need to use pd. So I need to use pd and then pd dot data frame, and I need to pass this like r. Okay, and yes, I'm able to make a data frame. So this is what we call a data frame. If you're able to like if you try to search it on a like internet, you are easily get it like if you type data frames, we are getting this kind of like a picture. Okay, so this is what we call a data frame. And now, so this is our like our columns and then rows. Okay, so sorry, this is rows and columns. So rows and columns are given. And okay, fine. So we don't have any like a value for rows, and we don't have any values for column, because we just okay, because we just pass our data through this like data frame. If you want to if you want to make a if you want to use a proper row name, and if you want to use a proper column name, so yeah, you can do that. But so how you can do that? You can like assign maybe, okay, so you can check by entering a shift enter. So you need to pass a data first, then you need to pass the index, and then you need to pass the column. So index means rows. So yeah, I can pass like index. Okay, so just pass the index. So I think row is 4, so you need to pass like 4 values. So a, then maybe a b, and then a c, and then d. Okay, so these 4 values I'm able to pass. And similarly, I can pass like a number of columns. So number of columns may be a w, and then x, and then y. Okay, so w, x, y, and z. Okay, but we need, I think, 5. So w, x, y, z. So you can start from v. Okay, so v, w, x, y, z. Now if you run this, yeah, so now my column name becomes vw xyz, and my row name becomes a, b, c, and d. Okay, now just try to do the simple manipulation, or you can say simple kind of an analysis. So suppose what I want to do is, I want to like create one new column. Okay, so suppose I want to create one new column with any name. Okay, so maybe I want to create a new column with name s. So how I can create a new column with name s? So you can like create a new column with name s with any like with any method. Okay, so like a kind of method which I am going to use is called a interpolation method. Okay, so inside interpolation method, what you can do is you can just use 2 column, and by adding 2 column, or by subtracting, or by like performing any kind of arithmetic operation, you can add like 2 columns and make a single one. Now if I again run df, so yes, I'm able to get a new column, and this new columns comes by adding these 2 numbers. Okay, so 20 plus 13, then 14 plus 16, then 6 plus 8, and then 27 plus 2. Now in a later stage, so suppose if I want to maybe drop one column. Okay, so if I want to drop maybe a row, or maybe if I want to drop a column, because maybe the number of columns are more and number of rows are even if I want to drop maybe one row, or maybe if I want to drop one column. So yes, I can do that. So how I'm able to drop a row or column? So for that, you just need to use a function drop, and then you need to give like a row name which you want to drop. So suppose I want to drop the last row with d. So yes, I'm able to drop it. But what happens? So suppose if after dropping this d, if again I try to execute df, so again I'm getting d over here. Okay, so although you are able to drop d in this cell, but again the same d is like showing over here. Okay, so for that, okay, so okay, so okay, so this is what these things are happening, because this is not like a permanent change. Okay, so with the help of drop, I'm able to like make just a temporary change. Okay, where I'm just able to perform a temporary change. I'm not able to make a permanent change. Okay, now to make like a permanent change, okay, to make like a permanent change, what we can do is so we can write in place equals to true. Okay, So now you can see the change become permanent. Now if you like try to execute df again and again, then also you are getting a like same thing, because you are able to drop this d row permanently. In a similar way, suppose if I want to drop a column, so let's see, can I'm able okay, so can I drop a column as well? Okay, so with this, in a similar way, can I drop a column? So for that, suppose what I can do is, so I can drop the last column, and then I can like again try to make in place equals to true to make like this thing permanent. But yeah, but I'm getting an error. Okay, and this is the error which I'm expecting. So I'm getting an error, I'm not able to drop like s. Okay, so what may be the possible reason that I'm not able to drop s? So the very like a possible the reason which behind which is behind it is, so if you're trying to like again, if you're trying to press shift plus tab, okay, so suppose again you are trying to press shift plus tab, so you are able to see one attribute as axis equals to 0. Okay, so there is one attribute axis equals to 0, and now the axis equals to 0 means what? So fine, so axis equals to 0 is like okay, so axis equals to, so here I am getting axis equals to 0. So like, so suppose if you try to check that what is the meaning of axis, so axis indicates a row and column. Okay, so 0 means index, or you can call it as row, and 1 means column. Okay, so this is the like this is the meaning of like axis. Okay, so axis 0 indicates the row and axis 1 indicates the column. So I can also I want to drop a like s, and s is in the 1. Okay, s is in the column. Okay, so that is the error we are getting over here, as not found in axis. So by default the axis equals to 0, which means it represents a row, but the s is like s is a kind of a column, it's not a row. So I need to write 1 over here. Okay, now I'm able to drop it. So suppose if you run the df again, so I'm able to drop this column. Okay, fine. So I think till this it is very clear to you. Now suppose I want to like maybe, okay, so I want to maybe like perform some kind of indexing, or maybe I want to perform some kind of a slicing. So how I am able to perform like kind of an indexing and slicing in case of a data frame? Okay, so in case of a data frame, can I like do like indexing and slicing? Okay, and can I do that in a similar way as I'm doing in maybe in case of okay, so maybe in case of like a numpy, or maybe in any other case. So here what you can do is, so you can use a log function and ilog function. Okay, so it is not possible to like a slice element, or maybe index a particular value with just like okay, so with just by giving an index number. Okay, so you can do that by what? By just uh, by using a log and ilog function. Okay, so df dot log. Okay, so you can use the df dot log, and then you can try to like yeah, you can try to log maybe okay, so you can try to log maybe some values. Okay, so there is a slight difference between log and ilog. So in case of a log, you are trying to log with a name. Okay, so suppose uh, okay, so suppose I want to log this complete row. So yes, you can lock it by using like a. Okay, so this is okay, so no access named object. Okay, fine, it is why it is giving me an error. Oh, fine. So this should become inside a square bracket. Okay, so yes, I'm able to lock it. So now if I want to lock maybe a and b together, so the same idea, the same concept. Okay, I'm able to lock it. Even if you want to lock maybe a complete thing. Okay, so maybe if you want to lock like a and b and v and w, so yeah, this is also possible. You just need to give like a comma. So left on the left hand side of a comma, you need to write a row, and on the right hand side of the comma you need to write a column. So V, and then you want to tell go, you want to go like a W. So yes, I'm able to log it. Similarly, now what is a like ilog? So in case of ilog, if you want to log, if you want to access the same thing, so now you can access the same thing by using their index value. Okay, so now if I'm using an index value, so again I need to include the concept that upper bound is going to exclude. So if I want to log A and B, so I need to start from 0, I need to go till 2, and similarly I need to start from 0 and I need to go to it. Okay, and I'm able to log the same thing. So this is the difference. So in case of a log means you are trying to log some value, or you are trying to log some pattern, or you are trying to slice some data together by using their name. And in case of ilog, you are trying to log maybe a sequence of data, or maybe slice some data by using the index number. Okay, so I think this much things are clear to everyone. Now if I again run the df, and then there is one concept which is called masking. Okay, masking and a boolean masking. Okay, so this is called a boolean masking. Okay, so boolean masking means what? So suppose if I can write in this way, so df is greater than maybe 11. Okay, so I think you are able to understand where the value is greater than 11, I'm getting true, otherwise I'm getting false. Okay, so this is what we call a boolean masking. Now if I want to like maybe mask the I only want to mask those value where I only want to mask those things or those values which is greater than 11. So what I can do is I can write in this way. Okay, so now I'm getting nan I'm getting nan where the value is lesser than 11, and I'm getting the exact value where the value is greater than 11. Okay, so this is what we call a boolean masking and a masking as well. Okay, so I think this much concept is very clear to all of you. Okay, now there is one more thing, there is one more important concept. So suppose if you want to, so suppose in your data frame you are getting some this kind of a thing, you are getting some like a nan value or something. So you can do one more thing. Okay, so what you can do is, so suppose I just store this thing in df1. Now in my df1 I am getting a nan. So what you can do is, so you can do one thing, you can like just drop like this null values. Okay, so by using a drop na, you can drop the null values. Okay, so so the row where there is a null value, I'm able to drop that like a complete row. Okay, so I think in every row we are having a null values, so yes, you are able to drop it. Now if you want to utilize this null value, so you can use a function fill na. And suppose if we want to fill all the null values with maybe a 3, so yes, wherever you are having a null values, you are able to fill those null values with the 3. Fine. Okay, so I think this much concept is clear to everyone. Now just try to analyze the concept of pandas, and just try to use the concept of pandas on a real data frame, on a real data set. Okay, so I am having like a data set which is a Titanic data set, and it's like very popular and very helpful for the beginners to understand the concept of even machine learning. So pd.read csv. So whenever I'm we need to like read any data sets, so we need to use or whenever so the file the data set is in the form of a csv. Okay, so that is why I'm trying to write pd.read csv. Okay, and now if I want to see just the first 5 rows of my data set. Okay, so this is just first 5 rows of my data set. Okay, so I am using the like function which is called head. Okay, so this is like head, and now so inside a head, if you try to check, so by default the value is 5. Okay, so the n is equals to 5. But if you want to change it, okay, so if you want to like make it 10 or maybe 15 or 20, so yes, you can make it. Fine. So this is like a head. Now if you want to see the like data dot columns, so yes, I'm able to see the columns as well. And then if I try to check the data dot shape, so yes, I'm having a shape of my data. I'm getting the shape of my data. Okay, so what this shape represents, so this shape represents the number of rows and columns. So I'm having like 891 rows and 12 columns inside my data set. Okay, now suppose if you want to check the type of our data set, okay, so you can try data dot d type. Okay, so I think data dot d types. Okay, so we are getting that okay, so the passenger ID is in the form of integer, then survives is integer, passenger class is an integer. Okay, fine. Now suppose if you want to access just a single column, okay, so how you can access just a single column? So you can access just a single column by using a dot and then by giving the name of the column. Okay, even you can access a single column in this way. Okay, so in this way you are able to access a single column, but there is one problem. Okay, there is one problem, and okay, maybe I want to use I want to access multiple columns. Okay, so maybe I along with the name I want to access sex as well. So I'm getting an error. I'm getting an error name and sex. Okay, although I'm having a column sex over here, but it is giving me an error. Now how I'm able to like resolve this kind of an error? So for that you can like put this name and sex column inside a double braces. Okay, so in place of a single braces you can put it in a double braces. Okay, and now you are able to see the difference between the kind of representation we are getting from this like a data dot name or data in a single braces. Okay, and the kind of representation we are getting over here. Okay, so what exactly happened? So if you try to check the type of this thing, if you try to check the type of this thing, so it is that the type becomes series. Okay, although you have a data frame, but um but because of this single braces, you so your data frame becomes a series. And and but if you're trying to check the type over here, so it becomes a so it is a data frame. Okay, so it is a data frame. Fine. Okay, so now it is, I think, clear. Okay, and okay, so now we can check another function. So in case of okay, so with the help of pandas we can check that whether my data set contains a null values or not. Okay, so let's check whether, so is null dot sum. Okay, so I am getting an okay, so how many number of null values? So in a age column I am having 177 null values, and in a like cabin column we are having 687 null values, and in embarked column we are having 2 null values. Okay, so we are having like kind of a null values inside my data set. Okay, so we are having 177 null values, then 687 null values, and then 2 null values. Fine. Now if I try to check what is the distribution of the class, so if I try to check the distribution of class, so yes, I can check. So data survived, and then if I try to check value counts, so yes, I am getting okay, so 549 people are not able to survive. Okay, so 549 passengers are not able to survive, but 342 passengers are able to survive. Okay, so this is a kind of a scenario we are getting over here. So in this way, so with the help of like values count, you can check like the distribution of any kind of a class. Okay, so there are like, so there are different categories. Okay, so along with the survived you have like passenger class as well. So there are like three categories of passenger class. Okay, so 1, 2 and 3. Even you have like 2 categories of like in case of a sex also you have 2 classes, male and female. Similarly in case of embarked, so you can check the number of counts by using the value count. Fine. Now there is one very important or very interesting thing in a pandas. Okay, so very interesting a function you can say, that is what we call a pivot table. Okay, now pivot table is going to give you a very good insight, or you can say a very good analysis. Okay, so apart like above all, personally, I feel that the pivot table is very useful when you are trying to do like analysis by using a pandas. Okay, so what pivot table gives you? So I can try to apply pd dot pivot table. Okay, so pivot table, and now what this table gives you? Okay, so we are having a data, and then we are having an index. So inside index, I'm having maybe one column, just a sex column, and then we are having a values as like a survived. And if you're trying to check, so we pass the like data, we pass the index as well, and then there is an aggregate function. So this is a very important thing. Aggregate function is mean, means average. So by default, it is going to give you the mean. Okay, although you can change it also. Okay, but let's see that what we are getting. So now this is a very good analysis we are getting. Okay, so the analysis tells us that out of our like total number of female, whatever the total number of female we are having, so out of total number of female, 74% female is survived, whereas just 18%, or you can say a 19% males are survived. Okay, so this is this is a very big or very important analysis regarding this data set. Okay, so just 71st, okay, so we, of 74% females are survived, and just 18.8% males are survived. Okay, and now if you change this, if you change the aggregate function, so if you make it sum, so now 233 females are survived. So out of like, okay, so you can see that how many females are there. Okay, so you can try to copy the same code, and in place of survived, you can like put a sex over here. So out of 314 females, 233 females are able to survive. But out of 577 males, just 109 males are survived. Okay, so this is a kind of observation we are getting from this pivot table. Okay, and that is why this pivot table is like a very useful. Okay, it gives you a very good like insight and analysis. So suppose I'm going to use a p class also. Okay, so I'm going to include a p class also. Now you are able to see. Okay, so where there is a female, so a female from passenger class 1 is like 91 female from passenger class 1 is able to survive, 70 females from passenger class 2 is able to survive, then 72 females from passenger class 3 is able to survive. Okay, so female survival rate is high. So it doesn't matter that whatever the class may be, from every class, most of the females are able to survive, although the if we try to make it a mean, so we are able to see that the percentage of females survived in first class are like much more in comparison to these two. Now if you are able to calculate in case of male, so from first class 45 males are survived, from second class 17 males are survived, and interestingly, so this is a quite of this is like a surprise thing. Okay, although this number are very less in comparison to this, but this number are surprising in case of female. So from a third class, okay, so from a third class, 47 males are survived. Okay, so this is kind of a surprising result, but yeah, this is a kind of result we are getting. Okay, so 36% male are survived from a first class, 15% survived from second class, and then 13% survived from the third class. Okay, so these are the result we are getting over here. Now if you want to maybe rename any column, so yes, you can rename any column by using data dot rename option. Okay, so data dot rename, and then you can change the column name. Okay, so what you need to give, you only need to give a columns, and then you need to make a curly braces, and then maybe I want to replace sex with a gender. So yes, oh, you need to give a colon over here. Okay, so the sex is like replaced with the gender. Okay, so these are all the like basic functions, or the function which we can use
regressively in case whenever we are going to solve our machine learning or maybe any kind of a problem. Okay, so I think this much information is more than enough with respect to pandas. And then okay, and we are good to start with the visualization part. Okay, so thank you so much.
Hello all. So let's start with the like visualization. Okay, so I think in last session we talked about pandas. Now it's time to see the like what kind of a visualization we can make. So visualization simply means that how we are able to make a charts, or how we are able to make a graph to show our things. Okay, to show our analysis, to make it more attractive. Okay, so like. Especially it is the name is exploratory data analysis. So we are actually trying to explore the data set. We are actually trying to make some exploration with the help of a graph and with the help of a chart, and then we are trying to understand that we are trying to understand and we are trying to just pick some kind of insights, and we are trying to pick the insights from the data, and then we are able to make our analysis based on that. Okay, so it's like quite attractive, interactive, and at the same time we are trying to understand the data in a much better way. Okay, so there are like certain libraries which help us to make this kind of exploration. So, and yeah, these are the the previous libraries which we are using, so Numpy and Pandas. Now the libraries which we are going to use for the visualization is matplotlib. Okay, so we need to import matplotlib dot pyplot. Okay, so matplotlib dot pyplot as plt, and then another library is cbon. Okay, so these are like two libraries which we are going to use in this session to understand that how we can perform in exploratory data analysis, how we can visualize our data. Okay, now let's first I will give you a kind of an introduction of a single plot or a single chart, and then after that I am going to use a data frame, actual data frame, and then try to make a chart on it, or make a graph on it, and then give you a kind of insights. Okay, so this is the insights, or this is the information which I am getting from this data set. Okay, so let's start with a simple plot. So a very basic and a simple default plot is a line plot. Now if you are able, okay, so what we can do with the line plot, so maybe we have okay, so we need to have two things. Okay, so we need to have a data on the x-axis, and we need to have a data on y-axis. So suppose what we can do is, so we can make this kind of data. Okay, so we can create our own data set. So yield oranges, and then I can give look at, okay, so I am going to see the yield of oranges every year. Okay, so maybe I can make it this way. So 0.78, then a 0.81, then a 0.82, then 0.85, then 0.89, and it will be 0.87. Okay, so 1 2 3 4 5 6, and then I'm going to take a year as well. Okay, so inside a year maybe I can start with 2015, then I can okay, so yeah, 2015, then a 2016, and then a 2017, and then 2018, then 2019. So 1 2 3 4 5, and then 2026. So so we have a value on the x-axis and we have a value on y-axis. Now how I am able to plot this? So for plot this, you need to use plt.plot, a very simple thing, and then whatever the value you want to be on x-axis. So I want like year on the x-axis, and I want yield oranges on the y-axis. Now if you plot this, so this is the graph we are getting. Okay, so I think every year the graph is like goes on increasing. Whatever the situation is, the graph is goes on increasing. Maybe in 2020, maybe because of corona. Okay, so it doesn't affect much, but yeah, it affect a little bit, and it slows down, or it goes down. Okay, and so yeah, okay, fine. So this is a you can say a dummy data set which is created by us. But in other scenario also, in other case also, where we don't have a dummy data set, we can understand like what is all going on in my data set. Okay, so here I can say that, yeah, so the yield is increases year by year, and but maybe because of some reason, or maybe because specifically for the because of COVID, the yield is decreases in the year 2020. Okay, so this is a kind of a thing which we can make. Now one more thing which we can do. Okay, so a kind of a just to make it more sensible. Okay, so if client used to see this like a graph, so maybe he's not able to understand. Okay, so okay, maybe fine. So in this scenario, maybe he can understand, but in most of the scenario, okay, where the on the x-axis we have multiple values, and on the y-axis we have again multiple values, so maybe he's not able to understand, he's not able to make generalization. So what we can do is, so we can plot. Okay, so we can find a x level. Okay, so we can find we can label them. Okay, so how we can label them? So so this is the way to label them. Okay, so on the x-axis there are we have an years. So yes, we are going to put years on the x-axis, and on the y-axis I am having I think I'm calculating the yield. Okay, so means yield per hectare. Okay, so this is what I'm calculating. So yeah, I can write this in the way so that everyone can understand. Okay, so this is what going on in this place. Okay, now if you okay, I can do one more thing. Okay, so I can do one more thing. I can try to plot maybe two things together on a single data set. Okay, so on a single graph, I can try to check the yield of two fruits. Okay, so what I can do is I just try to change the value over here so that it can be more generalized. Okay, so now the graph is goes on increasing, maybe and that is what maybe I want to show. So like the yield of apple is goes on increasing, so even in 2020 the yield is not going to decrease at all. The yield is goes on increasing, maybe not with the pace with which the orange yield of oranges increases, but yeah, with a fixed like a pace, or with a minimum speed, it is also goes on increasing. Now I can make a same thing for apples. Okay, so I can try to make a same thing for an apples. Okay, so I don't need to change a lot. Okay, so yield apple is there, not apples. So yeah, this is a graph which I'm getting for apples. Now if I want to plot this both the things, okay, so means yield of oranges as well as yield of apples on the same graph. Okay, on the same graph or chart. So how I can make it? Okay, or is there like a possibility that we are able to make it in a single a graph? So yeah, definitely there is a possibility, and it is totally possible to make this both the graph on a single plane. Okay, so how what if we can do is, so we just need to write this thing in this way, and then so yeah, fine. I think x-axis is going to be same for everything. Okay, so x-axis is going to be same for both the graph, and that is why it is a possibility. Okay, because if the value on the x-axis also changes, so it is maybe impossible to plot both the things on the same plot on the same graph, but now it is, I think, possible to like create. Okay, because x and y both are same. Now there is one more thing which we can do. So plt dot legend. So what legend can do? So legend can check. Okay, so the first is the oranges. So you are able to give a name. Okay, because here the they you are able to see that the like how, because if there is same color we are not able to differentiate. Okay, but now we are able to differentiate. Okay, so this is the yield of oranges. Okay, in with a blue with a blue line we have a yield of oranges, and with the like orange line we have a yield of apples. Okay, if you want, like you can maybe add the changes, because you are thinking that yield of apples is showing with the orange color. So there is like okay, so you have like significance. You can okay, so you have an attribute. It totally depend on you. You can change it. Okay, so maybe I think we have something called color, or maybe something else through it. Yeah, you have a color. Okay, so now if you know any color, or maybe if you're okay, if you're thinking, okay, so it should be a red in color. So yeah, you can try to make it. Okay, you can try to make it. Okay, so in this place you can make it like okay, we need to check that how okay, so I think you are able to write in this way. So it should be in red color. Yeah, fine. And similarly you can make this for oranges. Okay, so for oranges, if you want to make it a orange color. Yeah, fine. So this is what we can do now. Okay, now let's see that how we are able to generalize this, how we are able to generalize this concept, this graph and chart concept with the real data set. Okay, with some actual data set. Okay, not on a dummy data set. Okay, so I can maybe read one like very popular data set with the okay, so with the help of pandas. So they okay, so pd dot read CSV, and I have a very popular data set with me, like iris data set. Okay, so iris is a very popular like machine learning data set. Okay, and not only a popular, it is the like oldest data set. Okay, and so I inside an iris, so what kind of a data we are having? So iris is a kind of a flower. Okay, so iris is like a kind of a flower, and the data set which we are having, so we are having like 150 rows, means 150 examples, where we have 4 columns to like which represent the like a feature of my data set, sepal length, sepal width, petal length, and petal width. And along with that we have output. Okay, so inside an output we have 3 things. Okay, setosa, versicolor, and virginica. So this setosa, versicolor and virginica is a kind of iris. Okay, so there are like 3 classes of iris data set, or 3 different categories of iris flower. Okay, one is called setosa, another one is called versicolor, and third one is called virginica. Okay, so we have these 3 classes, these 3 categories, and this is what we are able to see over here. Okay, okay, now let's see, let's try to plot it, and then try to make some like insights. So maybe if I directly plot this data set. Okay, so maybe if I try to directly plot this data set, so in a line plot we are only able to plot a numbers. Okay, we are not able to plot like output, or maybe categories. Okay, so we can't plot a categories, we can only plot a numbers. Okay, so what I can do is I can write data dot plot, and then I can give a figure size. Okay, so I can give a figure size. So figure size may be 12, 10. Now if I am able to plot it. Okay, so I think you are able to see the like kind of okay, so it is like I think okay, so you are able to see like a line plot. Okay, so this is what we call a line plot. And actually, so this is nothing but values which is just go up and down. Okay, so like if you're able to see the value of sepal length, so first it is 5.1, then 4.9, then 4.7. Okay, so this it's the same thing. Okay, so the same thing is represented over here, but here we just have 5 or 6 values, so that is why we are getting this kind of a graph. But now we are having 150 values, so we are getting this kind of a graph. Okay, now what we can observe from this like a plot or from this chart is you can like make one observation, or you can try to make try to get a simple insight that in which variable. Okay, so there are like 4 variables or like 4 features, so in which feature or in which variable the fluctuation is high. Okay, so if you're trying to check, okay, so the fluctuation in like in a green color feature, okay, whatever the green color is, so you are able to see from here the green color is nothing but a petal length. So the fluctuation in petal length is very high. Okay, so the fluctuation in petal length is very high, whereas the fluctuation in like petal width is, yeah, it is lesser than petal length. Then I think the fluctuation in orange color means a sepal width is like a very less. Okay, and similarly the fluctuation in sepal length is also less. Okay, so this is a kind of a graph, this is a kind of a, sorry, observation you can make from this graph. Okay, so you can simply write that the fluctuation in petal length is very high. Now okay, so this is like a fine with a line plot. Okay, so this is like this is enough for the line plot. Now we can check something for a scatter plot. Okay, so let's first see that how many categories we have, although I already told you that you have this much of a category. But yeah, you can check it by yourself. I think inside a pandas we already learn about value counts function. So with the help of value counts, we are able to see that a 50 setosa is there, 50 virginica is there, and for 50 versicolor is there. Okay, so now just try to make a scatter plot. Okay, so for a scatter plot, now I'm going to use a seaborn library. Okay, although we can make it with a matplotlib also, but yeah, it's like yeah, we can try to check with other libraries also. Okay, so scatter plot we can draw with the help of a seaborn library. So what we can do is, for a scatter plot also you need to have 2 things. Okay, so you need to have a value on the x-axis. So maybe value on the x-axis is maybe you can take a petal length. Okay, so you can take a petal length on the x-axis, and on the y-axis you can take anything. Okay, so it totally depends on you. Okay, so maybe I can take a petal width. So on the x-axis I'm trying to take a petal length, and on the y-axis I'm going to take a petal width. Fine, and then I'm going to take a u. So u denotes a color. So actually I'm going to okay, so you are able to see that why I'm using a kind of a u over here, and I'm using this u with the outputs. Okay, so SNS, oh sorry, SNS dot, we have a scatter plot, not scatter. Okay, fine. So I am taking a u to like make this kind of a differentiation. Okay, so I want to make a differentiation on the basis of different category or different different category of a flower. Okay, so I have 3 categories. Okay, so setosa, versicolor, and virginica. So I want to make differentiation on the basis of this, and that is why I take I just make u on output. Okay, on output itself. Okay, so so setosa is represented with the like blue color, then versicolor is represented with the orange color, and then Virginica is represented with a green color. Okay, so I'm able to make this kind of a differentiation. Okay, now and a scatter plot. Okay, so by using this scatter plot, although it is not going to give you the same kind of insight or same kind of a knowledge with every data set, but with this data set, with regard to this data set, you are going to get a very good idea, a very good insight for your like complete data set. Okay, so now if you try to okay, so if you try to see your graph, okay, so if you're trying to see your graph, so you are able to generalize that what you can do is, so you can like make a single line on this place. Okay, so you can make a single line, so maybe at 2.2 or maybe 2.3 you can make a single line. And what kind of remark you can make, okay, what kind of remark you can make, that okay, so a kind of a hypothetical model you can make on the basis of this scatter plot itself. Okay, so definitely we are going to make like a model, we are going to make a machine learning model to make a prediction. Okay, so if any new flower comes into the existence, and if this and this is petal length and petal width, then what may be the possible flower it is. Okay, what may be, okay, so in which category the flower is going to fall. But here you can make a hypothetical model on this on the basis of this observation, that if your petal length is lesser than 2.3, okay, if your petal length is lesser than 2.3, then the flower is going to be a setosa. Okay, what like this is like a mind-blowing thing. Okay, so this is a kind of like a genius observation you are able to make over here, and you are able to make a like a very well setted hypothetical model. Although if you are not able to like make this, you are not able to say this thing with 100% confidence, but you are able to observe one thing from both the graph, okay, from the line plot also and from the scatter plot also, that petal length is a very very important feature for your data set. Okay, so and why I'm saying that, so suppose if I remove a petal length and if I take a sepal length, so you're not getting yeah, you are not getting uh, that much. Okay, so okay, so although here also you are able to make a boundary, but the boundary which you are making is not like, okay, with the petal width also you are able to make a boundary, but yeah, you are not able to make a boundary with the sepal length. Okay, and the boundary which you are able to make with the petal length is more wider in comparison to petal width. Okay, so that is why I am able to say that petal length is much better, or like is a way important feature for your data set. Okay, to make a model, to make a predictive model, or to make a statistical model, petal length is a much important feature for your data set. Okay, so fine, this is what we are able to see. Although, and one more thing, like it is not possible for us to make a graph, to make with the sepal length and with the petal length, then sepal length and sepal width. Okay, so this is not possible at all. So what you can do is, so you can try to plot each permutation combination in a single shot by using something called a pair plot. Okay, so by using something like by using a concept of pair plot, you can plot each combination in a single shot. Okay, so how you can make it? So SNS dot set style, and then you can plot a pair plot. You can draw a pair plot. U is equals to the outputs, and then you can like plot this thing. So plt dot show. Okay, now it will take some time, and you are able to and you can think by yourself that how many plots you are going to see, because okay, so this is just a permutation combination. Okay, so I am able to see like 16 plots, and now you are able to check with a scatter plot that which feature is much better. Okay, so you are able to see with the sepal length and sepal width, then sepal length and petal width, then sepal length and sepal length and petal length, and sepal length and petal width. Okay, now you are able to see with sepal width. Okay, then you can make a comparison with petal length, and then we can make a comparison with petal width. Okay, now if you're trying to see the graph, the petal length section, so everywhere, okay, so it doesn't matter that whatever the second value is, whatever the second feature is, you are able to make a like kind of a like a boundary with each graph, and even with okay, and with a petal width, it's give you a much better boundary. Okay, it gives you a much better boundary. Okay, you are not able to get this kind of a boundary with sepal length and sepal width. Like here also you are able to get a boundary because you are having a petal length on one side. Okay, petal width okay, and with petal width you are able to get a boundary, but this boundary is not more wider than this. Okay, so this is what I'm trying to say, that petal length is a very important feature, is very important feature for your data set and for your modeling. Okay, now okay, now just try to make some more insights. Okay, and for that I'm going to take another data set. Okay, again a Titanic data set. Okay, so I'm going to read the Titanic data set for you, and I'm trying to make some more insights. Okay, so now I think in the last class itself, in a Panda section itself, we explored this data set a little bit. So we have a passenger ID, survived, and then P class, name, sex, age. So all this column we are having. Now there is one very important and a very interesting chart or plot we are having, which is called a box plot. Okay, so box plot is going to give you a very good insight or very good knowledge about a data set, that whether your data set contains an outlier or not. Okay, so you are able to see most of the times that your data set is having an outlier. Okay, outlier means kind of a value which is very far away from a normal distribution. Okay, which is a very far away from a normal data set. So that value is considered to be an outlier. Okay, so now let's try to check whether your data set, and you are able to see this kind of a graph only with respect to a numerical data. Okay, so now just try to check with an age that whether your age column is contain an outlier or not. Okay, so train age, and then like make the orient is equals to V, so that I can able to see my graph in a vertical way, not on in a horizontal way. Okay, so this should be a DF. I have a data frame. Now, okay, so this is a box plot. Now, what this box plot is represent? Okay, so this box plot is going to represent that this is a minimum value. Okay, the value. Okay, so this line on the like below or on the footer, this represents the minimum value. Then this represents the like 25th percentile. Okay, so I think you are aware about a percentile concept. So this represents the 20th percentile of your data set. Okay, so 20, the value 20 is the 20th percentile of your data set. Then this value, maybe you can say 28. Okay, it is very close to 30, so it may be a 28 in my knowledge. So this is a median or 50th percentile. Okay, so median and 50th percentile is the same thing. Then this value, okay, maybe a 38 or 39, this value is going to be a 75th percentile. Now this is a maximum value. Okay, so the box plot is going to show you a kind of a normal distribution. Okay, so it assumes that if my data set is normally distributed, or it assumes that in a normal distribution graph, so this is a minimum value, this should be a maximum value, this should be a mean, this should be percentiles and all. And now the data which is beyond this beyond this maximum value. Okay, so our maximum value should be like 63 or 64 something, but now I am getting a data beyond this 64 also. So now this data, this particular values are considered to be an outlier. and this is a way of checking an outlier. Okay, so now I can say that yes, my data set contains an outlier. And if you're able to, if you want to like clarify this thing, so what you can do is you can try to plot any data of maybe iris. Okay, so you can try with a petal length or maybe a sepal length. Okay, so maybe you can try with the like a sepal length. Okay, so a sepal length in centimeter, and you can plot it. Okay, so you're not getting a single outlier over here. Okay, so the minimum value is maybe a 4.2, then this is the 25th, 50th and 75th percentile, and the maximum value is 7.9. Okay, so you are not able to see a single outlier over here, but here you are having an outlier. Okay, so whenever you get this kind of dots, maybe on the right hand side. Okay, so on the positive side, or maybe you can get this kind of a dot maybe on the negative side also in some cases. Okay, so it means that you are having an outlier. So now you can say there's my age column contains an outlier. Okay, so you can write this observation. Okay, so you can write this observation that yes, my age contains an outlier. Now one more thing, or you can say a very like last and interesting thing, the same thing I think which we did in case of a pivot table. Okay, so I think in case of a pivot table, I'm making a bivariate or multivariate analysis. So till now, with the help of all this graph and chart, I think I'm just trying to make a univariate analysis. But suppose if I want to make a bivariate analysis, okay, so maybe if I want to compare two things, or maybe if I want to make a multivariate analysis, so can I make that? Okay, so is it possible to make that kind of a graph to like compare two things? Okay, so a kind of a graph which give you a kind of a comparison between two variables. Okay, so is it possible? Okay, so let's check whether it is possible or not. So SNS dot bar plot. Okay, so there is like, I think you are aware about what kind of a graph you are going to get with the help of bar plot. Okay, so it's just a bar chart. I'm going to take like on the x-axis, I'm going to take a p class. Okay, and the same thing I'm going to plot over here, which we already analyzed with the help of pivot table. But now I'm going to analyze the same thing with the help of a graph. Okay, so it gives you more like better insight, more better view. So, and then on the y-axis, I'm going to take a survived. Although this things can be changed, and I'm going to make a differentiation with the help of sex. Okay, you. Now the name of my data set is nothing but a df. Okay, so now this is a kind of a graph I'm getting. Okay, so on the basis of sex, so I just take sex as an output. Okay, which I take in case of iris also. So I just take sex as an output through which I'm going to give a color, and then so on the x-axis I'm having like a kind of a probability. On the y-axis I'm having a kind of a probability of like a survived, and on the x-axis I'm having my p class, passenger class. Okay, so you can say that the male from passenger class 1 okay, so a complete observation tells you that a female from all the classes, no matter irrespective of the classes, females are survived more in comparison to male. So this is the very first insight or very first observation you can make. Now the second observation what you can make is, so a male like a male from passenger class 1 is survived more in comparison to passenger class 2 and passenger class 3. Okay, now a kind of observation you can make that a female in passenger class 3 is survived less in comparison to passenger class 1 and passenger class 2. Okay, so and a female passenger from first and third class is survived more. Okay, uh, and the male of passenger and both the male and female of passenger class 3 have a very less chance of a survival. Okay, so these are all observation you can make, and these are all observation you can write in on write as your observation. Okay, so as your observation you can write all those things. So there is one thing which is called a markdown. So
you can make a you can make a use of markdown, and you can write your observation. So yes, you can write like I can give you a single example, that a male and female from passenger class 3 have less chance of survival, have very less chance of survival. Okay, so fine. I think this is like enough to understand with the help of with the visualization theory. Now in we are able to move on to our machine learning part. So we are okay, so we are going now now I'm going to okay, so now we are going to discuss the introduction of machine learning and applications, and then we are ready to with our first algorithm, linear regression, and then we are going to discuss all the algorithms one by one. Okay, so that's all from EDA section or visualization section.
Hello, so my name is Shivam, and today I'm going to talk about a machine learning system, and along with that, I'm going to talk about linear regression model, which is a very first and basic algorithm of machine learning. And then we are trying to implement something, and then trying to check whether okay, we are able to do a kind of a prediction or not. Okay, which is a core concept of machine learning. So machine learning is all about finding the patterns in our data set, and based on that pattern we are trying to make a decision and prediction for the future. Okay, so what we have actually, so we have an input also. Okay, so in a machine learning system we have an input, along with that we also have an output. Okay, so we have an input and we have an output, and then we apply our machine learning system, or you can say our machine learning algorithm. So we are going to apply our machine learning algorithm. Okay, so ML algorithm. And now this algorithm or the whole system is going to give us a rule, okay, or pattern. And then based on this pattern and based on this rule, we are going to take decisions. Okay, so now based on a real data set, okay, based on actual data from the real world scenario, we are going to take a decision, or else we are able to make a prediction. Okay, so this is what we call a machine learning system. Now the whole idea, okay, so this whole concept can be divided into two categories. So one is called supervised. Okay, one is called supervised and another one is called unsupervised. Okay, so now in this complete session we are going to discuss, or we are going to focus more about a supervised learning. Okay, because supervised learning is a thing. Okay, so suppose if you try to find out a scenario from a real world data also, so a 70, or you can say, yeah, or 70 or 75% of the data, or 75 or 70 or 75% of the cases comes under the supervised learning category. Okay, just a 25 or 30% 25 or 30% of data, or 30% of cases comes under to the category of unsupervised learning. Okay, so we focused more on kind of a supervised learning. Okay, so in case of a supervised learning also, we are trying to divide our problem. So based on the data which are available, we are trying to divide our problem into stage or two categories. So one is called or you can say there are two kind of a task in case of a supervised. So one is called a regression, another one is called a classification. Okay, now in case of a supervised learning, you have a input data. Okay, so you have an input data. Okay, or you can also call this input data as a features. So you have an input data or features along with you, and along with this input data and features, so suppose you have a feature 1, feature 2,
feature 3, feature 4. So along with all these features, you have an output data also. Okay, so you have an output data also, and this is also called a target. Okay, means you already know that what you are going to predict. Okay, so suppose there is a problem statement that there are like some features of people person is given. Okay, so maybe their blood pressure level is given. Okay, or maybe their diabetes level is given. Then their like maybe sugar level is given. Okay, okay, and then maybe here hemoglobin is present. Okay, so and based on this 4 feature, we need to predict whether the person is having a diabetes or not. Okay, so here we have maybe a 2 classes, yes or no. So now so here I am having feature 1, feature 2, feature 3, and feature 4. And so suppose I have a data of maybe 100 patients. Okay, so maybe I have a data of 100 patients, and uh, corresponding to this 100% data, we have like our label also. Okay, so we have a label as Y or N, yes or no. Now we are going to train our model. We are going to train our model on the basis of this on the basis of the data present. Okay, so on the basis of this 100 data, we are going to train our model, and then on the new data set. Okay, on the new like suppose now a new person come into the existence, a new patient come into the existence, who's having a blood pressure level maybe something, and then glucose level maybe something, diabetes level maybe something, and maybe a hemoglobin something. Now based on all these 4 new features, we need to predict whether the person is having a cancer, having a diabetes or not. Okay, so this is what like we call a this is what we call a supervised learning. Okay, so we already know that what we need to predict, and what is our class label that we are going to predict. Okay, so we work under some kind of a supervision, because we already know the criteria, we already know that this may be the possible result. Okay, and then when a new person comes into existence, we are able to check whether he's having a diabetes or not. So this is what we call a supervised learning. Now in case of unsupervised learning, only this data is given, only the input data or maybe the input features are given, this output or target is not given. So what we can do is, so in case of unsupervised learning, what we can do is we are trying to make a clusters. Okay, so this is what we call a clustering. So if you take an example, so suppose there is a okay, you can say that maybe okay, so I can take a very good example and scenario for you to understand the case of unsupervised learning. Okay, so maybe you have just 2 input data. Okay, so you have just 2 input data which is given. So one is like age. So on the x-axis, suppose you have an age, and on the y-axis you have an expenditure. Okay, so these are so this is input data which is given to you. Okay, and no other information is given, no output data or maybe labels are given. So what you can do is, so you can do one thing. Based on their properties. Okay, so based on their properties or based on their liking, you can make a cluster. Okay, so maybe there are some people in this entire world whose age is lesser, whose age is very less, and along with this, okay, so their age is also less, and along with this their expenditure is also less. Okay, so age is less and expenditure is also less, so you can make a cluster of this kind of a people. Okay, and then there are another kind of a people in this entire world whose age is very high, very high. Okay, so the age is high, but the like the expenditure is very less. Okay, so the expenditure is very less. Then there are like some people in this entire world whose age is very less, but the expenditure is very high. Expenditure is very high. And then there are another kind of people in this entire world whose age is very high, and along with their age, expenditure is also very high. So this is also one kind of a cluster. Okay. Now you can name this cluster. Okay, so based on the data which is given, based on the input data only, you are able to make a cluster. You don't know that what you need, what exactly you need to predict, but you are able to make a cluster. Now you can make this a cluster 1, cluster 2, cluster 3, and cluster 4. Now any new person come into the existence. So suppose a new data comes into the picture, and their age is something, and their expenditure is something. Okay, so their age maybe A1, and then expenditure maybe E1. So now based on this number, what may be the A1 and E1, you are able to classify it. Okay, so now this new person, okay, so this new person is going to fall into this cluster. Okay, or maybe this cluster, or maybe this cluster, or maybe this cluster. Okay, so this is what happened in case of unsupervised learning. You can like name this cluster with your knowledge. Okay, so maybe you can call this kind of a people as a mature person. You can call this kind of a people as an immature person. Okay, so it is based on your knowledge. It's not like it's not a sure thing that they are the immature or a mature people, but yeah, based on your knowledge, you can make this kind of a cluster. You can make this kind of a classification. Okay, so this is what happened in case of unsupervised. Okay, so I think you guys are able to understand the idea of supervised and unsupervised learning and how they are differ from each other. Now I am going to take like example of supervised learning. So in supervised learning, we are going to perform a supervised learning, and we are going to check we are going to check the algorithms of supervised learning. Okay, so as I told you that in case of supervised learning, you have two kind of tasks. One is a regression, another one is classification. Now a very uh, thick difference between a regression and classification is, so if your output data or if your target variable is divided into some classes, okay, maybe yes or no, maybe male or female, maybe any kind of a classes, C1 or C2, or maybe it may be a multi-class also, C1, C2, C3, C4. So if your output data is a discrete random variable, so I think you are able to understand the difference between discrete and continuous random variable. So in case of a discrete random variable, you don't have a number in between, you don't have any number in between two numbers. Okay, so in between 1 and 2, you can't have any number. So this kind of a data is called a discrete random variable. Okay, where you have just 1, 2, 3, 4 in this way. So if your data is having if your data represented in this form, 1, then 2, then 3, then 4, so this kind of a data is called a discrete random variable. Like so this kind of a data is called a discrete random variable. This kind of a variable is called discrete random variable. You can take a very simple example, like if you throw a dice, so the chance of coming of any number, maybe, so a number can be a 1, can be a 2, can be a 3. It can't be a 1.5, it can't be a 2.5, it can't be a 3.2 or 3.4. Okay, and similarly, if you throw like if you toss a coin, then also you, if whether you get a head or whether you get a tail. Okay, so this is what we call a discrete random variable. Okay, so this is the difference. In case of a regression, your output variable is going to be a continuous random variable. So continuous random variable means if between two numbers, maybe in between 1 and 2, you may have a infinite numbers. Okay, so if I want you to predict the height of a person, if I want you to predict the weight of a person, if I want you to predict the price of something. Okay, so this kind of when you are having this kind of a scenario, so this is going to be a regression. Okay, this is going to be a regression task. Okay, so this is a very simple difference or very simple idea of a regression and a classification task. Okay, now let's start. Now let's jump on to our algorithm. I think you are able to understand the basics. You are able to understand the like kind of a data. Now let's start with a linear regression model. So linear regression is a kind of an algorithm. Okay, so linear regression is a very basic and simple algorithm, and the idea is very simple. Generally, this linear model makes a prediction. So it makes a prediction by simply computing the weighted sum of input features, means whatever the input feature you are having. Okay, so maybe f1, f2, f3, f4. So the weighted sum of those input feature plus a constant term which is called bias. Okay, now this is a representation. Okay, so I think you are able to relate this representation which you with your childhood learning. Okay, so I think in our childhood we learn about something we learn about this kind of an equation which is called equation of line, y equals to mx plus c. And so this equation is very similar to that particular equation. Okay, so theta naught plus theta 1 into x. Okay, so here I am able to represent my slope and bias with thetas. Okay, you can also maybe somewhere you are able to see this thing representing with the with w and b. Okay, so that is also a very same thing. Okay, that is not that is not different at all. And maybe if we are having, so this is so this equation is when we are having just one single feature, and this equation is applied when you are having a multiple features. Okay, and this is what we are now I think you are able to understand this equation. But the thing which actually we are trying to do in case of a linear regression is suppose you have something. Okay, so maybe based on an area. Okay, so maybe based on some areas given, you try to predict the price of a house. So maybe on the x-axis you have an area, and then on the x-axis you have a price which you need to predict. Okay, so what you actually trying to do, so the area is spreaded, or the area or price may be spreaded in this way. Okay, so this is a kind of a spreadness which is present inside your data set. Now what your task is to find out a best fit line. Okay, so your task is to find out the best fit line. Okay, and that is why we are using the equation of line. Okay, because we need to find out this line. Okay, we need to find out this line which is called a best fit line. Okay, so what so we can so this may be your best fit line, or this may be your best fit line, or this may be your best fit line, or this may be your best fit line. Okay, or this may be your best fit line. Okay, so you are trying to trying with a different lines, and the core idea is to find the best fit line. Okay, so best fit line is what so best, the very simple definition of best fit line, the line which is going to touch most of these data points. Okay, so which is going to cross a most number of data points which is spreaded in this region. Okay, so you need to find that line which crosses most of the data points, and that line is called a best fit line. Okay, I think you are able to understand the understand that what exactly we are trying to find out. Okay, now I think with a very simple example I will explain you that how this mathematics is going on in behind. Where definitely in case we are having a Python with us, so we don't need to worry about a mathematical equation, because we have a library scikit-learn where we need to import the library and we are able to do the calculation. But you actually need to learn, or you actually need to know that what exactly the equation going on in behind. Okay, what exactly the mathematics going on behind. And actually in this case, okay, so at least in case of a linear regression, that mathematical equation is not very tough. The kind of a mathematics is not very tough at all. Okay, so at least in this case you can generalize that equation or generalize that mathematics. Okay, so suppose suppose the height of a person is given and the weight is given, and I need to predict the weight. Okay, so this is the data of some students. So 5.6 is height, then weight is 60. 5.8 is height, then weight is 62. Then 5.4 is height, then weight is maybe a 59. Then 6.2 is height, then the weight is maybe 72. Then 6.3 is height, so weight is maybe 74. Okay,
And likewise, suppose in case of 5.9, I need to predict what may be the possible weight. Fine. So maybe this is a problem statement, or this is a scenario given to you. Now, according to the equation, okay, so if I try to write down this equation, so one more thing which you need to understand, that in this case, I have written fx or y hat. Okay, so this is not, I didn't write a y, I write a y hat. So y hat means what? So this y hat means a predicted y. Okay, predicted y, because this is our predicted value. Okay, so predicted y. So I'm going to find out the predicted weight. So how I'm able to find out? So first we need to find out that weight and biases, that theta and theta naught, it called as a weights and biases. So I need to find out like first weights and biases. So how I'm able to find out the weights and biases? So suppose the weight is 60, then I'm able to get, okay, so the equation is like theta 1 into 5.6 plus theta naught. So this is maybe equation 1 we are having. And then in second case, we are having 62 theta 1 into 5.8 plus theta naught. This is the second equation. Now, I think in our childhood, we do like we do a lot of this kind of a calculation. Okay, so with the help of equation 1 and equation 2, we can get a theta, we can try to apply a elimination method, and by applying a elimination method, we can find out the value of theta 1 or and theta naught. Okay, so by applying a elimination method, if you try to you can do by yourself. Okay, so or by applying elimination method, or what you can do, you can just pull out a theta naught from here. Okay, so you can write theta naught as 62 minus 5.8 into theta 1, and then you can put this value over here, and then you can find out the value of theta 1. Okay, so you can do this thing, although I give you the result. So theta 1, after a calculation, you are able to get, or you can pause the video and you can do the calculation by yourself. Okay, so theta 1 is going to be 10, and theta naught is going to be 4. Okay, now just try to apply this thing with your equation. Okay, so what is my predicted weight? Okay, so w hat is equals to theta 1 into 5 point maybe if I try okay, so I can try to find out the weight of the next person, 5.4, and then theta naught. So what is theta 1? 10 into 5.4 plus theta naught is 4, so this is going to be 58. But my actual weight my actual weight is 59. Okay, so my predicted weight is 58, but my actual weight is 59. So this is what we this is a kind of a error, or this is a kind of a loss I'm getting over here. Okay, now the idea in case of a machine, in case of a linear regression, is we need to find out this loss on the very first place, and then the main thing in case of a linear regression, or in case of any machine learning model, we try to optimize our equation, and we try to reduce this loss. Okay, so how we can do that? So first we need to calculate the loss or error, which can be calculated with the help of mean squared error. Okay, so mean squared error, and then there are like different ways of calculating this. You can find out a mean squared error, you can find out a root mean squared error. So what is mean squared error? So mean squared error is going to be w minus w hat whole square. So this can be 1/2 also, and this can be 1/n also in some cases. Now this is going to be 1/2 into 1, which is going to be 0.5. Okay, so 0.5 is your loss, 0.5 is your error. Now our job is to minimize this error. Now, so this is the equation. This is like optimization equation in case of a linear regression model, and you are able to find out the optimization equation in each and every case. Okay, so this is the loss function. So the mean squared error is your loss function, and now this is the optimization equation. Optimization equation for linear regression model. Okay, so what optimization equation says is we need to find out we need to find out such thetas and such theta naught. Okay, so we need to find out such thetas and such theta naught, so that the summation of I equals to 1 to n, because we need to sum up all the loss. Here I just try with one like single loss value, but we need to sum up all the loss. So theta 1 into x1, okay, plus theta naught minus actual y, okay, means actual w or actual y, you can say. Okay, so just rough it and make it y. So y minus y hat, in a simple sense, y minus y hat divided by n. As I told you that it can be n somewhere or it can be 2 also. So we want such theta and theta naught, so that our like loss should be minimized. Okay, and this is the optimization equation for linear regression, and this is our objective. Okay, so this is our objective, and so what we are able to achieve with this objective, we are able to get that best fit line. Okay, so we can try with the multiple lines, and then we are and then finally, so after a multiple iteration or after a multiple trying, we are able to get that that best line. Okay, and that is what happened in case of a linear regression. Now there is a like one very important concept which you are able to understand only with the help of a linear regression. Okay, so now one very important concept which you can understand over a much better way, although that is a like kind of a general concept which can be understandable by any machine learning algorithm, but with the linear regression it's like very it's way easier, or it's like simple to understand. Okay, so that is what we call a bias variance trade-off. Okay, now what is the meaning of bias variance trade-off? So there are like a two kind of or maybe a three kind of a model which we are able to prepare by using any machine learning algorithm. Okay, so maybe if I try to make a model with the help of a linear regression algorithm, so suppose my data is spreaded in this way. So my data is spreaded in this way, and this is a very like good representation of my data. Although this kind of a data, finding this kind of a representation like is very tough job, but yeah, maybe my data is presented in this way. But hypothetically, or just by as I am biased towards something. Okay, so there is something, there is a word called bias. Okay, so what I think you are or you all aware about this term, a bias. Okay, so bias means what? Maybe whenever you just biased with one thing, and you're not trying to understand the other scenario. Okay, so I think this is a very famous quote, that every coin has two faces. Okay, yeah, this is a very famous quote, maybe quoted by someone. So every coin has two faces. Okay, and we need to so before making any kind of a judgment, we need to understand the both the faces. Okay, but like there are so many people in this entire world who are like just biased. Okay, so they are just biased towards one face, and in India there are a lot of politics. Okay, so you can take an example, like there are some people who are just biased with the towards one party, or maybe there are like a lot of people who are just biased for like MS Dhoni, and they are doing a comparison maybe in between MS Dhoni and Virat Kohli, or maybe in between Virat Kohli and Rohit Sharma. And then there are like more people who are interested in football, so they are like just fighting for Ronaldo and Messi. So this kind of a biasness is present in this entire world. Okay, so this kind of a biasness is present in this entire world. So likewise, if we if our bias is very high and if our variance is very low, Okay, so if the bias is very high and the variance is very low, so hypothetically what you can do is, so you don't try to find out the best fit line. You just take a single equation and you just stick with that equation. You just stick with that mathematics, and then you are saying that no, I'm not going to generalize it. I'm not going to I'm not going to do like lot of mathematics. So I'm not going to find I'm not going to do a lot of mathematics and all. I'm just stick with my own concept, and I'm going to draw a straight line from wherever I want. Okay, so maybe from here you draw a straight line. Now this straight line is not going to touch most of your data points. Okay, and this straight line is not going to give you a better result or maybe a good performance for the model. Okay, so now in this case, what happened? Your bias is very high, your bias is very high, and your variance is very low. Your variance is very low. And now this becomes a underfitted model. This is what we call underfitting. Okay, so this is what we call the underfitted model. And this concept is called underfitting. Now, if I take a second scenario or second case, so what happened inside a second case? So suppose my data is spreaded in this way again. And now I am trying to build a model in this way. Okay, so this kind of a model or this kind of a model is called a overfitted model or overfitting. Because what happened in this case, your variance is very high and bias is low. Okay, so what I mean by your variance is very high, so there are some people in this entire world. Okay, so like there are few students in your class itself who are very uh, okay, so there are like some people, there are some students in a class who crying even after getting a 90 marks or even after getting a 95 marks. So they are crying just for that 5 marks or just for that 10 marks. Okay, so this kind of these kind of students are really ridiculous, because they are fighting, or they are fighting with the teacher, or maybe they are crying just for 10 marks or just for 5 marks. Okay, so it means what, they are not able to digest those like 10 marks error also. Okay, so so this kind of a like stubborn child is considered to be a overfitted model. Okay, so this kind of a stubborn child is you are not going to digest a mistake. You are not going to digest a single mistake. Okay, but this can't have this can't like this will not going to happen in a real world scenario. Okay, so in a real world scenario, your model or whatever the things, suppose if you make any kind of a hypothesis, so that hypothesis may be a wrong also. Maybe at some place that hypothesis or that kind of a model is maybe a wrong with some cases. Okay, because there is a lot of exception also. But if you are trying to touch each and everything, so that is what we call a like a very high variance. Okay, so a lot of fluctuation is there. So this kind of a model is called overfitting model. And now if you okay, and there is one more example through which you can understand, because what happened inside a underfitting model, so your training result, okay, your training result is also very low, and your testing result is also very low. But in case of overfitting, your training result is very high. Okay, means when you train your model, so your training result is very high, but in actual sense your testing result is very low. So you can take another scenario, like suppose there is an exam tomorrow, and somehow you are able to find, maybe somehow or somewhere you are able to find that these are the questions which are going to ask in examination tomorrow. Okay, so what you can do, you just go through all those questions by, okay, so you can find like answer from somewhere, and you can go through all the questions by and then you just memorize all the answers, and in the next and on the next day you are able to get a high marks. Okay, so you are able to get a very high marks in an examination, because each and every so each questions you already know, and you are able to memorize it. But what happened in an interview? Okay, so you are able to get a 90% mark, so definitely in an interview, interview can think, okay, so this is a very bright student, I'm going to ask maybe some tough question with him. Now when he asks a tough questions with you, so you are going to fail at all, because you didn't learn those things in an for an examination. You didn't learn those things, you just memorize it. Okay, so whenever your model do this kind of a memorization, whenever your model just try to just memorize the thing instead of learning, so that is what we call a overfitted model. That is what we call a overfitting. Okay, so this is a case of overfitting. So we don't want a overfitting, and we don't want a underfitting as well. Okay, so we don't want a very high bias, as well as we don't want a very low very high variance. Okay, so that is why it is called a trade-off. Okay, so if there is a high bias, the chance of underfitting increases. If there is a high variance, the chance of overfitting is increases. So we want both optimal. Okay, so we want a optimal bias, and we want or you can say average bias and average variance, to get a generalized model. Okay, so generalized model is what? So there may be any error. So if there is no outlier, so this kind of a data is considered to be an outlier. But in case of overfitting, you're going to take this data also. So but in case of a generalized model, you're not going to touch an outlier. Okay, so we want a generalized model where our bias is low, variance should also low, and our data is and with that we are able to get a good accuracy on the training set also, even on the testing set also. Okay, so this is what we called a this is what happened in case of this is a very good and important concept which actually ask in an interview. So this is a very first question which interviewer may ask in an interview, that is that what is a trade-off between bias and variance. Okay, so I think this part is completed. We are able to complete the theoretical and as well as a mathematical part of linear regression. Now let's jump on to the uh, implementation work. Okay, so let's try to use Python, and then try to implement something with this. Now I'm going to show you that what kind of a data I'm having, and then what kind of a prediction I'm going to make. Okay, so to read data, I think we already know that we have a pandas, and maybe we can also import our basic libraries such as a Numpy also. Maybe it can help you somewhere. Then for visualization, we can import a matplotlib .pyplot as plt, and then at last I can import Seaborn. Okay, so pandas, Numpy, matplotlib, and Seaborn. Now it's time to read the data. So for reading the data, you can write pd.read CSV. Okay, so if you are having a CSV file, suppose if you are having an Excel sheet, so you can read in that way. So I think this is my data set, housing.csv, because we are going to predict the price of a house. Okay, so you just need to copy the path and you need to paste it here. Now if I show you the data set, so this is looking in this way. The data set looks like in this way. Okay, so this is my data set. Now I'm having a price on the very first place, and then these are my features. Okay, so we have an area, then bedrooms, bathroom, stories, main read, guest room, basement, hot water heating, air conditioning, parking, prefer area, okay, pref area, and then furnishing status. Okay, so this is like my data set. Now if I'm trying to check the shape, so this is the shape of my data set. Okay, so 545 rows are there and 13 columns are there. Okay, so 545 rows are there, 13 columns are there. Okay, so now we need to okay, so I think this is kind of a data set which is given to us. And now the very first thing which you can do, you can try to find out the information about your data set. So data.info, and this data.info is going to give you some very good insights. So you are able to get that there is no null values. Okay, so there is no null values present inside my data set. Then the second thing, you have a 6 integers and 7 objects. Okay, so a 7 column is here, which is in the form of you can say object, okay, or string. Now the very first thing which you need to do is you need to do the exploratory data analysis, means a EDA. You need to perform an EDA. Maybe so to like check to do a kind of a analysis. Okay, so to do a kind of an analysis, you can try to make the some EDA, some kind of basic graphs. And then one more thing which we can do, maybe with the numerical data, you can try to find out the like correlation. Okay, so I will show you just with the 1 or 2 plot, because that is enough in this case. So I can make a count plot, and on the x-axis I can take okay, so I can make a count plot of what? Okay, so maybe in this way I can make a count plot that on the x-axis I can take my, okay, I can try to plot all this count plot to check how many like features are available. So what I can do is I can try to plot all these objects together. So for that I can use a subplot plotting. Okay, so plt dot subplot, and then a total number of rows, maybe I can take 6 at one time, and the column which I'm going to take is just 1, and then I can give a fixed size. Okay, so fixed size maybe in between 12 to 10. Okay, now let's take a look. Now calls. So for a better representation, we can make it in this way. So I can use data.columns feature so that I can get all the columns over here, also here itself. Now the object, the like object. Okay, so whether there is a guest room or not. Okay, so these are the things which I can plot draw over here. Then a basement, so whether there is a basement or not. So I think everything is just in a form of yes or no. So we don't we need not to do more mathematics and like feature engineering. Then hot water heating is available or not. Then air conditioning system is available or not. Then fourth is a pref area, and then one is main road. So whether this is on the main road or not. Pref area is not important. Then we can check the furnishing status. So what is the furnishing status by? Then so I can take we can run a loop. So I hold in enumerate codes. Okay, so just plot the count plot. So on the x-axis I have all the column. Then a data is equals to data itself, because the name of my data set is data itself. And then ax is equals to ax I. So figure size photo with 0 axis. Okay, where it is 0 axis by, so n rows we have 6 rows, n calls we have 1 calls, fine. And then fig size is going to be
Okay, so this is going to be 16, like 12 cross 10. Maybe it should be something more. Has no properties and rows. Okay, so N R O W S. I think this is a property. Okay, so fig AX is equals to a PLT dot subplot. Okay, so I think this should be a subplots. Yeah. So I think you're able to see that mostly it is a yes no thing. Okay, so and most of the places there is no. Okay, and just in case of air conditioning, so there is a lot of houses where there is a heat where no, there is lot of houses where air conditioning system is not available, lot of houses where hot water heating is not available, basement is not available, then guest room is not available. Okay, and then like most of the houses is a semi furnished. Okay, so there are three categories: furnished, semi furnished, and unfurnished. So a lot of there are like most of the houses which is semi furnished. Fine, so I'm getting this kind of a thing. Okay, now what is the next thing I can do? As I told you that we can try to make a heat map. Okay, so what I can do is, so I just take a numerical feature along with me. Okay, so num data I can take along with me, and inside a num data what I can do, I can just try to make a numerical data. I can just try to put a numerical data. So I can put a price. Along with that, I can put a area. Okay, so price, then area, then okay, so price, area, then I think bedrooms. Okay, although this bedroom, bathrooms, and stories is not going to give you anything, but yeah, then also we can plot bedrooms, then I think bathrooms, and then maybe stories, and then a parking. Okay, so it should be a bathrooms, I think. H is there. Okay, now just I will going to show you one very beautiful graph. So again, PLT dot figure should be there, so that your figure size should be large enough so that you are able to see something, or you are able to visualize something. Okay, now the next thing, core is going to be data. Okay, so a num data dot core, because we have a numerical data with us. Okay, now we are going to plot a heat map. Okay, so SNS dot heat map, and then we are able to give a core over here. Then anode is equals to true. Okay, and then I can give maybe some coloring. Okay, so maybe a C map is equals to PLT dot CM. Okay, dot CM, this color. So this color is quite beautiful to visualize, although you can give a color based on your choice. That is not an issue. So this is a kind of visualization which I'm able to see. Okay, so I can maybe increase this size to show this thing to you in a much better way. Oh, okay, fine. I think this line should be here itself. Yeah. Okay, so now just try to check. Okay, so it is making a very high relation with the area. Okay, so area is very important factor to to predict the price. Okay, because if the area is large, then the price is large. If the area is small, then the price should also be small. Okay, so that is why you are able to see that this two feature is having a very high correlation, not very high, but yeah, this is having a like a good correlation, 0.54. Okay, then with a bedroom 0.37, with a bathroom 0.52, with a storage 0.42, and with a parking 0.38. Okay, so although it is making a correlation, a positive correlation with all the features, but yeah, area is the most important feature. Okay, now this is fine, I am able to understand. Now in case of feature engineering, you need to check at least three things. Okay, so the first thing, you need to check whether there is a missing values. So if there is a missing values, you need to handle that. So I'm able to see that there is no missing values inside my data set, so so that is a very good thing for us. Then the second important thing, you need to check whether a data set whether so if you are having a categorical data also, so if you are having a categorical data, you need to convert it into a numerical one. And the third important thing is scaling. Okay, so you need to check whether all your data set is present into the same scale or not. Okay, so I think you are able to see that price and area is not into the same scale, so you can scale it. Okay, and along with that, you need to convert a categorical data into a numerical one. Okay, so let's convert it. Okay, so you can so that is what we call the handling categorical variable. Okay, so the very first data, which is okay, so just again make it in this way. So data dot d types, maybe, yeah. So like object data. Okay, so I think main road is just yes or no. So wherever there is just yes or no, you can map it with 0 or 1. Okay, so data dot main road, okay, dot replace so just replace, I think there is yes. So let's check also. So yes and no, small. Yes with a 1, no with 0. Okay, so the very first replacement, then the second replacement, third replacement, and fourth replacement. Okay, so the second replacement is I think with the, so we are done with main road. Then we are going to do the same thing with the guest room. Okay, so a guest room, here also guest room. Okay, then the third is like basement. Okay, so basement. Then the fourth is hot water heating. So hot water heating. Okay, and just one, I think one more is left, that is air conditioning or pref area also, 6. Okay, so air conditioning, just make it air conditioning, and the pref area, because you can't change a furnishing status with yes no. Okay, so there is a furnished, semi furnished, and unfurnished. So we are going to take we are going to do this thing, convert this numerical convert this into a numerical with other knowledge, with other technique. Okay, so these are all the things. So this comes into the category of handling categorical variable. Okay, right. Now just try to do with the label encoder. Okay, so from sklearn dot pre-processing, import label encoder. Okay, so now just take a feature. So feature is equals to maybe a furnishing status. Okay. Or just do it in this way. So this is a label encoding technique. So what you can do is, so data, and then you can give a furnishing status, and then you can directly do it. Okay, so this is a label encoding technique. So this so this technique is going to convert your categorical data into a numerical one. Okay, so what you can do is you can just make a object for this class label encoder, and then you are going to fit this data onto this label encoder. So le dot fit transform data of furnishing status. Okay, now if you are able to see your data set, so data dot head, if you are trying to do again, so I think all of your data is converted into a numerical one. Okay, so I think you are able to convert all your data from a category. So you are able to convert all your categorical data into a numerical one, and now all the features are available into the numerical format. So this is what we are able to achieve till now. So a very good and clear understanding I think you are able to make. Now my objective is to apply a linear regression model and then try to find out the result. Okay, so first we need to split the data into a feature and a target, and in a next step we are going to split the data into training and testing set. Okay, because before deploying a model, okay, so before deploying a actual model, we need to split the data into two sets. One is training, another one is testing. So on the training data only, maybe we can split into a 70-30 ratio, or maybe a 80-20 ratio. So on the training data itself, on the training data, we are going to apply some mathematics, we are going to apply our algorithm, and then on the remaining 30% data, we are going to test. Okay, we are going to evaluate our result, okay, whether the result is good or not. So first, inside an X, I'm going to take I'm going to drop just a price data, and I am not doing a scaling over here. So I think you can do the scaling by, you can try the scaling by yourself. Otherwise, in the next session with some other data I can apply, or maybe if the result is not very good, so it just again a 2 or 3 lines of code. So I will try to make it over here. Okay, so you can what you can do is you can drop the price. Okay, so you can drop the price from axis equals to 1, and inside of y I can have a data draw a dot. So I want only price. Okay, now a training and testing splitting is okay. So how this is done? So from sklearn dot model selection import train test split. Okay, so now I'm going to split it. So X train, and then X train, X test, Y train, Y test, and then train test split X, Y, test size, .2, okay, fine.
So now what next I can do, I need to import the linear regression model. So from sklearn dot linear model import linear regression. Linear regression. Okay, and now I'm going to fit my training data on this. So lin leg is going to be, so lin reg dot fit x train and y train. Okay, so I'm able to fit my data set on the linear regression model, and now I'm going to predict. I'm going to make a prediction. So I'm going to make a prediction on the test data. Okay, so len reg dot predict x test. Okay, and finally I'm going to check. Okay, so I'm able to make a model. So my model is built. Now it's time to make a evaluation. Okay, so it's time to evaluate the result. Okay, so what is a result of my model? So it's time to make a evaluation. So how am I able to make an evaluation? So evaluation can make with the help of a matrix. So from sklearn dot matrix import, I think mean squared error. Okay, yeah. So now just calculate a mean squared error. So I'm going to print our mean squared error. So mean squared error. This is I'm going to print, and how I'm able to find out? I'm able to find out with, okay, so it's a difference between actual data and a predicted data. So I'm having a y test with me, and I'm going to check with the predicted data. So my mean squared error is okay, so I'm able to get a mean squared. Oh, sorry, I didn't apply my mean squared error over here. Okay, so it should be a mean squared error. Fine. So I'm able to get a mean squared error as 177. Okay, so the mean squared error is very high. So I think we need to do kind of a scaling over here before applying that. Okay, so let's import mean max scalar. So from sklearn, so this is what we call a normalization. Okay, so this is what we call a normalization. Okay, so I'm going to show you. Okay, so mean max scalar means normalization. So normalization means what? I'm going to like scale my data in between in a range of between 0 to 1. Okay, so that is what we call a mean max scaling. So from sklearn dot preprocessing import mean max scaling, and in a similar way just make an object of this thing. Okay, so this is a mean max scalar, and just do the same thing. Okay, so you can make it in this way. The data is going to be scalar dot fit transform now. I think I'm so I'm getting a numpy array data in a form of numpy array. So I need to convert it into a data frame again. So data is equals to pd dot data frame. Now I think my data comes into the form of a data frame again. Okay, so I think what we can do is I have an X and Y. Now I can split the, like I can scale the data on this place. Okay, so after making this, I can do the feature scaling over here. Okay, so I can do the my scaling thing on this place. Okay, so how I can do that? So again, what I can do is, so I can like import from sklearn dot like pre-processing, and I'm going to convert scale my data in between 0 to 1. Okay, so import mean max scaling. Okay, so this is what I'm going to do, and mean max, so I can represent this with mn and mean max scalar, and then I'm going to fit transform my training data xtrain and mn dot fit fit transform, and what I'm going to transform my xtrain, and similarly I'm going to transform my xtest, but this should not be a fit transform, this is just a transform. Okay, so I think, yeah, this is fine. Yeah. Yeah, so mean squared error is this much. So this is fine. I think the value is very high. So that is why we are getting this much of mean squared error. What I can do is I can I can try to find out a root mean squared error. So SQRT, and this is going to give us a root mean squared error. Okay, and so this is my root mean squared error. Okay, so this is all about like kind of a thing which you can make with the help of a linear regression. And maybe this data set is maybe okay, so linear regression is always try to make an assumption that your data set should be linearly spreaded. Okay, so maybe we are getting this much of an error, so it may be a possibility that our data set is not linearly spreaded. So what we can do in that case, so I am going to discuss that thing in a later stage, that in that case, suppose if our data set is not linearly spreaded, so we can use a something called a polynomial regression, means a polynomial graph. Okay, means we can use a quadratic equation. But yeah, that is completely fine if you are not able to apply over here, because this is a simple idea of a linear regression, and this is how we can implement a model by using a linear regression algorithm. Okay, so that's all from a linear regression. Now we are now ready to jump into the classification part. Means we are able to jump into the classification algorithm, and yes, with again, so there are like a lot of classification algorithms available, like a logistic, KNN, and SVM. So I'm going to discuss those algorithms, and along with that, after discussing those algorithms, I'm going to show you that how you can implement a model by using those classification algorithm. So yeah, thanks a lot, and stay tuned till next session.
Hello, all. My name is Shivam. So today I am going to talk about classification. Okay, so I think last time we talk about a linear regression model. Okay, so we talk about a regression model. So how we are able to predict a number. So whenever we need to predict any number or maybe any continuous random variable, so at that time we are using a linear regression model or maybe any kind of a regression model to predict a number. Okay, so a number may be a height of any person or maybe a weight of any person, or it may be a score of the match, it may be a stock price. Okay, so anything. A house price. Now in today's session, so I'm going to talk about a logistic regression. So you are able to see the word regression over here. Okay, but
Now this time, with the help of logistic, we are not going to perform the regression task, we are going to perform a classification task. So classification means when you have just a when you have like maybe a number of classes. Okay, so it may be a 2 classes, it may be a 3, it may be a 4, it may be a 5. Okay, so it can be a number of class, it can be a just 2 class. Okay, so maybe a binary class, maybe a multi-class. But now so there now we are going to predict any discrete random variable. Here our objective is to predict a discrete random variable, not a continuous random variable. Okay, so this is what a meaning of a logistic regression. Okay, so the word regression present over here, but because it carries the same idea. Okay, so it carries the same idea of linear regression. So the same thing, like in case of a linear regression, we are trying to optimize the equation of line. Okay, so we are trying to find out the best fit line, and we are working over like on the equation of line. So the same thing we are going to do over here. So we are going to work on equation of line itself. But now but in case of equation of line, so okay, so suppose if I give you like a scenario. Okay, so it's better to understand with the scenario, because without a scenario or without an example, anyone can't able to understand this. Okay, so maybe on x-axis you have a age. Okay, so maybe on the x-axis you have a age of a person, and on the y-axis you so this age is x. Okay, means your feature, and on the y-axis you have a purchase column. Okay, which indicates y. Okay, now so just take one scenario, one problem statement. So maybe there are like number of items present in a shop. Now the shopkeeper trying to make a prediction from his past experience, from a history, that so suppose like this is maybe item I1. So and this is age of a person E1. Okay, so now whether this person is going to purchase this item or not. Okay, so when we have this kind of like scenario, or when we have this kind of an objective, so it means that we are trying to find out a probability, that what is the probability that a person of given age. Okay, so age can be start from 18, and maybe it goes till 52. In between there are like a number of ages, maybe a 30, then maybe a 38, then maybe a 42, then maybe a 48. Okay, so now our idea is what our objective is to predict whether this person, okay, whose age is 30. Okay, so what is the probability that the person of age 50 is of 30 is going to purchase a particular item. Okay, so so I think every one of that the value of a probability lies in between 0 to 1. Okay, so although I'm going to form an equation of line, I'm going to draw a line over here. Okay, so I'm going to draw a line over here. But in case of a line, what happens? So like the minimum value of y may be a 0. Okay, so y may be a 0 in this place, and maximum value may be a 1 in this place. Okay, so suppose maybe the item the kind of item which is present inside a shop is like maybe it is such kind of an item that old age people is actually. Okay, so a old age person is going to buy that object. Okay, so old age person, like it's like most likely old age person is more attracted towards those items. Okay, so what happens in this case? So I can say that, okay, so if the age is 52 or if the age is 50. Okay, so now I'm going to make a prediction that what may be the possible result if the age is 52. So the person is going to buy an item. Okay, so here our value goes beyond
1. Okay, so here our values go beyond 1, and even in a case of a negative side, even in case of opposite direction, means young age people is not going to buy that item, so here the values goes behind 0 also. Okay, but we don't want this kind of a scenario, because the value should be in between 0 to 1. Okay, it can't go beyond 1, and it can't go past 0. Okay, so now we need to apply something, we need to apply some kind of algorithm, or we need to apply some kind of function, mathematical equation, so that the we are so that we are able to concise this value in between 0 to 1. Okay, and this is what our objective is, because what you are trying to say in this place. Okay, so suppose at the age of 52 the person is going to buy an item. Okay, so I am 100% sure. So in a mathematics you can be 100% sure, but you can't say that I am 200% sure, I am 300% sure. Okay, and in similar you can't say that I am minus 100% sure, I am minus 200% sure. Okay, so you can't say this kind of a word in a terms of a mathematics. Okay, so value should be in between 0 to 1. It can't proceed over 1, and it can't go below 0. So we need to apply some function. Okay, so what kind of a function we are going to apply? So there is a function. Okay, so through which we are able to make this kind of a curve. Okay, so we are able to make this kind of a curve. Okay, this S-shaped curve. Okay, so this is called S-shaped curve. It's called S-shaped curve, and this S-shaped curve is called a sigmoid function. Okay, so now let me rub this so that it will look much beautiful. Okay, so this is a curve, this is a curve. Okay, so this is a S-shaped curve, and this S-shaped curve is called a sigmoid function. Okay, so now the idea is same, the because we are forming an equation of line, so we are going to okay, so the equation is same. So y hat is equals to theta naught plus theta 1 into x. Okay, so theta naught into theta naught plus theta 1 into x. So this is a equation, okay, through which we are going to predict a y. Okay, so y hat, but now we are going to make a slight change, because this values, this equation is not going to give a value in between 0 to 1. Okay, so we need to apply something so that we are able to get a value in between 0 to 1. Okay, so what is that value? Okay, so that is represented in this way: 1 plus e to the power minus theta naught plus theta 1 into x. Okay, so now this is our function, and this is what we call a sigmoid function. Okay, sigmoid function. Now no matter what kind of a value you are going to put in this equation, your output should always be in between 0 to 1. Okay, so this is what we call a sigmoid function. Fine. Now let's try to find out. Okay, so now this is a probability. Okay, so suppose if I'm trying to find out a probability that so what is the probability of this y is 1, given that, so what is the probability that's what is the probability that y is equals to 1? Okay, so the person is going to purchase an item at maybe this age. Okay, so now you are okay, so the age is given, so means your x is given. You need to find out your weights and biases, and then you need to calculate this value. So suppose this value turns out to be a 0.7. Okay, so this value maybe turns out to be 0.7. So what is the probability for class to be a 0? Okay, at the same age, so I think you know the answer. So this is going to be 1 minus 0.7. Okay, so this is what happened in case of a logistic regression. Okay, so we are trying to find out a probability, we are trying to find out okay, so whether this person is going to buy an item or not, And what is the probability? Okay, so what is the probability if okay, so what is the probability that if the person is going to buy an item, so by okay, how much we are confidence, how okay, so how much percentage we are confidence. So this is what we are trying to find out with this equation, with this like logistic regression. Okay, now okay, so this is like one classification algorithm, a very easy and simplest classification algorithm. Now and along with one assumption. Okay, so along with one assumption, so I think you are able to see that in case of a binary classification, it's pretty easy to solve this equation. It's pretty easy to find a solution, and it's maybe you may get a very accurate and very good result over this place over here. Okay, but suppose if you have a multi classes, okay, so in that case, yeah, again you are able to find out the solution, no issue. It can be a theta 2, theta 3, theta 4, theta 5. It is completely possible, but the same thing. Okay, so but you are not able to find maybe very good accuracy or very good performance. Okay, so in case of a binary classification, this model is very good. Okay, so it will give you a better result every time, but in case of a multi-class classification, maybe it will fail. Okay, or it will not generate the same result, same kind of a result as it is generating in case of a binary class. So this is the first thing. Now the second point related to this logistic regression is, so a kind of assumption it makes. Okay, so a logistic regression always so it works on assumption that your data should be linearly separable. Okay, so your data should be linearly separable. Okay, so this is a kind of an assumption which your logistic regression model build. Okay, so if the data is linearly separable, so it will give you so it will always give you a very maybe a good prediction or better result. But if the data is not linearly separable, so maybe it will not give you a very good accuracy or very good performance. Okay, so what do I mean by a linearly and non-linearly separable data? So maybe if your data, so suppose this is like crosses. Okay, so like there are maybe a two classes. Okay, so suppose if your two classes present in this form. Okay, so maybe okay, so I can add some outliers also. So maybe your like data present, so there are like these are the some black classes, and these are some like red classes. So this kind of a data, is called a linearly separable data, although there are like some noises. Okay, but now you are able to make you are able to make a curve. Okay, so now making a curve on this kind of a data is pretty easy. Okay, you are able to make a curve. Okay, with there. Okay, so definitely there is some error. There are some errors, but you are able to make a curve. Okay, so this kind of a data, this kind of a separation is called a linearly separable data. This kind of this is called a linearly separable data. Now, what do I mean by a non-linear separable data? So in case of a non-linear separable data, this is what like happens. Okay, so suppose again this is a black class, this is a black points. So these are the black points. And then these are the red points. Okay, so now no matter how expert you are, how much expert you are, but you are not able to make this kind of a curve. Okay, so you are not able to make this kind of a curve because this is this is what we call a non-linear separable data. Okay, so logistic regression model is not not works well in this kind of a scenario. Okay, so if your data separated in this way, if your data is spreaded in this way, so your logistic regression model fails.
Okay, because and you are able to see that why it fails, because it always try to form a sigmoid curve, it always try to make a sigmoid curve, and it not and this sigmoid curve is not able to make a boundary in between two classes. Okay, but yeah, in this case, case of a linearly separable data, so your sigmoid curve is able to make like a boundary. So this is a kind of an assumption in case of a logistic regression which we make. Now let's move on to, okay, so now let's take a look of another algorithm. Okay, so now let's take a look of another classification algorithm which can like work in case of a linear non-linearly separable data. Okay, and that algorithm is called a k nearest neighbor. Okay, and k nearest neighbor, again a very simple, easy, and it's like I think okay, so in many books you are able to see that this is a very first classification algorithm. Okay, so okay, so no one is very much sure, but yeah, this is a like a very old classification algorithm. No, so I actually don't know whether it is the first one or the second one, but yeah, it is a very old classification algorithm. And the idea is very simple. So idea is pretty easy to understand, and it can work in even in case of a non-linearly separable data. Okay, now just take a look, and like it just follow you only need to follow like a 3 or 4 steps to complete this knn classification. Okay, so now suppose there is okay, so based on maybe your flower flower like features. Okay, so maybe based on setosa, sorry, based on a petal length and petal width. Okay, so maybe in x-axis we have a petal length, and on the y-axis we have a petal width. And now our objective is to okay, and I am going to take just 2 classes because I am not able to plot 3 classes on this place. Okay, so maybe this red classes is a setosa for me. Okay, so this red classes is setosa for me. Okay, and then this green classes. Okay, so now let's take another color, and this green classes are like a virginica, or maybe okay, a versicolor for me. Okay, so there are like 2 classes, one is setosa, another one is versicolor. Okay, now okay, so okay, fine. Now just take one. Okay, and this is maybe a new class, x query. Okay, so xq means x query point, means a new point, a new flower come into the existence. And now my objective is to predict whether this new x query point, this new flower, is belongs to a setosa class or whether it belongs to a versicolor class. Now if I ask you, okay, so if I ask you to just by seeing, okay, so just by visualization, what is your opinion, what is your thought that whether this x query point belongs to a setosa class or whether this x query point belongs to a versicolor class? Okay, so okay, so now you need to I want you to share your thought. Okay, so I want you to share your thought whether this belongs to a setosa class or whether this belongs to a versicolor class. Okay, so I think every one of you are able to realize that this new x query point, this new xq point is belonging to a setosa class. Okay, because and I think you give a reason, you can give a reason that the distance between this x query point and this setosa point this data point and this vector is minimum or lesser in comparison to these two. Okay, and yes, the distance between these two is is lesser in comparison to this. Okay, so this is what happened in so and this is the idea of knn. Okay, so what knn does is, so knn tries to find out a distance with each data point. Okay, so it tries to find out a distance with each data point, and then it tries to okay, so and then it try to classify this new query point to like a class where the distance is minimum. Okay, But for this, okay, and but we okay, but we start with the steps. We start with the initial steps. So at initially, we need to choose like some values of k. So k is what? K is the number of nearest neighbors. So maybe you can take a k as 3, 5, 7, any number. So k maybe, so suppose k is 3. Okay, so this is a very first step in case of a KNN. In case of an KNN, so you can choose a K manually, or even you can choose a K by using a cross validation method. Okay, so in this session, I'm not going to focus on cross validation, but yeah, there are like a cross validation and hyperparameter optimization. But actually, so in case of KNN, you actually didn't. Like in a real case scenario, you didn't use this thing because you're able to find out a value of k very easily, because there are like some pros and cons of like taking k as this and taking k as that. So by using that concept, you are able to take k manual k. You are able to take a manual k, and that manual k can be a very optimal one. Okay, so now just take a look of the first point. Okay, so what this first okay, so what happens in this first step? Okay, so these are the like steps of your KNN. So in first step, you need to choose k. Okay, so choose the value of k. Maybe choose the value of k. So suppose I took so maybe I can choose a k as 3. Okay, so k equals to 3 means so there are 3 nearest neighbor. Okay, so what you are trying to do, you are trying to find out a distance with each and every data point. So we are trying to find out the distance of this new x query point with each and every data point, and just select the 3k. Okay, so means the 3 points through which the distance is minimum. So I think these are the 3 points. These are those 3 points. And what kind of a distance we are going to apply, what kind of a distance metric you can apply. So there are different distance metrics available which you can apply. But like other people are using a very famous distance metric, and like easiest one, that is called a Euclidean distance. Euclidean distance. So just after applying a Euclidean distance, try to find out a Euclidean distance of this x query point to every data point, every data point, and then select the nearest k points, right? And then at last is what? So at last we are going to, okay, so select the nearest k points. Okay, so nearest 3 points, and then okay, and then so now this is a classification task. So try to find out the majority votes. Okay, so find out the majority votes. Okay, so try to find out the majority vote. Okay, so I think if we try to find out the majority vote over here, so the majority of red classes is greater in comparison to a green class. So we can say that this new x query point is belonging to this class, which is a red class, which is a Setosa one. Okay, so this is the very simple, like easiest 4 steps of KNN. Now, one important thing that what may be the possible values of k. So always remember that k should not be equals to 1. Okay, because if the k is 1, okay, so if the k is 1, so it just always try to take one point. Okay, so it may possible that this one point may be an outlier. Okay, and maybe this maybe I can change this scenario, I can change this picture, and you are able to see that maybe this point is an outlier. Okay, and or maybe there is okay, or maybe suppose that this is a green point. Okay, so this is an outlier, and okay, and maybe this x query point falls in this place. So it is not going to give you the correct prediction, it is not going to give you the correct class. Okay, so because of an outlier or because of some reason, it just take it just try to find out the distance with each, and just and you say that this x query point belongs to this. Okay, so we are not going to do that. Okay, so this is not a good thing. So always remember that you can't take k as 1. Then second, k cannot be a even number. Okay, so k cannot be a even number. Okay, so I think you are able to understand the reason. So suppose k is 2, and maybe there is 1 point from a red class and 1 point from a green class. So your model being confused. Okay, so now how I'm able to take a majority odd. So in which class I'm going to I need to classify. Okay, so k cannot be a even number. Now the third one is k is not should not be equals to n. So n should not be equals to n means maybe you can take a scenario. So n is a number of dimensions. Okay, n is a number of data points. Okay, so k should not be equals to n. Okay, so this value should not be equals to total number of data points. Okay, so always remember that k should not be like these three values other, and then you can take any other value. So you can take k as 3, 5, 7, 11, 9, anything. Okay, and now how look like, and you can like use a simple for loop. Okay, so you did not to use a cross validation. Even cross validation is also having a same idea. So what you can do is you can take a simple like a for loop, and then try to find out for which k your accuracy is better, and you can simply apply you can simply use that k as your optimal k. Okay, so now this is like a simple idea or simple understanding of k nearest neighbor, and I think you are able to understand the logistic regression also. So now let's take like a quick look. Let's try to build a one classification model, end-to-end classification model, based on the idea which we like understand so far. And then just take a look. Okay, so whether you are able to understand the scenario that in which case or in where we are going to use this kind of a concept, and how to implement a model by using this this classification concept. Okay, so now let's take a look. Okay, so I need to share like screen. So this is my problem statement. So I already uh, read a data set. Okay, so data set is in the CSV format, art.csv. Okay, and I'm going to check whether the person is having any heart disease or not. Okay, so whether the person is having a heart disease or not. So this is what we are going to check with this model. Okay, so I think you are able to see in this data set we have one column as a target. Okay, so now this target is my target variable. This target is my like output variable. Okay, and in total I have 14 columns. Okay, so I have 14 columns. It means that I have 13 features and one output column. Okay, this target. And now inside this target you are able to see 11111. So if I try to find out that how many targets are one and how many target are maybe some other value. Okay, so a 0. Okay, so 165 value belongs to one class and 138 value belongs to other class. Okay, so okay, fine. Here we are able to see all ones, but definitely there are 138 more data which belongs to a zeroth class. Okay, or maybe you can say which belongs to another class. Okay, so now our idea is what? Our idea is to make a model. Our idea is to make a classification model, and my classification model is going to find out whether the person is having any heart disease or not. Okay, so this is what we need to classify. This is what my model is going to this is what my model going to do for me. Okay, so fine. I think
I'm able to see and one very important and very a very good thing for us is we don't have like any categorical column. Okay, so we don't have to worry about that my data set is containing a categorical column and I need to convert it into a numerical one. So this is a very good thing. And now I can check another thing in my data set with the function called info. Okay, so with the help of function called info, I'm able to see that I'm having 303 non-null value in all my columns. Okay, it means I don't have any null values. So this is another advantage of this data set, that I don't have any null values, and I don't have any along with that I don't have any like categorical data. Okay, now fine. So if I don't have any categorical data, if I don't have any numerical, if I don't have any null values, so yes, I'm able to, so it's, I'm good to go and I can make my like a prediction. Okay, so how I'm able to make a prediction? So first we need to build a model. So before building a model, we need to split the data set into X and Y, means features. We need to separate features and target, and after that we need to split the data set into a training and testing set. Okay, so first try to, okay, so just try to import the uh, libraries first. So from sklearn dot model selection. Okay, so from sklearn dot model selection, import train test split. Okay, so from sklearn dot model selection, import train test split. In a similar way, from sklearn dot linear model. Okay, so our logistic regression is also a kind of a linear model. I need to import logistic regression. Okay, so logistic okay, and one more thing we need to import. So from sklearn dot metrics, we need to import accuracy score. Okay, so these three libraries we need to import. Now our next job is to make a separation between X and Y. So inside an X, I'm going to preserve my complete features. So I'm going to drop just one column, which is a target. So target, and this target is on like a column. So axis should be 1, and in a Y I'm going to take just a target. Okay, so this is my X and Y. Now I'm going to split the data set into training and testing part. So for that, I need to write a code in this way. So X train, then X test, then Y train, and Y test. So train, test, split. Okay, so train, test, split, and how I'm able to split it? So X, and then test size is going to be test size should be 0.2, and then like a random state, maybe you can take any random state, that is completely fine. So okay, so I'm able to split my data set into training and testing set. Okay, now we need to build a model. So we need to train our model. So for that okay, so train a model. So I'm going to apply a logistic regression over here. So for that, I'm going to use kind of a object. So because logistic regression is a class for me, and I'm going to fit my training data on this object. So log reg dot fit, and I'm going to fit X train and Y train. Okay, So yeah, I'm able to fit my data set. So after fitting, I need to find out like score. So for score, you can write down I'm going to evaluate my model. So a model evaluation. So model evaluation I'm going to do. So and how I'm going to evaluate a model. So for that, first I need to find out the prediction. Okay, so predicted value. So y pred is going to be uh, log reg. I think these are the same steps which you follow in a last session also in case of a linear regression. So log reg, and I'm going to use my test data. Okay, and now I can find out an accuracy. Okay, so how I'm able to find out an accuracy? So for that, just use accuracy score. Okay, so accuracy score, and this should be a comparison between a y test and y pred. So this is going to show you an accuracy. So accuracy is 88.52%. So it's a very good accuracy. So yeah, I'm able to get a very good and a very a very good performing model with the help of a logistic regression. Okay, so yeah, if my data is linearly separable, if there is no chaos, so yes, with the help of logistic regression. And the very important thing that if you have a just if you need to do only a binary class classification, so definitely at that in that scenario you are able to get a very good accuracy, a very good performance with the help of a logistic regression. Now make a prediction. Okay, so now it's time to make a prediction. So this is what we call a end-to-end model. So we are going to make a prediction. So and this is what we are trying to do. So I tell you that, okay, so after 303 data, okay, so if we make a model on 303 data, so suppose a new person come into the existence, any new like patient come into the existence. So I just take input data from him. Okay, so I'm going to take like his age, I'm going to take his like sex, then CP, then trust, TBS, then cholesterol, then FBS, everything, and I need to predict whether he's having any heart disease or not. Okay, so now I'm going to make such kind of prediction. So I'm going to take a random data. I'm going to take I'm going to I'm going to make a input data, and I'm going to fill this 13 information of a patient, and then I ask my model to predict whether this person is having heart disease or not. Okay, so maybe so I'm just going to take my input data. So my input data in this way. So the first value is age. So maybe the age of a person is 60. Okay, then the second, so a sex, so it may be a male or female. So one may represent a male, second 0 represent a female. So 1, and then CP, so CP is maybe some value, so 1 and then 2. Okay, then like cholesterol, so maybe I can make it as 140, and then I'm going to take it as like or you can take a data from X test also. Okay, so if you are finding a difficulty, so you can take, because X test is also a unseen data. Okay, and you are able to see whether your model performance is good or bad. So what you can do, you can just try to make one simple, and you can take X test. So 0 is not there. So what you can do is, so you can take a data from X test also. So yeah, in this way. So suppose the age is 57, and then sex is 1, CP is maybe a 0, then it may be a 150, then 276, then 0, then again 0, then 112, then 1, then 0.6. Okay, so
then 1, then 1, then 1. Okay, and now you can check that X test. I think you have an index value. Okay, so you can check at, so after making a prediction, you can check whether your prediction is correct or not. Okay, so Y test, so you can write down the index value and you can check whether you are getting 1 or 0. Okay, now convert this data into a NumPy array. Okay, so I'm going to convert this data into a num array. So np dot s array is a function through which you can convert anything into a NumPy array. Okay, so num array np dot s array input data. Okay, so NumPy array, I'm able to convert like my input data into a NumPy array. And then this is a single set of data, so you need to maybe reshape. Okay, because it may create a problem if you not reshape your data set. So input data is equals to, so input data, you need to reshape your data. So what you can do is, so input data like reshaped data. Okay, you need to change the name so that it can't create a confusion. So np and array dot reshape. So this is going to be 1, 1. And now it's time to make a prediction model. And now it's time to make a prediction. So what I need to do is, so I need to put my prediction over here. So log reg dot predict. And I'm going to make a prediction over this input data reshaped. So this is my prediction, and I can show my prediction whether the prediction is a 0 or 1. So I can show this thing. I can check now whether the person is having a heart disease or not. So if prediction is, so now I can give a condition that if prediction is 0, okay, so what does it mean? So if the prediction is 0, it means that the person is having a no heart disease. So I'm going to print that the person does not have a heart disease. Else print person has heart disease. Okay, now I'm going to check. So X has 1 feature per sample expecting okay, so maybe there is some issue. Okay, so at a time of reshaping, what I need to do is, so it is reshaped in -1 to 1. Okay, maybe I can make it as 1 minus 1. Maybe this is not a scene, because this is going to be stream, whether it's 1 minus 1 or 1. Okay, fine. Now our prediction is going to be model dot like predict, and then I'm able to make this prediction on what you call input data reshaped. So yeah, this is, I think, completely fine. I'm making, yeah, this is, I think, completely fine. What might be an issue? Yeah, correct. Okay, so the person does not have a disease. Yeah, so I am able to get a 0 over here, and that is why the person is not having a disease. Now, you can, like, I can try to make a cross check whether I am getting, like, and just see that whether I'm able to make a cross check or not. Yeah, correct. Okay, so at 179, if I am passing this data as an input, so I'm getting 0 as an output, and here also I'm getting 0 as an output. Okay, so it means my model is correct. Okay, because yeah, and I'm and and we actually clear, we are able to get 88.5% accuracy, so which is good enough. Okay, so this is it for from this logistic regression and KNN, means a classification view. Now in the next session again, we are going to talk about a classification model, but we are going to talk about a different classification model along with a different problem statement. Okay, so that's it. Okay, stay tuned till our next session. Bye. Hello, so my name is Shivam, and now I'm going to talk about decision tree. Okay, so decision tree is again a classification algorithm, but it is, you can call it as a more powerful classification algorithm as comparison to a logistic regression and a k nearest neighbor. Okay, so yeah, definitely, if we take a specific problem statement, if we take like if you talk about a specific task. So in case of in case where you have a large number of data set, where you have a use amount of data. So in that scenario, the decision tree model and the random forest model is much more applicable and much more appreciable in comparison to logistic regression and k nearest neighbor. Okay, so now let's talk about a decision tree. So decision one very key point and one very like strong statement based on a decision tree is it is a highly interpretable model. Okay, so this model is called as a highly interpretable model. So highly interpretable model. Okay, so this model is called a highly interpretable model, and the reason being why it is called a highly interpretable model is it's very easy to interpret. Okay, so it's very easy to understand, it's very easy to interpret, and you are able to see that what are the things going on. Okay, so in case of logistic regression, in case of a linear regression, in case of another algorithm, maybe you are not able to generalize that what may be the possible mathematics, or what may be the possible scenario which is going on in the back end. Okay, but in case of a decision tree, you are able to interpret those things. Okay, okay, so yeah, and it is very easy to understand. Okay, so the mathematics and the concept is very easy to understand, because it just follow it is a kind of a if else classifier. Okay, so it is a kind of if else classifier, like maybe if I try to take a case of a Irish data set. Okay, so if I take a case of a Irish data set. So in case of a Irish data set, we have a three kind of flower. Okay, which we already discussed, that we have three kinds of a flower. So one is setosa. So maybe I can denote setosa with one. Then another one is versicolor, and the third one is virginica. Okay, so these are the three classes of flowers in case of Irish data set. Now if I try to write excise, means what are like attributes, what are the features. So my features are nothing but a sepal length, petal length, sepal width, and petal width. Okay, so these are the features, these are the columns of Irish data set. Okay, now I can okay, so now I can check. Okay, so with the help of if else model. So if I consider it as if else model or if else classifier, so yes, I can check that if a petal length
Okay, so I can call, okay, so if a petal length is lesser than a, so a may be any centimeter, any size. Okay, so it may be the size of a petal length. Okay, so if petal length is lesser than a, then yi is equals to 1. Fine. Another, else if sepal length is lesser than b, then yi is equals to 2. Else yi is equals to 3. Okay, so if petal length is lesser than a, then yi is equals to 1, means your class will be a setosa. If sepal length is lesser than b, means maybe any another centimeter, so yi is equals to 2, and else yi is equals to 3. Okay, so these are the maybe three classes of decision tree. Okay, so petal length. So I think if you try to draw this, okay, so this is okay, and this is the simple concept. This is a simple idea behind a decision tree. Okay, now if you want to draw this, okay, so yeah, it is very easy to draw this whole structure. Okay, so this is maybe your root node. Okay, where you are trying to check whether the petal length is lesser than this value. Okay, now you are going to check, okay, so if this statement is true, if this statement is true, so you are going to check whether this statement is true or false. So if this statement is correct, okay, so if it is correct, so you can call it as y equals to 1. Okay, yi is equals to 1. So, and this is your final decision. Now if this statement is false, then you are trying to give another condition, maybe a petal width. Okay, so maybe a petal width lesser than b, and then you are, yeah, you can make your model. Okay, so if it is true, then it is going to be a versicolor. Okay, it is going to be a versicolor, and if it is false, so it is going to be a virginica. Okay, so this node is called a root node. Okay, so this node is called a root node. Then this node is called an internal node. Okay, so this node is called an internal node, or maybe you can also call it as a child node. Okay, and then this node and this node is called as a leaf node. Okay, so leaf node means where you are able to make a decision. Okay, so the node where you are where you are able to make a decision, so that particular node is called a leaf node. Okay, so we have a root node, we have an internal node, and we have a child node. Okay, and this is a highly interpretable model. Okay, so yeah, and you are able to able to see that why it is called highly interpretable model, because it's easy to understand, it's easy to make any kind of an intuition, and it is easy to make build this kind of a model. Okay, now if I try to take a geometric intuition, okay, and then from geometric intuition we can make a different a definition. So if I try to make a, if I try to consider a geometric intuition, okay, so what may be the geometric intuition behind this model? So yeah, maybe I can write in this way. So this may be the petal length on the x-axis, this may be the sepal length on the y-axis. Now what we can do is, so this may be our pi, so pi 1. So this may be our plane 1, and this may be a, and this may be a b. Okay. Now what we can do is, so yeah, we can do that. Yeah, so if petal length is lesser than a, okay, so this is what we make there. Okay, so if petal length is lesser than a, then our class should be a setosa. Our class should be a setosa. Okay, and now if your petal length now you are able to check whether, so if your sepal length or petal width, so if it is okay, so if it is lesser than b, so it will be a versicolor, otherwise it will be a virginica. So this is also a kind of so this is what we call a geometric intuition. Okay, so from here also you are able to make your decision. Okay, so So your hyperplanes, okay, so this is your hyperplane, okay, so this is your hyperplane, so this pi1, and maybe you can call it as pi2. So this is your hyperplanes, okay, so all your hyperplanes are called are axis parallel, okay, so axis parallel, why it is called axis parallels? Okay, so now if you check this hyperplane, if you check a pi1, so pi1 is parallel to y-axis, okay, so pi1 is parallel to y-axis, and if you check pi2, so this pi2 is parallel to x-axis, okay, so all your hyperplanes are axis parallel, okay. So this is, and this is this is a definition of decision tree, okay. So decision tree is nothing but a set of axis parallel hyperplanes, okay. So decision tree is nothing but a set of axis parallel hyperplane, okay. So these are nothing but a axis parallel hyperplanes, set of axis parallel hyperplanes. So decision tree is nothing but a set of axis parallel hyperplanes. And you can also, like, you can extend this definition, and you can write in this way that divide your whole region, that divide your whole region, region into hypercubes or cuboid, okay, so hypercubes or cuboid, okay. So, and so this is what we call a decision tree. So decision tree, yeah, I think we get an idea that this is a very easy to understand, okay. Now there are like certain scenario, okay, so we are not going to discuss the detailed mathematics of this whole concept, but yeah, like I can give you the terminologies, okay. So on what basis you are able to select the root node, okay, so the terminology is very easy. So to select the root node, to select a root node, to select the root node, what you need to do is, so you need to find out, we need to find out something which is called information gain, okay. So information gain, so you need to find out the information gain, and to find out the information gain you need to calculate the, okay, so and to find information gain you need to you need to find you need to calculate the entropy, okay. So these are like two terms which you need to understand: entropy and the information gain, okay. So entropy, so with the help of entropy and information gain you are able to design a complete mathematics of this decision tree, okay. And now so I just write a simple formula for the entropy, so that it becomes easier for you to understand. So suppose you have two classes, maybe a positive class and a negative class, okay. So maybe y plus and y minus, so maybe these are the two classes which you are having. So the formula for the entropy is nothing but negative of summation I equals to 1 to k, then a probability of yi, okay, then log of probability of yi, okay. So this is the formula for the entropy, okay. So this is nothing but okay, so on the very first place you need to write down the probability for the information, probability for first class, and the probability for the second class, okay. So maybe you can take an example like so maybe a total number of cases, on total number of samples you are having maybe a 14, okay. And out of this 14, so just suppose that 9 value belongs to a positive class, and then 5 value belongs to a negative class, okay. Just consider this scenario. And now if I ask you to calculate the entropy, so yeah, it's pretty easy to do this calculation. What you need to do is, so minus 9 upon 14, and this 9 upon 14 is nothing but a probability of a positive class into a log of 9 upon 14, a minus 5 upon 14 log of, okay, and this is a probability of negative class, so 5 upon 14, okay. And now if you calculate this, so I think you are able to get like entropy something 0.9, maybe a 2 or 4. Okay, so this is going to be your entropy. And now on the basis of this entropy, you are going to calculate the information gain. And then on the basis of information gain, you are able to select your root node. Okay, so root node means what? Root node which is your prime feature. Okay, which is your most important feature. So information gain able to helps you to select the most important feature from your data set. Okay, so out of this 4 feature, like a petal length, petal width, sepal length, and sepal width, out of this 4 feature, which feature is the most important one? Okay, and then the which feature is the second most important one, then third, then fourth. Okay, so this is what we call a, so this idea is called like entropy. This idea of selecting a root node is called an information gain. Okay, so I hope and I think that you are able to understand this concept. Now, if I talk about a random forest, okay, so if I talk about a random forest, so yeah, random forest is okay. So like the name given, so random forest is nothing but a collection of a decision tree. Okay, so a collection of a decision tree is called a random forest. But now the concept is little bit different. Okay, so random forest comes into different kind of a technique, or you can say a different kind of a different kind of an idea that is called an ensemble learning. Okay, so the random forest is a part of an ensemble learning. And even in case of ensemble learning, so ensemble learning, so ensemble learning means what? Ensemble learning means so till now we are trying to trying to make a prediction, or trying to classify maybe a class um, with the help of single algorithm. Okay, so maybe with the help of a decision tree, or with the help of KNN or logistic regression. But when we try to when we try to develop an idea where we are able to make a ensemble of all these 3 methods, or maybe a 2 methods, or maybe another like 4 5 methods. Okay, so whenever so if when we are trying to the idea of combining all the methods, or maybe multiple algorithms together to make a prediction, so that is what we call a ensemble learning. Okay, so ensemble learning means ensembling a different classifier, or ensembling a different predictors, and then we are assuming that these predictors, okay, means your ensemble learning model gives you a much better accuracy, or much better performance in comparison to a plain model. Okay, so in comparison to a plain model, this ensemble learning models going to give you a much better production, or much better accuracy, much better performance. Okay, so now in case of ensemble learning also, we have some techniques. Okay, so we have some like techniques that is called a bagging. Okay, so there is one technique which is called a bagging, and bagging stands for bootstrap aggregation. Bootstrap aggregation. Okay, so now okay, so let's try to understand that what is the meaning of a bootstrap aggregation. Okay, so bootstrap aggregation is what you need to do is, so in case of a bootstrap aggregation, there is a like, okay, so we have a data set. Okay, so we have a data set DN. Okay, so we have an XI, we have an YI. Okay, so we have a data set XI and YI. Okay, so XI means on features, and YI means my target variable. So you have an input variable, along with a input variable, you have an output variable also. And maybe you are having a 10,000 points. Okay, so just consider that you are having a 10,000 points. So what we need to do is we need to apply a method. Okay, so we need to apply a method which is called a sample with replacement. Okay, so this is called a sample with replacement, SWR. Okay, so sample with replacement means what? We are trying to select like we are trying to collect some points. Okay, we are trying to select some like data points from this 10,000 points. Okay, and we are trying to select these points randomly. Okay, and then we okay, so and when next time we are trying to collect the points, so it's not like that we leave the next the past points, okay, or the past data. Okay, so maybe out of this 10,000 points, maybe we are able to collect at 8,000 points, okay, or maybe 7,000 points, and make our different data set, which is called a DN1. Okay, then again with a sample with replacement, again with the sample of replacement. So if we do a sample with replacement again, so we are again having a 10,000 data points. Okay, so we are again having a 10,000 data points, and now we have a suppose this time we collect just maybe 4,000 points, or maybe anything. Okay, so it is a random number, or it may be anything, just to make a like balanced data set. We are trying to maybe collect a similar number of points. Okay, so maybe here we are able to collect a 5,000 and maybe 4,000, and then maybe in this way we are trying to collect like k number of we are able to create a k number of data sets with a similar method, and yeah, we are able to collect the information. So now this idea of collecting information is called a sample with replacement, and now this step is called bootstrap sampling. Okay, so up to this statement, this idea is called a bootstrap sampling. Now what happened next? So on this data set, okay, so on this data set, we are trying to make our model. Okay, so this is my first model, M1. So M1 build on this data set. Okay, then we are trying to make our second model based on this data set, maybe M2, and then maybe on this we are able to make a k number of k number of models. So k number of data sets, and we are having a k number of models. Now to get like a result, what we need to do is we are trying to aggregate all these three models. Okay, so we are trying to aggregate all these three models and make one. Okay, now maybe this is a classification task. Okay, so just assume that maybe this is a classification task, and we are getting one from here. Okay, and maybe we are having two classes, 1 and 0. So maybe we are getting 1 as a result from this model. Now we are getting 1 as a 0 from this model, and maybe we are getting 1 from this model. So what we can do is, so now we can perform a voting classifier. We can perform a voting classifier. So now the maximum number of vote go in a case of one class. Okay, so maximum number of votes go in the favor of one class. So my model, my final model, so this is a aggregation. So on this stage we are performing an aggregation. So my final model going to predict this input as 1. Okay, so my model is going to predict, so whatever the new X query point comes into the existence, so we are able to predict, we are able to classify that new X query point to class 1. Okay, so now this at this point it becomes a bootstrap aggregation. Okay, so in like in a middle, okay, so in a middle, this is called bootstrap sampling, and at last it become bootstrap aggregation. Okay, now let us take okay, let us take okay, so now just try to understand this concept in a much better way. So what happened in this concept, that we are trying to make, so these models, okay, so this M1, M2, M3 means your on base models. Okay, so this M1, M2, M3. Okay, so now let me turn my page. Okay, so this M1, M2, M3 dot to MK. So these models are considered to be a base models. Okay, so these models are considered to be a base models, and we are combining all these models. Okay, so we are combining all these models, or we can say we are ensembling all this model to produce a single model, which is called a aggregated model. Okay, now this M1, M2, and M3, what we are trying to do in case of M1, M2, M2, M3, M3. So this M1, M2, M3 is considered to be a highly overfitted model. Okay, so this M1, M2, M3 dot 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 to MK means our base models are considered, in case of aggregation, in case of a bagging, it is considered to be a highly overfitted model. Okay, so overfitted model. This model are considered to be a highly overfitted model. So each models are highly overfitted, means overfitting is there. Okay, so so what is the scenario for overfitting? So in a scenario of overfitting, you have a low bias and high variance. Okay, so you have a low bias and high variance. Okay, so what this algorithm is trying to do is, we are trying to the simple idea of a bootstrap aggregation, or the simple idea of bagging is, we are trying to make so we have a bunch of a low bias and high variance model, we have a bunch of a overfitted model, and then we try to aggregate a model, and then and at a time of aggregation, we are trying to lower down the variance and make a low variance and low variable model, means a generalized model. Okay, and this is so there is something which is called a generalization error. Okay, so there is something which is called a generalization error. So generalization error is directly proportional to a bias square plus variance plus irreducible error. Okay, so this is what we call a generalization error. Okay, so our main goal is to minimize this generalization error. Okay, so our main goal or our main idea is to minimize this generalization error. So we so in case of a bagging, in case of a bootstrap aggregation, we take a bunch of like overfitted model, bunch of overfitted model where our variance is so high, but at a time of aggregation, we are trying to lower down its variance and make a generalized model. Okay, so this is what we call as a bagging. Now in case of a bagging, if our base, okay, so if we replace our base models, if we replace our base model, okay, so if we replace our base models with a deep decision trees, okay, so with a deep decision trees, so what why I said a deep decision trees, because deep decision trees means if in case of a decision tree, if our depth is very high, it means the model is overfitted. Okay, or the variance is high. Okay, so if we replace our base model with deep decision trees, so then it call then the aggregated then the model or the aggregated model which produce, then the aggregated model is called is known as a random forest. Okay, so maybe so your base model may be anything. So your base model may be a KNN with a k equals to 5, then KNN with k equals to 7, or maybe a logistic regression, or maybe anything. So if we replace our base models with a deep decision trees, okay, so deep decision trees means maybe somewhere depth is 5, then 7, then 10, then maybe a 20, then 30, maybe 100, maybe 1,000. Okay, so if we combine these kind of a decision trees, and then finally if we try to aggregate our decision tree and produce a result or produce an aggregated model, so that aggregated model is called as a random forest. Okay, so I think the idea is very clear. The a mathematical part or the mathematical intuition is very clear to all of you, that what is a meaning of a random forest and what is a meaning of what we call as a a decision tree. Okay, so I think both the idea or both the algorithm is clear to you mathematically. Okay, so what yeah, the base idea is clear to you, and now you can try to make your intuition little bit depth, or maybe you can try to understand more mathematics from maybe from some websites or link. So yeah, in this session, we are going to share the link also. So a link from a very famous website, so that you are able to understand mathematics of a decision tree, depth mathematics of decision tree. And along with we are also sharing a book with you, so that you can you can try to maximize your knowledge from that book. Okay, so let's try to do some coding stuff so that you are able to see that how these things can be implemented. Okay, so this is my data set. Okay, so I think I already read the data set. So this is my data set, and this is a very famous model which is called a churn prediction model. So the problem statement is there is a bank which is so there is a bank, and like lot of customers are trying to leave the bank. Okay, so bank is so as a data scientist, bank asks you to make a model so that we are able to see, okay, so what is the like criteria, what is the things which enhance the customer to leave the bank, so bank can make an improvement. And another thing that okay, so what are the what kind of a customers, or what what kind of a customers more likely to leave the bank. Okay, so these are the two things which bank wants to understand from your model itself. So let's start. So we already import I already import a data set. Okay, so data set contains 14 columns and and 10,000 rows. So 10,000 rows means at 10,000 examples we are having. So a very good number of examples. Now, if we try to find out whether the data set having any null values or not. Okay, so yeah, we can check this. So is null dot sum. So whether my data set containing any null values or not. So I'm not getting any null value. So this is a very good thing about a data set, that we don't have any null values. Now you are able to see that in case of a data set, we are having some like columns which are totally irrelevant. Okay, so like a row number, then a customer ID, then a surname. So these three columns are totally irrelevant. And these are not going to give you any kind of a significance to build your model. So yeah, we can drop these columns. Okay, so I'm going to drop these columns. Like the first column is row number, then the second column is customer ID, and the third column is surname. And then access is equals to 1. Okay, so fine. And yeah, then our df dot head again. So oh sorry, this is not a df, this is a data. Okay, so I'm making a mistake. Now if I'm going to check my data set, so I don't have those three columns which I've dropped. Okay, now in this data set we have two columns where we are having a categorical data. Okay, so in case of a geography and in case of a gender, we have a categorical data. And then we also have some okay, maybe those are not categorical data, but they are discrete random variables. Okay, so like a number of products has credit card, so whether the person is having a credit card or not, and whether the customer is active or not. Okay, so is active member. So these three are again a discrete data set, and along with a geography and a gender. Okay, so these are my and maybe a tenure. Okay, so because in case of a tenure, if we are trying to check, okay, so in case of a tenure, I think that we have a very limited number of unique values. Okay, yeah, so we have a limited number of unique values. So I think we can check that also. So maybe if I'm trying to write n unique functions, so with the help of n unique, I can check. Okay, so we have like 11 unique tenure. Okay, so it is also a kind of a discrete data. And maybe a credit score and a age, then balance, and then estimated salary. So these are like proper 4 numerical columns or proper 4 continuous data. Fine. Now okay, so let's start with our first step, which is called exploratory data analysis. So in case of exploratory data analysis, what the first thing which we need to do is we need to check our class distribution. Okay, so what is the distribution of our like classes? Okay, so this is the very first thing which we need to plot, or which we need to understand. So I think we already done this thing in a last session, but I'm going to draw this I'm going to draw this with like maybe uh, another way. Oh yeah, but a pie chart is best. Okay, so pie chart is the best thing to understand these things. Okay, so maybe I can say there are two labels which is existed, or as the second one maybe called a retained. Okay, so just opposite of existed is a retained. Okay, now I'm going to give a sizes. Okay, so data dot existed and then data existed is equals to 1. Fine. So this is going to be okay, so size means we are going to decide how many labels we are having. Okay, so 1, and then the count of 1, and the second is the count of the second thing. Okay, so the count of non-existed. Okay, so the count of you can say a retained one. Okay, so the count of retained one, data of access, so this should be a 0. Okay, so I think this is fine. Now the third thing is just to make it more attractive, I am going to use one thing which is called explode. Okay, so it is a 0 and then a 0.1 maybe. And then next thing which I can do is I can just simply use a pie chart and plot it. Okay, so ax1 dot a pie. Okay, so maybe I need to, oh, okay, let me check. Okay, so if there is an issue, so maybe I need to plot something, but I think now it is fine. So what attributes I need to pass? I need to pass the sizes, and then I need to pass the explode, which is explode itself, and then I need to pass my labels, which is a retained, and the second one is existed. Okay, so I think this is fine. And one more thing which I can pass is auto, I think auto PCT, which is going to be percent 1.1 F and again percent. Okay, and again percent. So I think this much of thing is fine enough. And then I can give a title. So plt dot title is going to be yeah, proportion of customer churn, proportion of customer churn as well as retained. Okay, so these are the things, and then I can use simple plt dot show and plot it. Let me check. Okay, so ax1 is not defined, so this is what I'm trying to understand. Okay, maybe I need to give something else. Okay, so I need to, yeah, I'm trying to define, I forgot to define like figure size. Okay, so fine, I can do that. So plt dot subplots, and then I can define a fig size. So fig size maybe equals to 10 comma 12. maybe 10, 10 is fine. Okay, so this is my this is a proportion. Okay, just try to short it a little bit. Okay, so in case of 10, 10, I can make it 8, 8, and maybe it looks more perfect. Okay, so 79.6% customers are retained. Okay, it means a very few people are going to leave the bank. So 20.4 percentage of people of 45.4 percentage of customers are going to leave the bank, whereas 79.6% customers are going to retain. Okay, so this is a good graph for any bank, but yeah, we need to preserve this 20.4% also. Okay, so and then so we need to understand that what are the criterias, or maybe what are the maybe the places and from which gender more people are leaving the leaving the bank. Okay, so these are all the things which maybe we need to understand. Okay, so for that I can give you maybe some ideas, and then you can try to plot some more graphs by yourself. Okay, so what I can do is I can try to give you a idea that how you can try to plot your own things. Okay, so I'm going to make a bivariate analysis. So a geography is one, and then I'm going to take u as existed. Okay, and data is equals to data itself. Now if I'm trying to plot this, let's try to plot this. Okay, so you're able to see that yeah, more number of people who are not churned, or more number of people who are churned are from Germany. Okay, so this is a, and France is a good France is having a showing a good scale, that most number of customer are not churned from a France, but there are like more customers who are churned from a Germany. So the same thing you can check for the male and female. The same thing you can check for the whether the person is having a credit card or not, or the same thing you can check for the active members. Okay, so these are the scenarios which you can observe, which you can check, and then you can make your hypothesis. Okay, so yeah, it is like completely fine to understand. Now if I try to give you a more analysis, so maybe I can take one like a box plot with a numerical data. Okay, so here I'm try to make analysis with the categorical data. Now I will give you one good analysis with the numerical data as well. Okay, so what you can do is, so you can do one thing, you can try to take age on the y, and then on the x you can take existed. Okay, where the u is also existed at all, and then data is equals to data itself. Now, so this is give you that okay, so 0 or 1 is showing you the existed. So and you are able to see that the older people, okay, so the where the age is greater than 50. Okay, so age is greater than 50, so the older people have okay, so are churning less, but okay, so the older people, okay, so here we are able to check. Okay, so the older people who are more than 60 have higher chance, or maybe more than 70 have higher chance to churn the okay, to churn the company. Okay, in comparison to the younger one. Okay, so this is what you guys can check, or you can make your own hypothesis. Now let's complete some feature engineering, and just okay, and just try to make a model. Okay, so that is the main thing which we need to understand. Okay, so if you can and but before applying this feature engineering, we are not able to do that job. Okay, so what kind of a feature engineering we need to apply? So we need to convert a geography and the gender column into what you call as uh, a numerical data. Okay, so you need to convert your categorical data into the numerical one. Okay, so from sklearn dot preprocessing import label encoder, then le is equals to a label encoder, and then what you can do is you can try to use a gender column is equals to le dot fit transform, and this is going to be a gender column. Okay, and the same thing you can perform for the geography. Okay, so the same thing you can perform for the geography. What you need to do is you just need to replace this gender with the name geography. Okay, so it's very simple to understand actually, and it's very simple to implement also. Now if you're trying to see your data dot head, so I think all of your data is converted into a numerical one. Okay, even you can do one more thing. You can try, you can also, if you want, you can make it, you can convert into you can use a dummy variable. Okay, you can create a dummy variable, that is also fine. And one more thing you can do, you can try to plot a heat map, or you're trying to plot you are trying to plot a correlation matrix to see the relationship between a numerical data. Okay, so what kind of relationship like they are making, like tenure, age and all. Okay, although these are the columns which are not very specific in nature, so maybe they are not having any kind of relationship, because a credit score is having totally having a different scenario, then age is totally a different scenario. So it's very it's kind of an impossible thing to have any kind of a connection between these two data. But yeah, you can try to check, you can try to understand, maybe if there maybe if there is any kind of a relation. Okay, now one more thing which you need to do. So you can see that a credit score, then age, then balance, then estimated salary. These are all the columns which are having which are totally on a different scale. Although your geography, gender, tenure is a kind of a discrete random variable, but these four columns are on the are totally on a different scale. Even they are not similar in their manner also, because a credit score is having 100, then age is on the 10 scale, then balance is on like a 10,000, even a lakh, and even a zero also, and then estimated salary you have a 10,000 and sorry, estimated salary is lakh and 10,000. Okay, so all of them are on the different scale. So what you can do is you can try to make one separate separate you can try to store all this numerical data. So what you can say, a continuous where into into a variable, and then you can try to find out. Okay, so you can try to scale them. So the first one may be the credit score, fine. Then the second one is age, then the third one is balance, then the fourth one is estimated salary, and I think this is all. Okay, so credit score, age, balance, estimated salary. Okay, so fine, this is like I think this is these are all our continuous variables. Now from sklearn dot pre-processing, we need to import a mean max scalar. Okay, so mean max scalar. Okay, then scalar is equals to again a mean max scalar. Okay, and then what you can do is you can try to fit all these continuous variables. Okay, so you can try to fit all this continuous variable. Okay, so data of continuous var is equals to a scalar dot fit transform, and then again data of continuous. Okay, so fine. Now I think we are able to design this in a way which we want. Yeah, now my data is on the same scale. Okay, now what are the next steps which we need to perform? I just simply need to prepare my data set. So I want all the features into X. Okay, so for that I only need to drop the existed column from this X. Okay, so fine, I'm able to drop it. And inside Y, I want to take just existed. So I have my X and Y separated. Now the next thing which I need to split the data into a training and test part. Okay, so from sklearn dot model selection, import I think train test split. Okay, so a train test split, and then I'm going to split it. Okay, so X train and then X test and then Y train. Okay, and then Y test. And let's call this function train test split. Okay, so just pass X and Y and then pass the test size, which is 0.25. Okay, so I'm going to split it into 75 and 25. Okay, so this is a totally your wish. Right now, it's time to build a model. So X train, X test. Oh, sorry. Okay, so just import the libraries to build a model. So from sklearn, I'm going to from sklearn dot tree. Okay, import decision tree. Okay, so decision tree classifier, and then from sklearn dot ensemble, I'm going to import random forest classifier. Okay, so these are the two classifiers which I'm going to use. So and one more thing. So for evaluation, I'm going to import like so from sklearn dot metrics import accuracy score. Okay, fine. Now first just use a decision tree model and then use a random forest model. Okay, so for decision tree, DT is a good name. So decision tree classifier, and then DT dot fit X train and Y train. So I'm going to fit our data. Okay, so yeah, I'm able to fit it. Then prediction. It's time for making a prediction. So how I'm able to make a prediction? So for making a prediction, we can take another. So I bred with a DT, and this is going to be
dt dot predict. Okay, and I'm going to predict on the basis of X test. Now evaluation. So evaluation with the help of accuracy score. So I'm going to print accuracy score, and this is going to be a white test and vibrate. Okay, so vibrate is not defined, so it is vibratity. Yeah, so 79%. Okay, so my accuracy score is 79%. Now I am going to build a model with the help of a decision tree and then check what is the result. Okay, so sorry, random forest. Okay, and then check whether I'm having like we are able to do some improvement or not. Okay, so here I'm going to change with RF, and this is also going to be a decision tree classifier. Sorry, random forest classifier, and this is going to be RF as well. Then prediction. Okay, so again prediction. So for prediction, I'm going to take Vibrad RF, and Vibrad RF is going to be RF dot predict with X test. Okay, and then it's time for the final evaluation, and then check what is like a result. Okay, whether we have some improvement or not. So in place of DT, just replace it with RF, and I am getting 86.92%. Okay, so means a random forest performing much better in comparison to decision tree in this for this data set. Okay, and we have a reason, because we are trying to combine multiple decision trees together. Okay, so a plain decision tree definitely may not have may not produce that kind of an accuracy which multiple decision trees can make. Okay, so a multiple like the ensemble of multiple models can give you a much better accuracy, a much better performance in comparison to a plain model, and this is what we are able to see in this place. Okay, so guys, this is it from like a decision tree and random forest. Now the next session we are going to talk about, I'm going to talk about okay, so we are so till now we are able to do this do some kind of stuff with the structured data. Now in the next session, maybe we are going to start with the deep learning models. I'm going to talk about one unstructured data. Okay, so with this, thank you so much, and bye bye. Okay, hello all. So my name is Shivam, and now today I'm going to talk about end-to-end machine learning model, because we already learn about different kinds of machine learning algorithms, like in terms of in terms of regression and classification, and in so before starting the algorithm, before talking about the algorithm, I already talked that how the machine learning workflow are. Okay, so what is the workflow of machine learning? So I'm going to show you the entire pipeline. Okay, along with a problem statement with me. Okay, so along with so I have a very beautiful problem statement which you can going to relate with a real life data or real world like a problem statement. Okay, so this is a problem statement from a bank. So this is a query, or you can say this is a query from a bank. So you can relate this problem with you can relate this you can call it as a real world problem statement. And so and so you can see that how machine learning how with the help of machine learning model we are able to solve this particular problem.
And I'm also going to show you that how you are able to deploy your model. Okay, so by after building a machine learning model, how you are able to deploy it. So after deploying a model, you are able to see, okay, so okay, fine, like suppose if you give a input, okay, so a kind of a web page you are able to generate. Okay, so deployment means a kind of a web page you are having, and that web page can work in any kind of a system. Okay, so anyone can like take that web page, and they can push their information, push their input, and then a machine is able to predict, or machine is able to produce an output. Okay, so now let's talk about let's start with the problem statement. Okay, so let's start with the like what is my problem statement. So my problem statement is I need to I need to make a model which can predict, which can automate the loan prediction system. Okay, so what do you mean by a loan prediction system? It means that suppose anyone who's asking for a loan. Okay, so maybe there may be there may be a person who's asking for a loan to a bank. Now bank wants to automate this system. Okay, so they doesn't want that okay, so it will take manually, or it will take in some written format or what. Just bank just want to automate this whole system of what you can say loan of loan prediction. Okay, so whether the person is applicable for taking a loan, or the person who is applying for this loan is applicable for it or not. Okay, so bank wants to automate this strategy, and that is why he asked you as a data scientist to make a model, and your model is able to recognize, is able to predict whether the person who is applying for a loan is applicable, is authenticate for taking a loan or not. Okay, so this is a problem statement we are having with us. And now I'm going to this is a like company. Okay, so a dream housing finance company which actually deals in a home loans only. Okay, so particularly this dream housing finance company is deal with the in terms of a home loans only. So they give loans based on the like definitely maybe a lot of inputs. So whether you want a loan, you want a loan, a home loan. So maybe your home is in a rural area, or maybe in semi, or maybe in a urban area. So customer can apply, and company wants to automate the loan eligibility process at the real time. So at a real time, customer can put their input. Okay, so customer can give the input, pass their input to the system, and the system will able to predict whether you are able to eligible to take a loan or not. Okay, so fine, we are um, like we are good to go with this problem statement, and there is no issue. I think every one of you able to understand the problem statement according to me. Now let's start with building a model. So I already built a model. I go step by step. Okay, so I'm going to follow all 6 steps which I showed you at a time of machine learning workflow. So I'm going to follow like a complete pipeline in front of you, and you are able to relate these things. Okay, so the very first thing, the very first thing is you need to import the libraries. Okay, so this is the very first thing. And so right now I'm importing just basic libraries. Okay, so I'm not importing a library which is maybe related to any algorithm. Okay, so we are going to decide that which library we are going to take, or which algorithm is so we are going to decide our algorithm at a bottom. Right now we are just taking a basic libraries which is useful at like every place. Now I'm going to read my data set. So this is my data set, which like I copy the path of my data set from the drive itself. So this is my data set. And now after see into the data set, you can make your hypothesis. Okay, so like you have a loan ID, then gender, then a column of married, so whether the person is married or not, then dependents, then education, then self-employed, then applicant income, then co-applicant income. So I think this feature is very important, whether what is the income of a particular customer who's applying for the loan. Then the loan amount, again, this feature is also very important, and I hope and I can assume that this feature, applicant income and loan amount, is maybe highly relatable, or not highly, but it is relatable at some extent, because any customer who's applying for loan, so whatever the loan amount he definitely wants a loan amount which can be easily approved. Okay, and loan amount can be improved only if your income is good, and like if it is comparable with your income. Then loan amount term, so for how long you want this loan. Then credit history. So I think this feature is the most important feature, because okay, so as you at a time of building a model, building a hypothesis, you can build any hypothesis. So maybe if I'm working in a company, or maybe if I'm not working in a company also, so maybe if I'm having a knowledge of like a bank, or if I'm having a knowledge of this loaning system and all, so I can easily make this kind of an hypothesis. So like credit history means what, like if it is written 1 and 0, it means whether you are having some credit history or not. Like okay, so so did you have any kind of a debt? Okay, so a company actually want to ask you that did you have any kind of a debt on you. So when you are applying for a loan, so is it they definitely, so people are taking like so many debt. It is not like they are only taking a loan for building a home. So you may be taking a loan for buying a car, or maybe you are having some kind of a debt, or maybe for educational purpose or something else. So company wants to know that whether you are having some debt or not. Okay, so this might be a most important feature in my point of view. You can take your. Okay, then property area. So where, yeah, I think this is already mentioned in a problem statement, that where your like where your property is, from where you belong. Then a loan status. So I think this is a target column. Loan status may be yes or no. Y and N. So Y indicates yes and N indicates no. So fine. Now with the info, I'm able to check the information about my data set. So I'm able to check what are the data type of my data set. So I think 8 columns are object, means a string. So I think we need to convert this string into like a numerical data. Then one integer is there. So applicant income is in the integer, and then 4 floating point numbers are there. Okay, so these are all like numerical values. So 5 numerical values are there, means 5 numerical columns are there, and 8 categorical columns are there. Okay, fine. And you are able to check that there are very little null values are also present. Okay, so not so much little null values, but there are very few null values are present in few columns. Okay, so fine. We are going to check this thing alone, and we are going to solve this problem. But now I'm proceeding by dropping the loan ID column, because the loan ID column is not relevant at all. Okay, so loan ID column is not going to give you any kind of information. I think this simple assumption we can make by ourselves. We did not need any kind of perform any kind of function to check this, because loan ID is just a ID of each customer. Then again, so now I'm going to start with the exploratory data analysis. So in a machine learning workflow, if you remember, so there are like 6 steps. So the very first step is you need to understand the business you need to understand the like problem statement. Okay, so that is the very first thing. Okay, so business understanding is the first thing which you need to understand. Okay, so I think we are clear with our problem statement. Problem statement is very easy to understand. Then the second important thing is you need to make your own hypothesis. So I think I already make 2-3 hypotheses in front of you itself. Right now itself, you can make your own. And the third step is exploratory data analysis. So exploratory data analysis means we need to explore the data. We need to analyze the data. Okay, so exploratory data analysis is important. So we are going to perform an EDA. And then the fourth step is we are going to perform a feature engineering, then a data pre-processing, means you can data preparation, you can call it. Then fifth is model building, and the last one is evaluation. So I think these are the 6 steps which we already discussed. So now we are going to implement our third step, which is exploratory data analysis. So the very first thing which I'm going to check is what percentage of data is belonging to yes, what in total, I think we have total 614 customers. So out of 614 customers, how many customers are belonging to yes, like how many percentage of customers are belonging to yes category. Okay, so how many how many loans are approved, and then how many customers are belonging to no category. Okay, so these two things we need to understand on the very first place. We need to analyze on the very first place. So we are going to analyze this thing with the help of pie chart. Pie chart gives you a very beautiful overview. Now this pie chart is going to give you we are able to see that with the help of pie chart that in total 68.7% of people, or 68.7% of the customers loan are approved, and only 31.3 customers of loans are not approved. Okay, so like most of the loans, most of the applications are approved in comparison to rejection. Okay, so most rejection are lesser in comparison to approval. And you can write your observation. So I didn't write my observation over here, but I will give you the GitHub repository if you want. So you can write your observation by seeing mine, or by you can directly write by yourself also. That above pie chart show you that around 69% of the loan has been approved. Okay, so around 69% of the loan has been approved. This is true. While 31% of the loan application was not approved, which means about 2/3 of the applicants have been granted loan. Okay, so this area covers 2/3 part of the whole area. Okay, fine. Now I'm going to perform some univariate analysis. Although univariate analysis are very boring, but it will give you definitely some analysis that in your column more females are there in comparison, sorry, more males are there in comparison to female. Then there are more couple, there are more couple in comparison to bachelors or individuals. Then there are more graduates in your data in comparison to non-graduates. And if you see a self-employed, so no, so more non self-employed customers are there in comparison to self-employed. And then at last you are able to see that most of the people are belonging to semi-urban areas. So most of the property area is from the semi-urban background. Okay, now this is a good analysis. We are going to make a bivariate analysis. So bivariate analysis gives you a much beautiful graph and even much better understanding and much better analysis. So if you if you see the first graph in a gender column, if you try to make a comparison of your gender column, if if you try to make an analysis between a gender column and a loan status, so you are able to see that even we already know that most of the customers are male. Okay, so in your data itself, approx 3 times more males are there in comparison to female. So you can observe this thing that male applicants had more chances of getting a loan in comparison to female, because the number of male is higher. So this is very obvious. Now if you see the marital status, now here the data is not the fluctuation is not very high. So but the couple, like a married, 2/3 population in the data set is married, and married applications are more likely to be granted loans. Okay, so married people having a benefit, having a benefit in comparison to non-married people in terms of this a home loan system, not in others. Then about fifth, if you see the third observation about education, fourth observation, sorry, so about 5.6 of the population is graduate, and graduates are again having a higher proportion of loan approval. Then in terms of employment, applicants who are not self-employed has higher chances of getting loan, then applicant with a credit history are far more likely to be accepted. And the last one, more applicants from semi-urban are likely to be granted loans. Okay, so fine, these are our 6 observations from this 6 graph. Now I am going to make a correlation matrix on a numerical data only. Okay, so I'm not going to make a matrix on categorical data also. I am going to make a matrix only on the numerical data, and you are able to see, as I already told you, that there is a correlation between applicant income and loan amount. So yes, I am having a correlation 0.57. So it's a positive correlation, like a positive relation between a loan amount and applicant income. Even there is a positive relation between a co-applicant income and loan amount, but this value is very much less in comparison to this. Okay, so there is you can say a direct relation, like a very good positive relation between a applicant income and a loan amount. Now let's perform some feature engineering task. I think we are done with our EDA part. We done with the EDA part because we checked the like kind of insights hidden in categorical data also, and we check the kind of an insights which we can extract from the categorical data also. So we check both the column, we check both types of a column, and now it's time to uh, perform the feature engineering task. Okay, so it's time to pre-process our data. It's time to like prepare our data set to so that we can easily build a model. So fine, let's check this. Okay, so I think first we are going to check the null values, that how many null values are present inside my data set. So you are able to see that we are having so many null values over there. So in gender column, I'm having not so many. I'm just having a very few null values in each and every column, but I'm having null values in each and every column. This is the this is the like a kind of a thing. Not each column, maybe 2-3 columns are left, but in most of the columns I'm having null values. Although those null values are not going to affect your data set because the null values are very less in numbers. So and you're not going to think so much about this null values, because you need not to think so much about these null values, because there is a reason behind it, that the null values are very less in numbers. Okay, so you can fill the null values with just you can say you can say with a very simple method. Okay, you need not to think about any extraordinary method, or maybe like some methods which we generally not define. So here you only need to you can fill the null values of numerical columns with a mean, and you can fill the null values of categorical column with a mode. So that is what we are doing over here. So we are going to fill the null values of categorical column with a mode, and we fill the null values of in numerical columns with a mean. And now you can see that you don't have any null values. So I'm free from the null values. Now it's time to handle the categorical variables. So in most of the categorical data, you have just 1 and 0. So and we also know that what this 1 and 0 indicates. So we can simply uh, replace your categorical data with 1 and 0. Like in case of loan status, we can replace Y with 1 and with 0. In case of gender, we can replace male with 1, female with 0. And there is one column which is your what I can say property area. So there is 3 columns: property area, and education, and dependent. So these 3 columns, in these 3 columns, I just apply a label encoder. So it is up to my choice. So whether I can do even I can do 1 or 0 in this cases also. But if I'm not confident that that I can replace it with 1 or 0, so I can just perform a label encoding task. Okay, so label encoder is also a technique, and with the help of this technique, we are able to convert you with our categorical data into the numerical one. So I think now finally we have all the features with a numerical values. Okay, now I'm going to prepare my data set. So how I'm going to prepare my data set? So inside X, I'm going to take the columns which is important for us. Okay, so all those columns which are important for us. So I'm just going to take a gender column, married column, applicant income, loan amount, credit history. So I found these columns as so based on my hypothesis. Although if I'm not getting a much accurate result, or if I'm not getting a very good accuracy or maybe a performance, so I can introduce more features, or I can add some more columns from this column itself. But right now my understanding is that with this 5 columns I can easily make my model, and my model is going to give me a good accuracy. So this is my this is my own intuition. So I'm going to perform in this that way. So I just separate split the feature and target, and after that I'm split in training and test data. Okay, so I keep 80% data for the training purpose. So on 80% of the data I'm going to train my model, and on 20% of the data I'm going to test it. Okay, whether my model performing good or not. Now I think the fourth step of my machine learning workflow is also completed with this. Now the fifth step is we need to build a model. So we need to select the best model, we need to select the best algorithm, and we need to implement that algorithm. So in my opinion, the best algorithm which you can choose for this data set is a decision tree. Now why I'm choosing a decision tree for this model? Because decision tree is a highly interpretable. First thing, the very first thing that we can with the help of some library, we can also see that which feature is really important, and which feature is which feature which feature is considered as a root node. Okay, so root node means which is having a high information gain. So I'm going to see those things, I'm able to observe those things in case of a decision tree. So that is the very first thing why I'm going to choose a decision tree. And the second thing is we need not to worry about scaling and all at a time of decision tree, because decision tree do all this stuff internally, and we need not to worry about these things. And even decision tree is much better, and it is giving us much maybe a much better accuracy in comparison to you can say other models. Okay, so you can say in comparison to SVM, logistic regression and all. Okay, now this is so I'm going to import a decision tree classifier, and along with this, so I'm performing a fifth and sixth step together. So along with this, I'm also going to evaluate my model. So for that, I just import accuracy score and even a F1 score. Okay, so after fitting my training data on this classifier, I'm just trying to make a prediction. So ypred is equals to classifier dot predict. So I'm going to make my prediction on the test data, X test, and then I'm going to find out the accuracy score. So my accuracy score is 78.8, which is 79%. And even my X1 score is much better. It is 85.8. So I can clearly state that my data, the performance of my data set is very is not very, but yeah, it is good enough. So we are not we did not need to change the model. Even we need not to change we need not to make so many changes, because my model accuracy and my model's performance is good. And now we are good to go with this. We can deploy this model, because 80% or 85% F1 score is considered to a very good F1 score. Okay, so fine. And even I can show you the interpretability. So yes, as I told you, and even as I take a measurement that credit history may be the most important feature. So yes, the decision tree model also find that credit history is the most important feature. Okay, so credit history is the most important feature. So this is that is why they select credit history at a root node, on the root node, and then a loan amount, and then maybe a married. Okay, now it's now I think all my 6 steps are completed. So we can save our model. we can save our model in a file like in this place only. And now it's time to build our application. It's time to build also. You can consider it as a 7 step. So suppose it's in somewhere, if you want to build a web API also, so you can also add this in your machine learning workflow, in your machine learning pipeline. So I'm going to build a web API also. I'm going to build a web page, and with that web page, the things are pretty easy to understand for non-technical, non-tech people who is from the non-tech background. So they can also understand that what kind of a model it is. Okay, so I'm going to deploy my model. I'm going to deploy my model by using a Streamlit function. Okay, so Streamlit is a library, or Streamlit is a kind of a thing which is available inside a Python, which is very beautiful and easy to understand. So like so suppose if you are trying to deploy your model, so what you can do, so you can like use a Flask API, or you can build a REST API, or you can build maybe a Django or something. But in each and every scenario, or in each and every case, you need to build the web page from the scratch. Okay, so you need to have a knowledge of HTML, then you need to have a knowledge of CSS and all. So you need to use that knowledge, and by using that knowledge, you need to build a particular web page. Okay, but in case of a Streamlit, okay, so if you know a Streamlit, if you have a knowledge of Streamlit, so you need not to care about all these things. You need not to care about this kind of scenario, and you need not to care about this kind of a scenario. And you even you can build like you can deploy a model just by just by writing some line of a code. And with that line of a code, your HTML and CSS background is also created, means your whole web page is created within the Python code itself. Okay, so you only need to have a knowledge of Python, and Streamlit helps you to build like a web page for you. Even so, there is another library also, which is PyNgrok. So PyNgrok is also helps you to so generate that beautiful website. Okay, so like in terms of color and all, so a beautiful background and beautiful website. So PyNgrok helps in that place. Okay, so I'm going to import PyNgrok also, and I'm going to import your Streamlit also. And then there is a key. Okay, so you can't use my key. You need to you need to have your own key. So if you search for a PyNgrok in a Google, so you can go on to that page, and from that page you can take your key. Okay, so fine. Now this is a code for through which you are able to generate the web app. Okay, web page. Okay, so you need to import Streamlit as ht, and you need to import pickle because you saved your file in the like pickle format. So now you are going to train load your training model. So the model which you save over here, you are going to train you are going to open this model. Now you are having a 5 columns: gender, married, applicant income, loan amount, and credit history. So you are just need to give like a kind of input, because gender can be a male or female. So it will be 0 and 1. Then a married, then a credit history, and then loan amount is in the number. So you need to write a loan amount itself. Now you need to make a prediction. So from where you can make a prediction, so you need a classifier dot predict, and on the basis of this 5 feature, you need to make a prediction. And if a prediction equals to 0, it means rejected, and if it is 1, so it means approved. Now this is your HTML code. So I think each and everything you are able to make in this place only. Okay, so here you are going to give a background color, so you can change the background color even. And here you are going to give H1 your heading, automated loan prediction app. So this is the heading which I have given. Then you are going to give a boxes. Okay, so because you need to show something. Okay, and then a final box is going to show you the result. So fine, I think this is very easy to understand. So I'm able to make my app.py. and now I am going to deploy it. Okay, so let's see whether it is giving you a correct result or not. So attackers may trick you into doing something dangerous like installing software or personal information, for example, password, phone numbers, or credit card. Learn more. Okay. Okay, let me check whether my ngrok keys are changed or maybe something. So this is like from where you can use your authentication key. Okay, so you are not going to use my key. Okay, so this is like you need to go on the ngrok and then you need to sign up and then you need to log in. So this is my key, I think. Okay, so auto taken. Okay, I think this is my key. Maybe the key is changed, so that will create a problem. Let me check. If it is not changed, then we are happy to go. Okay. Okay, so the problem with the key itself. Okay, so if it is with you also, so just go and change your like authentication key. Now I am a male, so my marital status is unmarried. Then my applicant monthly income is, so okay, so fine, I can make it as 45,000. Then I maybe want a loan of 10 lakh. Okay, so fine. And then no unclear, so I'm have yeah, no unclear debt, so I don't have any kind of a debt on me. Now I'm going to predict, so my loan is going to approved. Okay, so fine, this is a very good thing that my loan is going to approved because I don't have any unclear debt, so it is not giving me any kind of a problem. Suppose if I change it to unclear debt, so maybe it is not going to approve my loan. Yeah. Okay, so fine. And after completing this, always kill your application, because if you not kill your application, so it is not next time when you run it, so it will show you the problem. So again, you need to go and change your key and all. Okay, so fine, this is like complete end-to-end machine learning model, automated loan prediction app. Now you can just use this URL and you can like now anyone can understand this thing very easily. So this is all like from my side. A complete end-to-end machine learning model is implemented in front of you. You can use it to make you can use this knowledge to build another machine learning model, maybe some based on some other problem statement. Okay, so this is it from my side, guys. Thank you so much, and I hope the whole thing is thing is very good, and you are able to understand, or you are able to understand, you are able to get a lot of knowledge from this session. So thank you so much. And yeah, just try all these things and just try to implement your own machine learning model based on the knowledge you are having right now. So build your own machine learning model and just deploy it by using Streamlit, and you can show it on your GitHub. Okay, so you can push those things on your GitHub repository. Okay, so fine. Thanks a lot. Thank you so much.